All right, so we are in great shape so far. We've connected to our source data, we've wired up our entire data model. Now, the only catch is that we're still pretty limited in terms of the metrics or quantitative values that we can analyze here. It's really just sales quantity and return quantity. So what we're going to focus on in this section is using Power BI's formula language, data analysis expressions, or DAX, to build out brand new calculated columns and measures. We have a lot to cover in this section, so let's dive in. All right, time to officially meet DAX. Now, DAX, otherwise known as Data Analysis Expressions, is the formula language that drives Power BI. So with DAX, you can add calculated columns and measures to your model using pretty intuitive syntax, and you can go well beyond the capabilities of those traditional A1 style grid formulas that you may be used to in Excel, using these powerful and flexible functions that are built specifically to work with relational data models like we're showing here in the AdventureWorks project. So there are two key ways to use DAX. Number one is to create calculated columns that actually live inside of your tables. And two is to create measures which are used in your visuals. So we're going to dive into each of these in turn, compare the two against each other, talk about exactly how they're operating, and then dive into a bunch of the most common and powerful DAX formulas. So a lot to cover. Let's go ahead and dive in. So I want to start with calculated columns because they're a bit more user-friendly, a bit more intuitive, especially for people coming from an Excel background. So simply put, calculated columns allow you to add new formula-based columns to the tables in your Power BI file. A couple important things to note. Number one, there's no A1 style references. You can't point to cell D16 or cell B5. Calculated columns refer to entire tables or columns. Next, calculated columns actually generate new values for each row in the table, and those values are actually visible within your tables in the data view of Power BI. And then third, calculated columns understand something called row context. What I mean by that is that they can see the information in each row in which they calculate, and so they're great for defining things like properties based on information in that row, but they're generally useless for things like aggregation, like sums or counts or averages. So important note here. As a rule of thumb, you're going to use calculated columns if you want to stamp static fixed values to each row in one of your tables. Or you can also use the tools in the query editor to do the same thing in many cases. What you don't want to do is use calculated columns for aggregation formulas or to try to calculate numerical values to use in the values area of a visualization. We'll be using measures for that instead. So pro tip, calculated columns are typically used for filtering data, giving you new fields that you can use to create those filters rather than creating or defining new numerical values. So let's walk through a couple quick examples. Here we've got two different tables, and in each case we've created a new calculated column. Now you'll note the DAX formula in the formula bar at the top, right above the table preview. And here in this top example, we've created a new calculated column that we've named parent, which equals yes if the total children field in that table is greater than 0 and no otherwise. And when you read through this formula in the top left, you'll notice that it looks very, very similar to Excel. So that same kind of user-friendly syntax. Now remember, since this calculated column understands row context, a new value is calculated in each row based on the associated value in the total children column. So what we're doing is cycling row by row by row, looking at the row context and returning the proper value based on the formula. So this is a valid use of calculated columns. Creates a new row property that we can now use to filter or segment any related data within the model. So we can grab that parent field, pull it into a visual, and break down our numerical metrics or values to compare data for parents versus non-parents. In this second example here, we're actually trying to use an aggregation function, in this case a simple sum of the order quantity field, to create a new column named total quantity. But here's the thing, since calculated columns don't understand filter context, and we'll get into that a bit more, the same grand total is returned in every single row of the table. So it doesn't matter which row you're in, whether you're calculating the value in row 1, 2, 3, or 4, in every single case, the sum of the order quantity field is the same sum, the same total. So this is not a valid use of calculated columns. We've essentially just taken that grand total and we've stamped it into the table in every single row. And in doing so, we've created this static column of numbers that can't be filtered, sliced, or subdivided any way. So for something like this, teaser alert, we're going to be using measures, the other important application of data analysis expressions. So let's quickly hop into our Power BI file and run through a quick demo for ourselves. Okay, so once you've opened up your AdventureWorks report, head to your data view and click on the sales table. Got my order quantities. And if you'll remember that earlier in the course, when we covered the query editor, we used that conditional column tool to create a new column called quantity type that was based on the order quantity here. So any rows where the order quantity was greater than 1, quantity type took a value of multiple items. Otherwise, it took a value of single item. So I'm going to quickly show you how we could have created the exact same calculated column here using DAX as opposed to using the tool within the query editor. So again, one of those common themes that we'll see time and time again, multiple approaches to solving the same problem in Power BI. So what I can do is right click, add a new column, and right up here in the formula bar is where I'm going to write some DAX. Don't worry about the syntax quite yet. We're going to dive into exactly how DAX formulas are written and then do a ton of demos with some of the most common functions. But for now, the focus is really just on when and why to use calculated columns instead of measures. So for the sake of example, we can name this quantity type equals, and now start typing our function. And in this case, we're going to use an if function. So if, and I'll start typing the name of the column. DAX uses something called IntelliSense, just like Excel formulas autocomplete. It provides a list of my options dynamically as I'm typing. In this case, I want AW sales order quantity. Just double click to lock it in. So if order quantity from my AW sales table is greater than 1, comma to my result if true, which is multiple items in quotes, comma again to my value if false, which is single item. Close the parenthesis, press enter, and that will lock in my new quantity type column here. So again, same exact logic that we used when we created this column in the query editor, except this time we've done it on our own using DAX. And if we scroll down, we see our single type items here, and then we've got some multiple type item categories where the order quantity is greater than 1. So it seems to check out. That is a valid use of a calculated column. Now, if we were to add another calculated column, new column, and this time name it something like total quantity, and give it an aggregation function like the sum, of AW sales order quantity, and enter that. Just like we showed before, we get that exact same duplicate total stamped on every single row, because in this case, the row context is meaningless, and the sum of that quantity column is always going to return that same grand total of 84,174. So again, let's delete it. This is not a valid use of calculated columns. What we want to use instead for something like that is a DAX measure, which we're going to talk about now. All right, next up we have the incredibly important topic of DAX measures. Now, by definition, measures are DAX formulas that are used to generate new calculated values. So a couple important things to note about measures. Like calculated columns, they reference entire tables or columns. So again, no A1 style or grid references like you would use in Excel. But unlike calculated columns, the measure values aren't actually visible in your tables. In fact, you can only see measure values within a visualization, like a chart or a matrix. So for those of you with Excel backgrounds, think of measures the same way you'd think about a calculated field in an Excel pivot. That calculated field doesn't exist anywhere else. You can't see it in tables. You only see it within that Excel pivot table itself. Now, measures in Power BI operate the same way. You can only see them when you drag them into the values field of a visualization. So while calculated columns were evaluated based on row context, measures are evaluated based on filter context. It's a little bit of a tricky concept to wrap your head around, but what I mean by that is that these measures, the values they take, constantly recalculate whenever the fields or filters around them change. So if you drag a new field or dimension into the row or column labels of a matrix, or if you apply new filters to your report, in each of those cases, you're changing the filter context and you're changing the value that that measure should return. So to summarize, as a rule of thumb, you're going to use measures, not calculated columns, when a single row isn't going to be able to give you an answer. In other words, when you need to aggregate. And a pro tip for remembering this, remember that measures are used to create numerical, calculated values that you can analyze in the values field of your report visuals. So if we actually look at the report pane in our AdventureWorks file, you'll see that we've actually already been using measures. We just didn't know we were using them quite yet. And the way we used measures was simply by dragging those fields into the values pane here. And you'll note that this little arrow tells us that we're looking at the sum of this particular numerical field, order quantity. And what we've done is actually create an implicit measure by doing that. So we're going to talk about implicit versus explicit measures in a bit, but check it out. You've already got a head start on understanding how measures work. So with that, we've done our intro to measures. We've done our intro to calculated columns. Let's take a minute to compare the two side by side and then move on and get a little bit deeper into how DAX really works. Let's take a minute and walk through a quick recap of calculated columns versus measures in one place. So on the calculated column side, these values are calculated based on information from each row of the table. They have row context. Measures are calculated based on information from filters in the report. They have filter context. Calculated columns actually append static values to each row in the table, and it stores them in those tables within your model. This increases the file size. Measures, on the other hand, don't create new data in the tables themselves. Therefore, they don't increase file size in your model. Calculated columns recalculate on data source refresh or whenever changes are made to the component columns in the calculation. Measures recalculate in response to any change to filters within the report. In other words, any time that filter context changes. And then calculated columns are primarily used for things like rows, columns, slicers, or filters. You often use them as dimensions to change the way you're viewing your data, whereas measures are almost always used within the values field of a visual. So when you create calculated columns, they live inside of the tables, and when you create measures, those measure values live within the visuals. So there you have it, quick cheat sheet for calculated columns versus DAX measures. So a quick note about adding calculated columns and measures to a Power BI file before we actually get our hands dirty and start creating some of our own. There are two options for adding columns and measures. Option one is to select either new measure or new column from the Modeling tab, and option two is to actually right-click from within the table in the data view or the field list, which is available in either the data or the report view, and choose to add a new measure or column from that menu. Now, there actually is an important difference between the two approaches. When you insert columns or measures using the Modeling tab option, they'll be assigned to whichever table is currently selected, or the first table in the field list by default. Now, when I say assigned to a table, I basically just mean this field that we're creating, it has to live somewhere. It has to be organized somewhere within our data model, so we can determine what its home table should be. So for instance, measures that are related to sales would likely go into our sales data table, whereas calculated columns related to customers might live in our customer lookup table. It's purely an organizational tool, no impact on actual functionality. Now, if you accidentally insert a measure from the Modeling tab and it gets placed or assigned to the wrong table, Not a big deal at all. You can easily reassign those measures or columns to new home tables using the properties options within that modeling tab. But going with option 2, actually right-clicking within the table or the field list, lets you be a little bit more deliberate about placing them. So that's the approach that I'm going to use and that I would recommend that you use as well. Now on the right side of the screen, you'll see a third option there called New Quick Measure. Now when you select the Quick Measure option, you'll see this big dialog box show up with a bunch of calculations and a new field list embedded in that dialog box. And what you've got here are basically like recipes with different calculations to perform different types of analyses. Average per category, weighted average per category, difference from filtered values, time intelligence, and so on and so forth. So the way I think about these is that they're basically pre-built formula templates that kind of help you drag and drop fields rather than actually writing any DAX from scratch. Now, if you've taken any of my other Excel courses, you've probably realized that I hate stuff like this. I feel like these types of tools, they can be helpful in certain instances, I'll give it that, but generally speaking, they kind of just encourage laziness. So they're almost like a crutch that people use to avoid actually learning and understanding the fundamentals of DAX. So if you're in this course learning from me, this is a no shortcut approach. We're just going to say no to quick measures from now on. So there's your summary for how to add columns or measures. Next up, we're going to compare implicit versus explicit measures and practice writing our first true measure in our AdventureWorks report. So I hinted at this a little bit earlier, but I want to take a minute to unpack this idea of implicit versus explicit measures. Now in Power BI, in the report view, implicit measures are created when you drag raw numerical fields like order quantity from our sales data table, into the values pane of a visual. Now what Power BI does is automatically select and apply an aggregation mode, usually a sum, so that you can view those numbers, those values, in a meaningful way. And that's exactly what's been going on with all of the values that we've been looking at in the matrix views that we've built. Now, on the other hand, explicit measures are created by actually entering DAX functions, or which we're not going to do, quick measures, to explicitly define calculated columns or measures. So, very important difference here. Implicit measures are only accessible within the specific visualization in which they're created. You can't reference that sum of order quantity anywhere else. Same exact idea as a calculated field in an Excel pivot table. It can only be accessed and analyzed in that place. But what's great about explicit measures is that they can be used anywhere in the report once you create them, and referenced within other DAX calculations to create more complex formulas, or something that we call measure trees. So for instance, if we wanted to take the sum of order quantity and then nest that within another function, like total orders minus total returns to come up with net orders or something similar, we would have to create an explicit measure in order to access those component values. So let's jump into Power BI and I'll show you what I mean. All right, so we're back in the report pane of our Power BI AdventureWorks report, just like we left it. And here we're looking at order quantities and return quantities by product keys. And now again, if you look at the actual details, you'll see that it's defaulted to an aggregation mode of a sum in both of these cases. And that's kind of the standard behavior when you drag in a numerical field like this. So let's get rid of return quantity, but keep this version of order quantity in here. I'm just going to drag this closer. And now the idea is that I want to create a proper explicit measure to capture that same idea, that same sum of order quantity. But I then want to be able to use and access that sum in other measures and calculations down the line. So I'm going to show you a couple approaches like we talked about. Number one, I could go into modeling and click new measure. And you see what happened when I did that? It created a new line item, a new field for this measure, and it placed it in the AW calendar lookup table, since that's the first one in our field list. And I'm trying to create a measure related to the sum of order quantity, so it doesn't make any sense whatsoever for that measure to live in the calendar lookup. which is why I don't recommend using that approach, using the modeling tab to create your measures. So instead of even typing it in here, I'm going to go ahead and X out, which just cancels that. And instead, I'm going to right click on the sales table or anywhere within the sales table. And I'm going to choose new measure from that menu. Now it's added the measure, assigned it to the sales table where it makes a lot more sense to live. So to define this, I'm going to give it a name. Let's call it quantity sold. And it's okay to use spaces in measures. They're always going to be reflected in formulas surrounded by brackets. So in this case, spaces don't really have any negative impact. And in fact, they can often make them a bit more readable. So we're going to do quantity sold with a space equals the sum of the order quantity column. And again, this IntelliSense, this autocomplete functionality is really user friendly. So I'm just going to literally start typing order. And I see that there are 4 columns within the AW sales table that begin with order. And we want order quantity. So I can either arrow down and tab, or I can click and then double click again to lock it in. So it's really as simple as that. The sum function has one argument. It's the column name. So I can close the parenthesis and press enter. And now looking over at our field list, it's created a new field here called quantity sold. Now let's grab that, pull it in right under our order quantity, and you'll see that it returns the exact same numbers, which is good. That's exactly what we want here. But again, the first version, the implicit version of this sum, cannot be accessed outside of this visual, whereas the measure version of the sum, which we've named quantity sold, can. And that's what makes it way more powerful and way more flexible. So one of the best practices that we're going to talk more about is to create explicit measures even for very simple things that you could define with the auto aggregation available implicitly. Getting in the habit of using explicit measures will only make things easier for you down the road. So there you go. That's a simple example of creating our first true explicit measure. If we did want to move or reassign that measure, this is where you do it. This little properties group in the modeling tab, you can just click the home table and assign it somewhere else. In this case, it makes sense to live in the sales table since we're aggregating a sales specific field. And you'll probably notice that you're seeing different kinds of icons next to the field in the field list. The one that we just created, the measure, has a little calculator icon next to it. That's always going to be your indication of a calculated measure, whereas the order quantity has that sigma symbol next to it because it's a raw numerical field. And you also have a different icon with the little FX, looks like a small table, that indicates a calculated column. So we have all 3 types here within our AW sales data. So there you go. That's your first explicit measure. Congratulations. All right, so we've talked quite a bit about filters in the context of our data model and how filter context can transmit through table relationships. But now we're going to talk about filter context and how it impacts DAX measures. So remember the definition of a measure. It's evaluated based on filter context, which means that those measures recalculate whenever the fields or filters around them change. So consider this matrix view on the left side of the screen. If we pinpoint one cell out of that matrix, we can understand exactly what filter context is being passed to that cell and therefore understand exactly how that measure is being calculated. So for this particular highlighted cell, we're calculating a measure called total orders, and it's evaluating based on the following filter context. The product name column from the product table is equal to touring tire tube, because that's the filter context passed to this cell from the matrix row labels. So this is pretty intuitive on the surface. This allows the measure, the total orders measure, to return the order quantity for each product specifically, or whatever the matrix row and column labels dictate. That could be years, could be countries, product categories, customer names. So again, pretty straightforward, but what might not be quite so straightforward is the fact that total or grand total values are not simply calculated by summing the values above. They're calculated as their own unique measures with no filter context. So in this case, since we aren't calculating orders for a specific product in the total row, we're essentially taking that filter context of product name and ignoring it. So it's a nuanced concept, but a very important idea, which is that each measure in a report behaves like its own island and calculates according to its own unique filter context, even totals and grand totals values. So as I was learning about filter context for the first time and really digging in and trying to wrap my head around what it really meant, what was most helpful for me was working through a number of different variations of examples. So let's take a minute to do that right now. Here I've got a sample view of a dashboard. This is a piece of a dashboard that we're going to be building in the next section of the course. And obviously you've got a lot of information here. You've got a matrix on the left, you've got donut charts, combo charts, tree maps, etc. One thing to pay attention to is this report level filter in the lower right that says year is 2016 or 2017. We're going to talk all about what those filters mean and how they work, but for now, all you need to know is that this filter applies to every visual and every number that you see on this entire report. So from here, we can actually pinpoint individual measure values to understand what filter context is being passed to them. So for example, this first case in the top left, we're evaluating a measure named total revenue. The filter context is that year equals 2016 or 2017, and that the full name from the customer table equals Mr. Larry Munoz. So with that filter context in mind, the DAX calculation for the total revenue measure evaluates and spits out the result that we see here. In this case, it looks like about $10,852 of revenue. Let's look at another example here. Now we're not looking at an actual numerical value. We're looking at a component of a chart, which is built from a value. In this case, this is a donut chart that's tracking total orders by gender. So the measure driving this segment of the donut chart has filter context of year equals 2016 or 2017, because remember, all visuals, all charts, all numbers in this report will be subject to that report level filter. And then the second piece of the filter context is that gender equals F for female. Similar case here, we're evaluating total orders again, got that same 2016, 2017 filter context. The only difference is that this chart is breaking down orders by occupation. So in this particular highlighted cell or segment of the donut, the second piece of filter context is that the occupation field in the customer table equals clerical. Moving down to the bottom left, here's an interesting one. In this case, we're looking at the total row for a measure called total orders. So even though this value lives in a matrix that's broken down by customer names, because this measure, this little island cell, needs to calculate the total, we're basically calculating orders in the absence of a filter, with the exception of that one page level filter that applies across the board. So that number, 22,534, reflects the total orders as defined by the measure formula for 2016 or 2017. Moving along to this trended view, where we've got columns capturing total orders and a line capturing total revenue by month. In this case, this highlighted column here, it's capturing total orders, years 2016 or 2017, and month from the calendar table is August 2016. So this one's a little bit interesting because you've got two different filters from the calendar table being applied. And in cases like this, it's the more specific filter that's going to take priority. Now, last example, looking at this card visual in the report. In this case, this number is acting almost like a grand total. There are no row labels or column labels or chart axes or visual level filters that would be impacting the value shown here. So what we're looking at is just the total revenue measure subject to those report level year filters. So hopefully these examples are helpful. I imagine that you're thinking to yourself, pretty straightforward, pretty intuitive. But the thing is, it does get a bit more complicated and a bit more interesting, to be honest, because these aren't static views. These are interactive, dynamic dashboards and visuals. And what I mean by that is that users can drill into components of this report and components of these visuals in order to drill in and explore this data in different ways. So you could drill in and isolate a specific row in a matrix, or drill in to filter down to a specific segment of a chart. And when that happens, more filter context is essentially being added to every single measure shown on the report. So what that means is that the context that we see here that we've listed out, this is just a snapshot at one particular point in time. But if this donut chart, for instance, that breaks down order by gender, was configured to interact with all of the other visuals in this report page, then that means that a user could potentially click on the female segment and add a new context to every one of these other measures that we've called out, as well as every other measure in the entire page for customer gender equals female. And if that user then drills deeper into a particular income level segment, that adds another line of filter context to every measure on the page. So as you can see, it can get quite a bit more sophisticated and quite a bit more complicated. That's why it's really important for us to nail down these fundamentals and understand exactly what's going on. So we're going to talk through a number of examples when we start writing DAX functions in the second half of this section, and then this will come into play in a number of different ways in the final section of the course when we actually start building visuals and reports. So stay tuned, some great stuff ahead. All right, so we talked about filter context, and we talked about how measures evaluate based on that filter context. But it's time to take a peek under the hood and try to learn about how this actual engine works. How are these specific measure calculations happening? So let's consider a simple matrix view like this. In this case, we're evaluating a total returns measure based on category names. And what we want to figure out is how this particular cell, this accessories returns number of 1,115, is calculated. So what I'm about to show you all happens behind the scenes, and it happens instantly every time the filter context changes. So I like to think of it as a three-step process, where step one is when the filter context is detected and applied. So this is where Power BI looks at the filter context for that particular value and says, okay, I'm being asked to only care about rows where the category name in my product table equal accessories. As a result, that product table gets filtered down to the point where you're only left with accessories rows. And from there, we move into step two, which is where that filter context of category name equals accessories flows to all downstream related tables. So if you had a model like this, where that product table were connected to two data tables, sales and returns, you would see both of those data tables filter down accordingly to only the product IDs where the category equals accessories. So you end up with filtered down versions of both of those data tables as well. And that brings us to step three, which is when the measure formula actually evaluates against that filtered table. So the measure that we're looking at here, what it's essentially doing is it's counting the rows in that returns data table, but not the whole thing. It's counting the rows of the filtered down version where the product category is accessories. And as a result, the number of rows that exist after the filter context has been applied is 1,115. So I'd recommend keeping this on hand just as a helpful reference in those cases where your measures might not be calculating as you expect them to. So with that wraps up the high level kind of conceptual part of this section of the course. From here, we're going to move into DAX syntax, operators, common function categories, and then get hands-on with a bunch of different examples. Okay, time to shift gears a little bit and shift our focus towards understanding the language of DAX. And we're going to start with the core syntax. So consider a simple sum function like this. Let's break this down into its component parts, starting from the left. In gray, we have the measure name. And like I mentioned, measures will always be surrounded by brackets when referenced in formulas, so having spaces here is okay. Now the next component immediately following the equal sign is the function name. Now, interesting note here, calculated columns don't require functions, but measures do. So a calculated column could have what's called a naked reference, meaning it points to a column on its own, not an aggregated version of that column. And that's okay because calculated columns evaluate row by row by row, so you could create calculations for things like discount price, like we practiced in the query editor, where you're essentially taking the value from another column, like retail price, and applying some sort of operation against it. On the other hand, you can't do that with measures. If you try to define a measure with a naked column reference, like transactions quantity, Power BI will return an error since it doesn't know how to translate that into a single value. So you need some sort of aggregation there. And then the last two components here are the table name in orange and the column name in blue. And this particular example reflects what's called a fully qualified column, since it's preceded by the table name. And like we talked about when we were working with the query editor, table names with spaces have to be surrounded by single quotes. So here's an example of what that would look like with or without a space. One piece of advice, pro tip here, when you're referencing columns, get in the habit of using the fully qualified name. So table followed by column. But for measure references, just use the measure name itself. That's a nice, easy way to differentiate column references from measure references within your DAX formulas. And there are some cases where that may not always make sense, but for the most part, that's a pretty good practice to follow. So moving on, let's talk about some common DAX operators. And most of these are extremely straightforward. You've got your basic arithmetic operators, addition, subtraction, multiplication, division, and exponents. Those pretty much speak for themselves. You also have your comparison operators, equal to, greater than, less than, greater than or equal to, less than or equal to, or not equal to. And I've shown some examples here as well. And then where it gets a bit more interesting is with the text and logical operators. And these ones are a little bit different from other formula languages that you may be used to. So one of the consistent ones is using the ampersand as a concatenation tool, where you can combine values to produce a single text string. But some of the newer ones are the double ampersand, which is an AND condition, or the double pipe, which is the OR condition. And on most PCs, you can find that pipe icon by holding Shift and pressing the key right beneath the backspace. And the fourth example here is called IN, which creates a logical OR statement based on an entire list contained within curly brackets. So, little hint, if you're only going to pay attention to a couple pieces from this slide, pay attention to these two, because these are going to come up a few more times with some of the formulas that we'll be writing. So from here, we're going to outline some of the most common function categories, then begin to add some new calculated fields to our AdventureWorks report. All right, last note before we shift into DAX demo mode, I want to lay out the common function categories. And most of these should look familiar to Excel users. These map pretty closely with Excel function categories, especially math and stats, logicals, text, and date and time functions. One area that is quite a bit different in DAX is the filter function section, which we'll dive into later in the section. But basically what we've got here in the math and stats category, your basic aggregation functions, your sum, max, min, average, count, etc., plus some interesting DAX formulas called iterators, which actually evaluate row by row. Sometimes those are called X functions because they all end in an X. Sum X, average X, rank X, max X, etc. And for Excel users, those work just like a sum product. More on that to come. Next up, we've got logicals, basically returning information about values in a given conditional expression. So these are all based around those if statements, if, and, or, not. There's a new one called switch, which is interesting. Then you've got very familiar text functions. These manipulate text strings, can also be used to control formats for things like dates, times, or numbers. And these should look very familiar as well. Concatenate or ampersand, left, mid, right. You've got capitalization rules like the ones we practiced in the query editor with upper, lower, proper, and then some useful options like substitute and trim as well. Now, filter functions, this is where things feel a little bit foreign and unfamiliar. These include lookup style functions based on related tables and table relationships in your model, and filtering functions to create more dynamic types of calculations. So the most common example of all is a formula called calculate, which we'll spend some time focusing on. The other ones that will really hit here are filter, all, and related. but tons of other options here as well. And then in the date and time category, you've got your basic date and time functions, as well as some advanced time intelligence operations. So your basic ones should look pretty familiar. Date diff, year frac, your component functions like year, month, day, or hour, minute, second. You've got volatile functions like today and now. And then time intelligence, this is really interesting. We'll do some cool demos there, like dates year to date, dates quarter to date, date add, and dates in period. These let you do some really interesting things like calculate rolling averages, year-to-date totals, and other date-specific comparisons. So big caveat here, this that you're looking at here is not a comprehensive list. There are many other DAX functions, some of which are more advanced, some of which are more specialized. There's trigonometry functions, parent-child functions, info functions. So the ones that we're going to cover here are some of the most common and some of the most powerful, but this will not be a fully comprehensive review of DAX. The plan here is to get you started with the basics and hopefully give you a deep enough understanding that you can begin to explore some more complicated, more advanced scenarios on your own. So with that, buckle up, it's time to start writing some DAX. All right, time to kick off our DAX demos. Now we're going to start by focusing on calculated columns first, since they're a bit more user-friendly, a bit more intuitive, and we're going to kick it off with basic date and time functions. So here's what we're going to be dealing with. Now, all you Excel users, this should look really, really familiar. These basic date time functions are very user-friendly, really simple syntax, so this should be a breeze. Starting with day, month, year, I call these component functions because they essentially point to a date and extract some specific component of that date, the day, the month, or the year. So syntax-wise, incredibly straightforward. You just point it to a column containing your dates and you're good to go. Same thing holds with hour, minute, second. The only real difference is that you have to point to a column with a date time component as well, because what these hour, minute, second functions do is they ignore the date and only focus on the hour, the minute, or the second of the timestamp component. Now today and now, those are volatile functions, which means that they update or refresh every time there's a workbook change, and those two functions return the current date or the current exact time, respectively. Syntax-wise, literally could not be simpler. This function doesn't even take a single argument. You literally open and close the parentheses, and you're all set. Now, weekday and weeknum, two of my favorite date functions here. Weekday returns a weekday number by default from 1 to 7, representing Sunday to Saturday, and weeknum captures the week number of the year. So for syntax, first argument is the date column, second argument is the return type, and this is where you can tell Power BI exactly how you want your weeks to start, whether it's a Saturday, a Sunday, a Monday, etc. Now, EO month, another really helpful one. I believe it stands for end of month because it returns the last day of the month, plus or minus a specified number of months. So here's what the syntax for EO month looks like. You point to a start date, and then you specify that number of months. So if you use a 0 for the second argument here, the EO month function will essentially give you the last date of that current month. If you use a -1, it would give you the last date of the previous month, and vice versa. Now, a little pro tip here, even though it's a bit of a misnomer, you can use the EO month function to return the beginning or the first of the month as well. I don't believe Power BI or Excel have any first of month equivalent functions, but what you can do is set that month's argument to -1 and then simply add 1 day, so +1, at the very end of the function. That basically calculates the last day of the previous month and adds 1 more day to give you the first date of the current month. And then last but not least, we've got date diff, returns the difference between two dates, but not only that, but it allows you to select a specific interval as well. So date 1, your start date, date 2, your end date, and your interval, which gets as granular as seconds or as broad as years. So a really helpful function for calculating the difference between two dates. With that, let's open up our AdventureWorks file and start adding some new date and time columns to our model. All right, so once you've opened up your AdventureWorks report, let's navigate to the Data tab. This is going to be kind of our home base for the next few videos as we create these calculated columns and measures to our model. And now make sure you're following along because we're going to be creating new fields, new measures that are going to be important for us to analyze and visualize once we get to the next section of the course when we start building reports and dashboards. So pay close attention, try to follow along step by step. Now the first demo that I'm going to use is the weekday function. So I can right click anywhere inside this table, really doesn't matter where, select new column, and it'll just tack that column right to the end of the table. So let's go ahead and name this day of week, and we're going to use the weekday function here. So as we start typing, you'll see that not only does the formula or function name populate, but a description populates as well. So really helpful tool tips and IntelliSense functionality that Power BI offers here. So I could tab to lock that in, and it takes me right to the first argument, which is the date. So let's go ahead and start typing to find that field. You can either type date, which gives us the option there, or we can type calendar to navigate to the table. Either way, it helps us find it. And then again, I can tab or double click to select that field. And now with date field specifically, this additional list of options appears. .date, .day, .month, and so on all the way to .year. And this is Power BI being pretty slick. It's saying, okay, I see that you selected a date field because it knows that calendar lookup date is formatted as a date. And it's giving us the option to either use the actual date itself by default or to use some aggregated component of the date like the month or the quarter or the year, just like those day, month, year functions actually work. But it's kind of embedded in here, which is pretty clever. Now, I don't have to select any of these options, or if I select .date, it would be redundant, but basically the same thing. In this case, I want to reference the actual date itself, so I'm just going to press comma, and it takes me right to the next argument of the function. Now remember, this is the optional component, the return type. You can see that it's optional because it's shown in brackets in that tooltip. And my options are 1, 2, or 3, where 1 is a week starting Sunday, 2 is a week starting Monday, and 3 is another week starting Monday, but from 0 to 6 instead of 1 through 7. So I kind of like defining my weeks starting on Mondays. So let's enter the 2 here, close the function off with a closing parenthesis, and then press enter to lock that function in. And there you go. You see we get 1s through 7s, where 1s are my Monday rows, 7s are my Sunday rows. So there you have it, pretty straightforward demo of the weekday function. Next up, let's actually collapse the calendar and navigate to our customer table. I'm going to scroll all the way to the right here. And you'll remember we have this birth year column, which we had actually calculated within the query editor. So we don't see any kind of DAX formula here, even though that was technically a calculated column. So what I'd like to show you is how we can create that same birth year column using DAX and then remove the original. So again, right click anywhere in the table, new column. I'm going to name this one birth year underscore CC for calculated column, just so that we can compare the two side by side and differentiate them. So birth year CC equals the year of the customer lookup birth date column. So I'll tab to lock it in, close the parenthesis, and press enter. And now when I scroll over, there it is, birth year CC against the original birth year. It all lines up, which is good. And you may have been wondering, can't we use that shortcut Power BI tip that automatically extracts the year without even writing a function? Well, yes, you're very sharp. You sure can. Let's go ahead and edit this, and I'll show you how to do this exact same calculation using a different type of approach. So instead of using the year function explicitly, what if we just point to the birth date field and then use Power BI's tip and say, just give us the birth date dot year, or just the year component of that date field. Press enter, scroll on over, and what do you know? Gave us the exact same correct values. So it's technically a third way to accomplish the same thing, calculating the birth year using the query editor or using both of those DAX or function approaches. Now, I want to show you one other interesting thing, which is obviously we don't need two birth years here in this table. So watch what happens when I right-click and delete the birth year column. Okay, so remember that birth year column that I just deleted, that column was added, it was calculated in the query editor. So there was an applied step that added that calculated column to the table. So now what you might be wondering is, every time we refresh this customer table, isn't that birth year column just going to keep appearing and appearing and appearing? And the answer, luckily, is no, because Power BI is very smart. Let me go to Edit Queries and navigate to that customer table, and check it out. It removed the birth year column as a new applied step so that it's not going to keep recreating that column. It knows that we just deleted it from the table itself in the Data tab, and so it saved us the trouble of having to delete it over and over and over. Now, the last date time demo that I want to show you, a formula to calculate the current age of our customers. So let's stick right here in our customer table, and for this one, let's practice the date diff function. So let's right click, new column. We're going to name this one current age equals, and we're going to start with the date diff. I'm going to arrow down and tab that one in. And now remember, 3 arguments: date 1, start date; date 2, the end date; and interval. So our starting date is the customer's birth date. So there it is, customer lookup birth date. I don't need any of these time components here. And then the date 2, the end date, is going to be the current date. So I'm going to use the today function, open close parentheses for that one, and then comma to my last component, the interval. And this says, okay, by default, I'm going to return the number of days between the 2 date arguments, the start date and the end date. In this case, we're looking for the current age in years, so we can just scroll right down to year, press tab to enter it, close the parenthesis, and press enter. And we scroll on over. There you have it. We've got current ages, 70, 69, 67, and so on and so forth. So a great way to use the date diff function in that example. And now, just for fun, I'm curious, if we change that last interval component, I wonder how many seconds old these people are. So you can close it off, change year to second. And there you go. It looks like our first customer here, Blake Flores, is just under 2.2 billion seconds old, which is not very helpful for the purposes of our analysis. And I don't think our AdventureWorks clients are going to care much about that, but kind of interesting to see. So let's go ahead and change that back to year, close it off, press enter, and now we have more appropriate ages there. So there you have it, just a little sampling of some of those basic date and time functions. We practiced weekday, today, and date diff. Next up, we're going to talk about logical operators and some conditional if, and or statements. Stay tuned. Next up, we've got basic logical functions. These are your if, and or types of statements. We're going to be looking at 4 of them here. Now, starting with the if statement checks if a given condition or logical test is met and returns one value if that condition is true, another value if the condition is false. So the syntax looks like this. There are 3 arguments, starting with the logical test. This is any Boolean test, meaning anything that results in a true or a false. It could be text-based, like country equals USA, or it could be numerical, like weekday equals 1, or retail price is greater than 10. All of those are valid logical tests because they all evaluate to either a true or a false. Now from there, our second argument of the if statement basically says, if that logical test is true, what value would you like to return? And then that optional third argument allows you to customize the result if that logical test is false. Otherwise, those rows will just show up as blanks. Next up, if error. This one evaluates a value or an expression and returns a value that you specify if the expression returns an error. Otherwise, go ahead and evaluate the expression just like you normally would. So it's a little bit wordy, sounds more confusing than it really is, but basically all you're doing is you're saying, if you get an error when you run this value or expression, instead of showing or displaying that error, display some custom value instead. Keep in mind that those errors can be very helpful and tell you some important information, so use it cautiously, but can be a great tool. Next up, we've got and it kind of speaks for itself. It checks whether two arguments are both true and returns true if that's the case, otherwise false. So syntax looks like this. You just plug in two arguments, two logical statements. Or is very similar, except instead of checking whether both arguments are true, it checks whether one of the two arguments is true. So same syntax, just using or instead of and. Now, important note about these two, I told you this was going to come up again. If you use the and or the or functions, you're limited to two logical statements. If you want to compare more than two statements or two conditions, you'll have to use either the double ampersand in place of and or the double pipe in place of or. Now, my tip for you is that using those symbols, the double ampersand, the double pipe, not only gives you more flexibility to work with more than two logical statements, but it's also a bit more readable when used in the middle of a function. I'm going to show you exactly what I mean in just a second. So that's actually a nice segue. Let's go ahead and pop into our AdventureWorks file and try writing some of these logical functions. All right, so once you have your file open, make sure that you're in the data view. And first things first, we're going to go into our customer lookup table, which I'm in right now. And the first thing we're going to calculate, just like the demo we saw earlier in the course, is a parent column. And the parent column will be a logical or conditional statement that looks at this total children field. And it says, all right, does this customer in this row have children? In other words, is the value in that column greater than 0? If so, we're going to call this person a parent. Otherwise, we're not. So great opportunity to use a simple if statement for that column. Let's go ahead and right click and add that new column. And let's actually just name it parent. This will be kind of a yes/no binary flag. And parent is going to start with an if. So if, and we're looking for a field with the word children. There it is, total children. Tab it in. So if the total children column from the customer lookup table is greater than 0, that's a valid logical test because it evaluates to only true or only false. Then I'll comma to my result if true. This means they have children, which means they are parents. So I can type yes in quotes because it's text, and then comma to my result if false. Remember, if I leave this blank, I'll see only yeses or blanks in the parent column. But instead of that, I'd like to use a no for the result if false and close the parenthesis. So when we hit enter to lock that in, we see that it's calculated. We scroll to the right, and there we go. We've got our parent field here. And if we scroll down, there's some no's where total children equals 0. So all looks good. There's your simple if statement. Next up, I want to calculate a column in our calendar lookup table. So let's head over there. And now the column that I'd like to add here in our calendar table is a column for weekend, which identifies weekends based on the days of the week. So we're going to use an if statement again, but now we need to integrate or as well, because a weekend is defined by day of week equal to 6 for Saturday or 7 for Sunday. So let's go ahead and see what that would look like. Right click, new column. We're going to name this weekend. And I'm going to start with the if or combination first. So we're going to lead with if, open the parenthesis, and now the logical test is where my or statement comes in, because I have two conditions that I'm testing for. And syntax-wise, it reads a little bit strange, but instead of writing condition 1 and then the word or, and then condition 2, I have to actually lead with the or here as well. So if or, and the same thing works with if and, where you now enter both of your logicals just separated by a comma. So if or, now my two logicals. The first one is looking for day of the week. So AW calendar lookup day of week equal to 6. No need for quotes there because 6 is a value, not text. And then comma to my second logical statement. Same idea. Calendar lookup day of week equal to 7. And my or statement is now complete. I've entered both logicals there. So I close the parenthesis to close out my or statement. And now I'm back in my if function. So I'll need to comma over to my result if true. So if either of these two logicals is true, day of week is 6, day of week is 7, then what value do I want my weekend column to take? Let's call it weekend. And then comma to the last statement, result if false. Rather than having non-weekend days show up as blank in this column, I'd like them to be labeled as weekday. Close quote, close parenthesis. You can see that it's highlighted my first parenthesis to tell me that I've closed out my whole statement, and that formula should be good. So let's press enter, and there we go. We see weekday, weekend for day 6, 7, Saturday, Sunday, all checks out. So that worked out pretty well. Now, just for the sake of demonstration, and because I actually prefer this approach over the one I just showed you, let's replace the if or approach with the double pipe or instead. So I'm actually going to delete this and write it from scratch just so we get a little bit more practice. So we're back to just our if. And this time I can actually write it in a readable way. So first logical test, if calendar lookup day of week equals 6. And now one thing to note, you can add spaces throughout the formula. So if that helps to space out the arguments or components, feel free to use those, and I'll try to do that just to make it as user-friendly as I can. So that's logical test 1, and now I'm going to hold shift and press that pipe under my backspace key and use 2 pipes in a row, which basically does the same thing. It serves the same purpose as an or statement, but I can insert it right in line between 2 logicals, or 3 or 4 or 5, etc. So if the day of week equals 6, or lookup day of week equals 7, and I can just comma since I didn't open up a new parenthesis with an or statement. Now I'm in my result if true as part of my if function. So if either one of these is true, weekend, otherwise result if false, weekday. Close quote, close parenthesis, enter, and there you go. Just refreshed, no values changed. We didn't expect them to. Which approach you use is totally up to you. If you're more comfortable with if or, that's fine. If you like using the double pipe, that's cool too. And just note the same exact logic applies if you're using and statements here. You could write it as if and, or you could write it with the double ampersand, just like we use the double pipe. So there you have it, calculated columns with basic logical functions. Next up, we've got text functions. Now, this is another set of functions that looks and feels almost identical between DAX and Excel. So those same left, mid, right functions, those same upper, lower, proper capitalization functions, same substitute, same search. So hopefully many of you are already pretty comfortable with these formulas. So let's quickly kind of breeze through these. Starting with length, returns the number of characters in a string. Simply point it to a column containing text and you're done. Concatenate joins 2 text strings into one. Note 2 and only 2. This behaves very much like the and or statements that can only take in 2 logicals. When you write out concatenate as a full function, you're limited to just those 2 text inputs, which is kind of silly and obviously restrictive, especially after going through all the trouble of typing that full concatenate function. So Just like you can use the double ampersand to replace an AND statement and give you more flexibility with logical statements, you can use the single ampersand to replace concatenate and allow you to combine many more than two strings. So when you think about it that way, I don't know why anyone would ever use the traditional concatenate function, because it's inconvenient to write and it's extremely restrictive. So best practice, just use the ampersand if you need to concatenate strings. Next, we've got some of my favorites, left, mid, and right. These allow you to return a number of characters from either the start, the middle, or the end of a string. Pretty simple syntax here for left and right. You point to a text column and then indicate a number of characters. Note that that's an optional argument. If you don't put anything there, it will return 1. So 1 is the default number of characters. For mid, there's an extra argument. You point to the text. You say, I want to start in character position 4 or 5 or whatever position you want, and then extend or return a specified number of characters from there. Upper, lower, proper, all capitalization stuff. Upper is all uppercase, lower is all lowercase, proper is the first letter capitalized. Simple syntax, just point to a text column. Then substitute, this one's kind of fun. You can replace an instance of existing text with any new text that you choose within a string. So this one has a few more arguments here. You start by pointing to a text column. You indicate the old text, or the text that currently exists within that string. And then the new text is what you want to replace that with. And then you also have this fourth optional argument for instance number, where you can tell Power BI, okay, I want to substitute my underscores with a dash, but I want to skip the first one. In that case, you can specifically target only the second underscore or only the third or fourth. So a lot of flexibility with that substitute function. And then last but not least, you've got search, which returns the position where a specified string or character is found. And by default, Power BI is going to read from left to right. So when you type this function, you're going to say, okay, I'm searching for this particular text string. That's the find text argument. And then within text is where you're looking for it. Generally, that's a column containing the original text values. And now those are the only two required arguments. So you may be wondering, okay, you're searching for certain characters or text within a string. But then if that's the end of the function, what is it going to return? And the result that the search function yields is a number. And that number indicates the position of the text if it finds it. So if, for instance, you said search for the word house within the text doghouse, that function would return a 4, since it found house starting in the fourth character of that larger string. Now you have two optional arguments as well. The start position, so you can indicate if you don't want to start at the very beginning of the string, you could, for instance, start 5 or 10 or 20 characters in. And then last but not least, you can indicate a value to return in cases where the characters or text that you're looking for isn't found. So let's jump back to our report and quickly try a couple of these out. All right, so in the report, head to your data view, as always, and let's go ahead and jump into our customer lookup table. Now, the first thing I want to demo is that concatenate function, and a great opportunity to do that is to replicate the full name, just like we created right here in the full name column using the query editing tools. This will be a good opportunity to show that we can do the exact same thing using a calculated column with DAX. So right click, you know the drill by now, new column, and let's name this one full name underscore CC for calculated column equals, and now remember the deal with concatenate. If I were to type out that full concatenate function, I would be limiting myself to only 2 inputs. And since I'm looking to concatenate or combine 3 fields here, the prefix, the first name, and the last name, concatenate is not an option. So I'm forced to use the ampersand, which is good news because I'd prefer to use it anyway. So all we're going to do is search for the first field we want, prefix, ampersand for concatenate. And now keep in mind, if I go ahead and just reference the first name right now, in fact, I'm going to do it as a demo, and then add another ampersand and reference the last name and press enter. When I scroll over, it worked, did exactly what we asked it to do, but the problem is that all the names are just blended together. So we really need some spaces in there as well. So it's an easy fix. Jump back into our formula bar, and now we'll say, okay, prefix, and then before we go and add the first name, let's add a space. So open quote, space, another quote, and then another ampersand. We're going to do the same thing between first name and last name. So first name and a space. Whoops, sorry about that. And our last name. Press enter. And scrolling over. There you go. Full name CC matches with our original full name column. Another good example of 2 ways to do the same thing. Now I'm going to show you one more demo, and for this one we're going to go back to calendar. And what I'd like us to do here is come up with a way to return a short version of the month name. So sometimes people shorten or abbreviate the month name with just the first 3 characters. So this is a great way to use one of those text functions, in this case like left. So let's go ahead and try that. New column. I'm going to call it short month. And that's going to be as simple as left, because we want characters starting from the left of a string, and the text column that we're pointing to is the AW calendar lookup month name. And then comma to my second argument. Again, the default would be 1 character. In this case, we want 3. So type a 3, close the parenthesis, press enter, and there you go. We get Jan, Feb, March, June, Aug. Looks good. But now it turns out that our AdventureWorks client hates lowercase short months. It's his pet peeve. He just can't stand it. So he insists that these month abbreviations have to be all caps. So lucky for us, we've got an easy function to help us do that. That's the upper function, one of those great capitalization functions. So all we need to do here is essentially wrap this whole function that we just created that yields these lowercase, or in this case, proper case, short months, just wraps them in an upper statement and capitalizes everything. So I'm going to insert my cursor right before the left. I'm going to type upper, open the parenthesis, leave the entire formula as my text reference because it yields a text value that I can then convert to uppercase, close the parenthesis, press enter, and voila, now we've got all capitalized short months, and AdventureWorks is going to be very excited to see that. So there you have it, a couple of quick demos of how to use text functions in calculated columns. So at this point, you may be wondering, why all the hype around DAX? All of these calculated column formulas that we've been playing with so far, the basic date and time, the logicals, the text functions, they're all pretty intuitive, pretty straightforward, and remarkably consistent with their Excel versions as well. So now that we've covered those basics, some of those fundamentals, it's time to start exploring some more interesting DAX functions. We're going to talk about one called related now. And in this context, I'm going to show you how to use related as a calculated column. And then later in the section, we're going to revisit this related function by nesting it within a SUMX measure, which is a really cool, really powerful iterator function in DAX. So this is where things are going to start to get a little more interesting and start to pick up pretty quickly. So related is a very simple function on its own. It just returns related values in each row of a table based on a relationship with another table. So syntax-wise, it's as simple as it gets. You literally just point related to a column name in another table that contains the values you want to retrieve. Could be a product name column, could be a retail price column, a country column, whatever it might be, as long as a valid relationship exists to that table where you'd like to retrieve the values. So tip here, related works basically exactly like a VLOOKUP function. It uses that relationship between the tables, which we've defined by our primary and foreign keys, to just reach into another table and grab the values it needs and pull them into a new column of another table. But the thing is, it works like VLOOKUP, but it's even simpler than a VLOOKUP because we don't need to define the lookup value or the match type or those other arguments that we need to include if we were writing a lookup in Excel. And the reason we don't have to define a lookup value explicitly is because Power BI already knows what your lookup value is because it understands the connection between your two tables. And that's why all you have to do is input the column name. Whereas in Excel, you're essentially defining what your primary key is within the VLOOKUP function. So here with related, because we've done all our data modeling already, that step is not necessary. One other note about related, this function does require row context because it needs to pull the correct value for each row of the table. So you'll only see related being used either as a calculated column, which I'm going to show you now, or as part of an iterator function that's designed to cycle through tables row by row. Things like filter, SUMX, MAXX, etc. Now, pro tip here, you may be thinking, okay, this concept makes sense, but isn't this kind of going against the normalization standards where we said we don't want to create redundant data like this? And yes, you're correct. Related does technically create redundant data. So it's important not to go overboard with related. You don't want to use this function to kind of hack your way into a huge merged table, but using it strategically to make certain fields more accessible is a valid approach as long as you're not bumping against file size or capacity limitations. That said, in many cases, you can actually replace the calculated column version of related by nesting it within a measure like filter or SUMX. And I'm going to show you that with SUMX in the iterator lecture, which is a really interesting one. So with that, let's pop back into our AdventureWorks file and try adding a new calculated column using the related function. All right, so when you open up your AdventureWorks report, head to your data view, and let's navigate to our sales table here. Now you may be realizing that so far we've been pretty limited as far as the numerical kind of quantitative values that we're able to analyze here. Really, order quantity and return quantity are the two most meaningful ones that we have access to right now. But we do have a means of creating many more interesting fields. And we're going to do that using related and using some of the measures that we'll talk about in the upcoming lectures. So for now, what I want to do is try to pull the retail price of these product keys into my sales table. And I can do that because related will allow me to access fields from any related table. And if we jump to our relationships view as a refresher, we know that sales has valid relationships to customer, to calendar, to territory, and to each of these product lookups as well. So what that means is that related is going to allow us to access any field from those lookup tables and pull it directly into a new column right here in my sales table. So that's what we're going to do here using retail price as an example. So let's right click, new column. Let's name the column retail price. You can add a space or not, up to you. And it's going to be as simple as related, and then point to the column name. And remember, I'm going to point to that column that lives in a related table. So the table that I'm looking for is going to be the product lookup. And here I can kind of just arrow down to look through my list of fields in that product lookup table. And the one we want is product price. So let's tab it in, close the parenthesis. That's the only argument. So we press enter and we're good. So there you go. We've got retail price. Right now it's not formatted properly. We can fix that in the modeling tab here. And we've got our formatting options. Don't have to go to the query editor. We can format right here in our data view. So instead of general, let's go ahead and choose currency, English United States. And that looks good. So as a quick QA, if we want to make sure that these prices map up to the retail prices in the product table, one quick way to do that, we could use a matrix view in the report, or we could do something like sort our product key here, ascending. So 214 has a retail price of $34.99. It looks like 215 has a retail price of $33.64. And now if we actually jump to our product lookup table and sort the product key ascending as well, now we can just make that comparison. The first row is product key 214, $34.99, 215, $33.64. So it checks out, and that's a nice little way to just do a quick spot check and make sure that related function is working properly. So back to sales. Now remember, we've essentially just pasted this data or replicated this data in a new place. It's nothing brand new, but this will allow us to now create some interesting new fields. For example, revenue. Let's right click, add a new column, name this one revenue. And now that within this table, we have quantities, we have prices, price times quantity equals revenue. So it's as simple as just multiplying those two columns together. So AW sales retail price times AW sales order quantity. We can press enter, and there you go. We've got our revenue. Looks like these are all quantities of 1, so the revenue is just equal to the retail price. And we can do a similar kind of spot check here and sort our order quantities. Let's actually sort descending. And there you go, 3 orders of a product that costs $23.55 yields a revenue of $70.65. So that looks good. This all kind of checks out. Let's go ahead and just for the sake of being consistent, let's format revenue as the same currency format as well. So there you go. We've used the related function to basically reach into the product table, grab the retail price, and pull it into a new column right here in our sales table. And from there, we use the values in that column to create a brand new field called revenue. So from here, we're going to shift gears a bit into measure mode, start with some basic math and stats aggregator functions, and then dive into some of the filtering tools that really set DAX apart. All right, so we've covered some of the core calculated columns with DAX. Now it's time to talk measures. And the natural place to start is with these basic math and stats aggregator functions. So usual suspects here, you'll see your sum, average, max, min, and a new one called divide, which I'll talk about in just a second. But these, for the most part, speak for themselves. Very straightforward. The sum evaluates the sum of a column. Syntax-wise, all you have to do is point to a column name containing values. Similar story with average, just returns the arithmetic mean of all the numbers in a column. Same syntax. Now for max, obviously returns the largest value, but you don't have to just point to a column. You could also feed a max function a list of scalar or specific values, and max will return the largest within that list. Same goes for min, exact same syntax, just returns the smallest value. And then divide, it performs division, but it also includes this alternate result, which is kind of like your value if error, kind of baked right into the formula. So numerator, denominator, alternate result. So really no surprises here. Let's spend most of our time in Power BI practicing some of these hands-on. All right, so I'm back in my AdventureWorks report, and keep in mind you can add measures in a number of different places. I could add them here in the report view, in the calculations grouping. I can add them anywhere I can see the field list, either report view or data view. Really doesn't matter where you add them. I generally like to add them in the report view because since measures won't actually be visible in our tables, the best way to QA and explore the values that our measures produce is using visuals like the matrix visual here. So let's get in the habit of creating our measures here in the reporting canvas. And like I mentioned earlier, rather than using the modeling tab, which sometimes assigns your measures to tables that you didn't mean to, we're going to also get in the habit of actually right-clicking the table itself or field within the table itself to deliberately organize where these measures are going to live. So to kick it off, I'm going to use the basic sum first, and there are 2 different measures that I want to create. The first is the quantity returned, or the sum of the return quantity from my returns table. So just like we calculated the quantity sold here in our sales table, we're going to calculate quantity returned in our return table. So again, I'm going to right-click the returns table this time new measure instead of new column, and it basically just adds a placeholder right here in the formula bar that says measure equals. So this one will be named quantity returned, and it's going to be quite simple, just your basic sum. I'll start typing return. So there we go. AW returns return quantity. That's the numerical field that we would like to sum. And it's as simple as that. Close the parenthesis, press enter, and there you go. You'll notice that all it's done is create a new field assigned to my returns table with that measure. But the only way to see the result of that measure is to visualize it. Pull it into the values field of some sort of a visualization, whether it's a matrix or a chart. So for instance, if I wanted to add a third column here in the matrix we've got, I can just grab quantity returned and pull it in as a third column of values here. And because we're breaking down the data by product key, which our returns table is connected to, then this is a valid view. Now let's do a very similar example, except this time let's add one to our sales table. Right click, new measure, and we've got this raw revenue field, these revenue values in that new column that we created using related in the last lecture. So basically I just want to sum those up. I'm going to call it total revenue equals the sum of that AW sales revenue column, and press enter. So as a reminder here, you might be wondering, isn't that kind of a redundant step? Is that really necessary? Because I could pull total revenue into this matrix view, right? Or I could pull the raw revenue values from my table into that view as well and get the same answer. So was that measure calculation just an extra unnecessary step? And again, it comes down to this idea of implicit versus explicit measures. And what I just showed you in the second example with those raw revenue values, that was an implicit measure which can't be used anywhere else. Whereas my total revenue measure now can plug into other sorts of DAX calculations, like profit, for instance. So you'll note that it's not formatted as currency here. You can access formatting tools here as well, just by clicking the measure itself and then accessing those formatting tools here in the modeling tab, which you saw was also accessible through the data view. So instead of general, this revenue is going to be English United States currency. And there you have it. So we just used sum to create two new measures, two new numerical values that we can analyze in our model, quantity returned and total revenue. And now that we have quantity sold and quantity returned, those two pieces could serve as interesting components to another new value like return rate. So I think that's something that AdventureWorks might be interested in seeing, not only the raw volume of sales and returns for their different products and territories and categories, but the actual return rate as well. So are accessories returned more frequently than bicycles? Are there certain territories where return rates are unusually or concerningly high? By creating these new numerical values with measures, we're giving ourselves, or we're creating for ourselves, these tools that we can use to answer those types of analytical questions. So let's try creating that return rate column, and we can assign it to any table we want. I think it makes sense to either go in sales or returns because it's going to contain a component of both. We're going to be using the quantity sold measure in the sales table and the quantity returned measure in the returns table. Now, since this is more of a return specific measure, let's go ahead and assign it to the AW returns table. So right click that header, press new measure, and we're going to name this one return rate. And two ways to do this. You can either use the division operator or the divide function. Both are valid. Again, the divide function just gives you that optional third argument. Now, this is also a good point in time to remind you about the difference between columns and measures and the fact that measures can't reference naked column types or columns that don't have some sort of an aggregator assigned to them. So for sake of example, what if we tried to calculate return rate as just the order quantity column from the sales table divided by the return quantity column from the returns table. If I try to start typing, it's not even allowing me to access that column because Power BI knows that I need some other piece of information here. I need some sort of aggregation, whether I'm defining aggregation here in the function, like the sum of the return quantity or order quantity, which is valid, or a measure like quantity returned or quantity sold, which is built from an aggregation. So in this case, our return rate, we're going to define it in a pretty simple way, just the quantity returned, and I'm using the measure that we've already created divided by quantity sold. So we're just coming up with a simple ratio here, and this is what I'm talking about with measure trees. We're using individual measures as components nested within new measures like this one, return rate. So I could press enter, and that should work just fine. You can go ahead and pull return rate into this same matrix view as well. And if we want to format this, let's make it a percentage here. And it's going to default to 2 decimal points, which looks good. And again, this is the operator version of the function. We could also use the divide just to see what that looks like. Equals divide, and then numerator, comma, denominator, comma, alternate result. So my numerator, again, is quantity returned. My denominator is quantity sold. And then the alternate result, so in cases where we get an error, that's going to be a div 0, and it's going to happen in cases where I have no quantity sold values. In this case, that shouldn't be an issue because we won't see returns in cases where there were no products sold. But just to cover our bases, we could do something like no sales as our alternate result. So in some case that we happen to run into a div 0 error with this divide function, we would just assign that label of no sales instead of the error message itself. So that should be good. And when we press enter, produce the exact same values. There you go, it just refreshed, nothing's changed. So that looks good. And now let's simplify this view a little bit. I want to explore things just for a second. Let's pull order quantity out. Let's pull total revenue out. So now we're just looking at sales, returns, and the return rate. And instead of breaking this down by product key, which is really, really granular, let's remove that. And let's actually look at product categories at kind of a higher level. So category name in our rows instead. This is starting to give us some interesting insight already. This tells us that the product category that's returned least often are accessories, and most often are bikes. And then you can see clothing kind of falls somewhere in between at 2.16%. So already, just by using some pretty simple measures like sum and divide, we're able to take our analysis to an entirely new level. And to be honest, we are just getting started. Now, the last basic math and stats demo that I want to walk through is the average function. And so to use average, let's say we want to create a field to calculate the average retail price. Now, since retail price is an attribute of my products, I'm going to access that field within my product lookup. There it is, product price. I'm going to add a new measure right here within the table. You can see I can right click anywhere inside the table. It doesn't have to be the header. Choose new measure. And let's call this measure average AVG retail price. And super simple. We're just going to use the average function. And I'm going to type price to search for it. Product lookup, product price. Close it off and press enter. So it's created that new measure, that new field in my table for average retail price. And let's go ahead and pull that field into our matrix. Now, one thing you'll notice is that now we're seeing average retail prices even for categories or products that weren't even sold in the data set. And that's because even though they don't exist in the sales or the returns records, they do exist in our product tables because they're part of the product lookup. And because we do have retail prices associated with every product key, then we are still able to calculate the average even with no sales. So let's go ahead and format this one as a currency as well. There you go. And now one last little teaser that I want to show you, just one of the reasons why these visuals in Power BI are so cool, is that so far we've just been looking at individual row labels, in this case category name. But what you can do is some interesting things, like pull in another field, let's say subcategory name, drag it in under category name. You'll see the view didn't change, but what we can do now is use these drill buttons to actually go to a different level in the data. So we've just drilled up from category name, down into subcategories, and we could stack or nest additional ones in here as well, like products, actual product name as a third level, and then drill even deeper. It's giving users the ability to kind of self-discover and explore the data and drill in and out at different levels. Or you could use this last button here to show your deeper levels within the same view, like so. So we're going to talk a lot more about exactly how these visuals work and some of the other incredibly useful tools available in this report pane, but more on that to come. So there you have it, creating measures using those basic math and stats functions. The next group of measures that we're going to talk about are the counting measures. These are really, really helpful. We're going to talk about 4 different count functions here: count, count A, distinct count, and count rows. They all work in a very similar way. They just count slightly different things. So starting with count, count is designed to find cells in a column that contain numbers specifically. So all you do is write the count function, point it to a column containing values, and you're good to go. Count A, very similar, but this counts the number of non-empty cells in a column. That could include numerical or text-based values. Syntax-wise, same deal, single argument for the column name. Now, distinct count, this is one of my favorites because historically it's been something that's unusually difficult to do in Excel. There hasn't been the same equivalent function on the Excel side to do something like this. And this is where DAX really stands out. You can easily count the number of distinct or unique values in a column using that distinct count function. Again, one argument for the column name. And then last but not least, we have count rows. This one's slightly different because this actually points to a whole table, or a table defined by an expression like filter or all, and counts the number of total rows in that table. So pretty clear, pretty straightforward. Let's practice a couple of these in our AdventureWorks file. Okay, so go ahead and open up your AdventureWorks report, head to the report view, and what we're going to do here is add 2 new measures practicing these count functions. And the first measure that I'd like to add is related to returns. Now, note that we've already created a measure for quantity returned, which is the sum of the return quantity field. But in this case, I want to return the value of total returns. So very similar concept, but the difference is that if a customer came in and returned 2 items, that would count twice in the quantity returned column, but I only want that to count once as a return. And since this AW returns table includes a record or row for every single return, what I can simply do here is count the number of rows to give me that total returns value. So to do that, we're going to use a count function, right click, new measure. Let's call it total returns. And we're going to set that equal to count rows and just point to that table, returns. So we're counting the rows in the AW returns table. As simple as that. Press enter. It's added my measure here. I can select the matrix, drag total returns into the values, and you'll note that they're very, very similar to the quantity returned, but a little bit lower. What that tells me is that the vast majority of returns, in this case, were from single items, but there were a handful of multiple items returned, which is why the total number is slightly lower than the quantity of returns itself. Now, let's go back to that concept I mentioned earlier about each row or record in that return table representing a return. I want to actually look at the table for a minute. So we're in our return table here, and you'll note that in every single case, we've got a return date, we've got a territory key assigned to it, product key assigned to it, and a return quantity assigned. So there should be no blanks anywhere in this table. And again, each row represents a return. So what that means, if I go back and revisit that measure, that means that I could theoretically calculate this same total returns measure in a few other ways. For instance, instead of count rows, I could calculate a simple count of any column in that returns table that includes values. So let's start typing returns. We could technically use any one of these, any of our keys. We could use the count of the quantities or the return dates. They should all return the same thing, again, because there are no blank values in that returns table. So let's calculate the count of return quantity. Tab it in, close the parenthesis, and press enter. And you'll see that these total return values refreshed and remained exactly the same, which is what we'd expect to see. And then same story holds if we use count A as well, because again, very similar function, except count A also accounts for non-numerical values like text. And that shouldn't make any difference in our case, but let's just confirm by pressing enter. There you go, they've refreshed again, same values. So there you go, 3 different count options or counting approaches to evaluate the same total returns measure. Now up to you which version you'd like to use. In this case, I'll just keep it as count A for now. And the next measure I'd like to add is a very similar one, but looking at the sales table, I'd like to add a comparable measure here for total orders. And same story kind of holds here. We already have a quantity sold measure, which sums up the order quantities, but I'm not interested in the total quantity. I'm interested in the total volume of orders as a whole. Now, to figure out how we're going to calculate this, it's helpful to go and take a look at that sales table for ourselves. And looking at the sales table, one thing that's interesting is that we've got this order line item column, which means that if I placed a single order but purchased 2 different products, that will show up as one order number with order line item 1 followed by order line item 2, which means that there are duplicate values in here because there are multiple line items for any order containing multiple products. And the reason we're digging into this is because I can't use a function like count or count A against any column in this sales table, like order number, because it won't respect the duplicates. And I'll be double counting and inflating my order totals. So this is a great opportunity to use that distinct count function because I want the count of unique order numbers, and that's going to give me my measure for total orders. So let's go back to our reporting canvas, right-click the sales table, add that measure, and you guessed it, we're going to name it total orders, and that's going to equal the distinct count of my order number column in my sales table. So AW sales, order number, tab it in, close the parenthesis, and press enter. And now just to demonstrate, let's grab that total orders. I'm going to put it in right next to quantity sold. And there you go, kind of the same type of comparison we just made with quantity returned and total returns. We have quantity sold and total orders. So as you can see, a number of sales, a number of orders contained multiple line items or multiple products or multiple quantities of the same product. So this is a great use case for when something like distinct count can really come in handy. And it's really as simple as that. Those are your basic counting functions in DAX. All right, now before we move on to the next DAX function, calculate, I want to take a moment and pause here to address a really important but nuanced point. And it has to do with the values that we've produced here in our matrix view. Now you'll notice my screen looks a little bit different. That's just because Power BI has gone through some updates since recording the last version of this course. So you'll see the light mode here, a new filters pane. Don't worry about those differences. Functionally, everything will operate exactly the same. And if there are major changes, I'll address those as we get to them. But what I want to focus on right now are the values here. Now, if you haven't already, I want you to take a minute, pause the video, and let me know if you see anything a little bit strange or unexpected about some of these values. All right, did you find it? By now you've probably realized that this total orders column is a little bit strange because the total, 25,164, does not equal the sum of its component rows. In fact, if we were to add up the accessories orders, bikes orders, and clothing orders, we'd end up with something closer to 38,000, not 25. So what's going on here? Well, this is a perfect opportunity to talk about exactly how DAX is working and also how the data that we're working with is really structured. So two things I want to call out here right off the bat. First, this value here in the total row is not calculated as a sum of the rows above. This field is calculated as an island, and it has no awareness or visibility into the values around it. In fact, this is calculated by evaluating the total orders measure without any filter context applied. That's why it's a totals row. Whereas a number like 6976 is evaluating the total orders measure with the filter context category name equals clothing. So it might not seem like a big difference, but it's a critical, fundamental idea to help you understand how DAX really operates. So that's the first thing. The second thing that we need to call out here is how this total orders measure is actually working. So let's go ahead and find it here in our field list. Total orders. Remember, we defined the total orders measure as a distinct count of order numbers inside of our sales table. So let's take a closer look. Let's jump into data. We're going to drill right here into our sales table. And what I want you to do is actually sort your order numbers descending. And what you'll notice right off the bat is that the same order number can appear multiple times. So there can be multiple instances of the same order. In this case, right here at the top, SO74147, that order number appears 3 times. So the order took place on June 30th, and it actually contained 3 different products or 3 different order line items. Okay, so this customer, when they made this purchase, they bought 1 quantity of product 490, 1 quantity of product 605, and 2 product 538. And because we're calculating a distinct count, that only counts as 1 order number, even though it contained 3 different products. So following this kind of chain of investigation, let's think about what these products actually represent. We can do that by following our relationships in our data model to understand what is product 490 and what category does it fall into. So let's start there, 490. We're going to go into our product lookup table. Make sure you're sorted on product keys, and we can scroll right to 490. Here it is. So this is a short sleeve classic jersey, and the product subcategory that this falls into is 21. So same logic. Let's go into product subcategory, find subcategory key 21, jerseys. That makes sense, and that falls into category 3. So last but not least, jump into product category. Category 3 is clothing. So product 490 should be labeled or categorized as clothing. Now I won't go through that same process for each of them. You can if you want for practice, but I'll tell you right now, product 538 is a road tire, which falls into the accessories category. And product 605 is a road bike. It's the Road 750 black bike, which falls into the bikes category. So as you're starting to realize, this one order number contains products that fall into 3 different categories: clothing, accessories, and bikes. So when we jump back to our report view, think about how this total orders measure is evaluating. When we're filtering down to our accessories categories, we're seeing one order from that particular order number that contains an accessory product, right? When we filter down on bikes, we see another order, and clothing, we see a third. So we're adding one, or we're counting one order for each of these 3 categories. But then when we evaluate the total, we're looking at the unfiltered total sales table, just like this. And because we're using a distinct count, we're not counting that as 3, we're counting it as 1. So kind of tough to wrap your head around, but that's exactly how this is working here. And one way to kind of interpret this or read the numbers from this matrix is that accessories or products in the accessories category appear in 16,983 orders. Products that fall into the bikes category appear in 13,929 orders, and so on and so forth. So again, it's a little bit of a nuanced point, but a really critical one to understand as you're learning this DAX language. Hopefully that helps. All right, important lecture coming at you. We're going to talk about the DAX calculate function. Now, calculate is arguably one of the most important DAX functions of all, because not only does it do pretty powerful things on its own, but it also serves as a container for much more sophisticated and complex DAX formulas. So let's break this down. Calculate on its own, pretty straightforward. It evaluates an expression or formula under a set of defined filters. So here's what it looks like. You've got your expression argument first. This could be the name of a measure, or it could be a DAX formula that could create a valid measure. So you could plug in your total orders measure there, or a sum function of the return quantity from your returns data table, both totally valid options. And then the second component of the function is this set of filters, this list of simple Boolean, meaning true, false, filter expressions. Now, important thing to note here, these must be simple expressions with fixed values. So column name on the left and some sort of a value or text string on the right, separated by an equals, a greater than, a less than, etc. So some examples could be country column from territory lookup equals USA, or the year column from the calendar table greater than 1998. What you cannot do here is insert more complex filters or even use filters that reference measures. So again, column name and some criteria, either value or text. So pro tip here, the way that I've kind of wrapped my head around calculate as I learned it for the first time was to think of it in Excel formula terms. I'm obviously an Excel guy, that's my background. I think like Excel, so anytime that I can relate it to something comparable in Excel, that usually helps me kind of wrap my head around it and understand what's really going on. So calculate works very much like a sumif or a countif or an averageit function in Excel, in which case you're evaluating a sum or a count or an average if certain filters or criteria are met. The difference is that calculate can evaluate measures based on any sort of calculation, not just those restrictive sums, counts, averages, etc. So you can almost think of this as like a calculate if, which is much more flexible because you can define really rich, really complicated measures and plug those into the expression argument here in the calculate function. So I want to jump to Power BI, do a simple demo, and then return to the slides to dig a little bit deeper into how this is really working. All right, back in AdventureWorks report, let's try creating our first ever calculate measure. And this measure is going to be related to my sales. And what I want to do here is calculate a measure that captures bulk orders. So in other words, I'm going to evaluate the total orders measure that I've already created, but only under the filter expression where order quantity is greater than 1. So this is a good candidate for calculate. Let's right click, add the new measure. And I'd like to name this one bulk orders, even though realistically an order size of 2, you could argue isn't really bulk, but let's not worry about that. So bulk orders equals calculate. First argument is my expression. So what am I calculating here? Well, I'm calculating my total orders measure that I've already defined. And then comma over to my filter statements, my filter expressions. And in this case, I'm looking for cases where my order quantity, which is AW sales order quantity, is greater than 1. Close the parenthesis. So this should check out because I'm evaluating a measure called total orders, and I'm calculating that measure, but only if my order quantity value is greater than 1. So we can press enter to lock it in. We see our bulk orders measure now defined. And let's go ahead and select our matrix here. I'm going to pull out our return fields. And I'll pull out average retail price as well, so that I've just got quantity sold, total orders, and now bulk orders as well. So it's interesting because you see a lot of bulk orders as a percentage of total for things like accessories and to a lesser extent clothing, but you see no bulk orders for bikes, which makes sense. If bikes are a much more high ticket item, you generally won't have customers coming in and purchasing multiple. So that looks good. That's our bulk orders calculate function. Now let's return back to the slides and drill in a little bit deeper into how this function's working. So let's look at a different example of calculate here. In this case, we've defined a new measure. We're calling it bike returns, which uses calculate to evaluate the total returns measure, but only when the category name from the product table is equal to bikes. And when you visualize this bike returns measure against your total returns, broken down by category names, you see something interesting taking place here, which is that you see the same repeating values in every single row for every single category name within that matrix. So you may be wondering, shouldn't those cells have different filter contexts in the other rows for the clothing row, for the components row? And this leads me to a very important point, which is that what calculate is actually doing here is it's modifying and overruling any competing filter context. Now let that sink in for a minute. Let's pay attention to the clothing row, for instance. That clothing row in the matrix has filter context of category name equals clothing, which is defined by the row label, and it also has filter context for category name equals bikes, defined by the calculate function. And since both can't be true at the same time, the clothing filter is overwritten and the bikes filter from calculate takes priority. So think of calculate as kind of the bully function or the bully filter, which says, I don't care if I'm sitting here in a matrix row that says it should be calculating accessories or clothing or components. I'm the boss. I'm going to step in and say, we need to calculate for category name equals bikes, period. And that's why you see the same total row after row after row, even for lines like components, which didn't generate sales or returns. Now, it may be helpful to revisit the step-by-step measure calculation that we walked through earlier in this section. So remember, there were 3 steps there to every measure calculation. It started with the filter context being detected and applied. So in this case, we're looking at the accessories row in that same example. So Power BI says, okay, we're in the accessories row. The matrix row labels have passed us filter context that says product category name should equal accessories. So go ahead, head to the product table and filter that down to just accessories rows. Here's where things change. Before we move to step 2, where normally that filter context would pass down to any related data tables, there's an intermediate step, which is that the filters get modified by calculate. So anytime the measure being evaluated, in this case bike returns, contains a calculate function, that filter context gets overwritten right here between step 1 and step 2. So what's happening is that even though we originally filtered down that product table to accessories, between step 1 and 2, the calculate function butts in and says, nope, we're actually going to filter based on category name equals bikes. And then that new filter context passes over to step 2, and the process continues as it normally would. So now the filter context is for product rows where the category equals bikes, and that context passes to any downstream connected data tables, and from there, the measure is evaluated. In this case, the total returns, which is the count of rows from that final filtered returns data. So the point here is that no matter what that initial filter context was in step 1, defined by the matrix row labels, accessories, bikes, clothing, or components, regardless of what it is, it's going to get overwritten with bikes, and then everything from step 2 onward yields the same end result of 342, and that's why you see the repeating values. So definitely a tricky, pretty technical concept, but let's head back to our report and create a function like this so that we can kind of see it working for ourselves. Okay, back in the report. First thing I want to do is actually jump to data quickly, and I want to create a measure to capture weekend orders. It sounds like our AdventureWorks clients are really interested in sales trends between weekends and weekdays. Maybe they're looking to see if they need to run more offers on weekends to promote sales, or if weekends tend to be stronger than weekdays. So to help them answer those types of questions, let's use a calculate function to evaluate our orders measure, but only for weekends. So we're going to be basing that off of this weekend column that we created with our if and or statements here in the calendar table. So let's hop back to our report view. And again, this is going to be a sales related measure. So I'm going to right click, add the new measure, and let's name this weekend orders and set that measure equal to calculate function. And we're calculating total orders, our measure, where the filter is that the date is a weekend. So we can search for that weekend field. There it is. And the two values that weekend can take are weekday or weekend. So in this case, my filter will be weekend and close it out. So we've got our simple filter, column name, criteria, and I think that should just about do it. So when I press enter here, created our new measure for weekend orders. I'm going to select my matrix, pull weekend orders in, and to clean things up a little bit, let's pull quantity sold out, bulk orders out, and let's clear all of these product related fields as well. So we should just be looking at two numbers, total orders and weekend orders, which is calculating the total orders measure, but only in cases where the date falls on a weekend. So just like I showed you in the slide, let's go into our calendar lookup, grab that weekend dimension, pull it into our rows, and this is exactly what you see. That same repeating weekend order number over and over and over again. Now you might be wondering, what's the point of calculating a weekend order specific measure when you have access to this weekend field that you can pull in, to break down your orders exactly like we see here? Well, the answer is that if we weren't filtering on this weekend field, pull that out of our rows and pull in any of these other fields like category name, for instance, we're still able to see the weekend specific orders broken down in a completely different way by category without having to have that weekend dimension pulled into my matrix view. And not only that, but just like any other measure, this weekend orders measure can now serve as an input and be nested into other calculated measures from here. So it gives me a lot more flexibility than I would have if I were simply pulling in a dimension like weekend and breaking down a basic total orders measure that way. So that's your primer on the calculate function. In the next few lectures, I'm going to talk about how to make this calculate function even more flexible and even more powerful by nesting other filter functions like filter and all. Stay tuned. The next DAX function that I want to talk about is all. Now the all function either returns all of the rows in a table or all of the values in a column, completely ignoring any filter context. So here's what it looks like. Your first argument of the function is either the table name or the column name that you want to clear filters on. So you could point to the entire sales or transactions table here, or a specific column like product category from your products table. And keep in mind here that all does not return a single number. It returns a table or a subset of a table. So you'll almost never use all by itself. Instead, you'll use it as a component of other functions, most commonly calculate. Now, the second optional set of parameters or arguments here are column names. So if you've selected a column in your first argument as opposed to a table, you do have the option to list additional columns here that you'd like to clear filters on. The catch is that all of these columns must be fully qualified and include the table name, and they must all come from the same table. So, pro tip, instead of adding filter context or changing it like calculate does, all removes it. And that sounds a little confusing and counterintuitive at first until you realize what it's commonly used for, which is when you need unfiltered values that you don't want to react to changes in filter context. Great example, which we're going to practice, is a percent of total calculation, where your denominator, your grand total, needs to always remain fixed. So let's head to Power BI and give this a shot. All right, here in my report view, I want to practice adding 2 new measures using that all function. But again, we're not going to use all on its own. We're going to use it as part of a calculate function. And the first one that I think we should add is a measure to capture the grand total orders, or all orders across the board. That way we can take our existing measure, the total orders measure, and take a ratio to calculate something like the percent of grand total. So let me show you what I mean by that. This is going to be assigned to our sales table, since this is a sales related metric. I'm going to add a new measure, and let's name this all orders. I'm going to make all kind of all caps just so that it sticks out and reminds us that we're using the all function as part of this measure. And so the way that we're going to calculate all orders, which is essentially the grand total of orders, is to start with our calculate. We're going to calculate our existing total orders measure. So here's where things get a little bit strange, because the calculate is now asking for the filter argument in our function. So this is where we would normally add filter context, like country equals USA, or quantity is greater than 1. Instead, in this particular case, we want to strip filters out. And anytime you want to remove filters, you know you need to use the all function. So we're going to type the all right here in the filter argument of our calculate. And we're going to just input the table name of our sales table, because the sales table contains the order information that we're using to calculate our total orders measure. So we can just type AW underscore sales and we'll get the entire table. This icon looks a little bit different because it's the whole table, not an individual column. Tab it in, close the parenthesis, and then close one more parenthesis at the end. So to recap, give me the total orders calculation applied to the entire AW sales table, no matter what. So let's press enter, lock that in. And there we go, it's added it into our AW sales table. And now what if we just select our matrix here and grab all orders and drag that into values. So check this out. We've got our total orders column, which is the measure that we're calculating. Now this all measure that we just created, this all orders measure, even in rows where the filter contexts are trying to tell it to filter down to different categories, accessories, bikes, clothing, the all statement that we added in the filter argument of our calculate is saying ignore all that and just return the grand total no matter what, no matter how this view, this matrix, this report page changes. So this field alone is not that helpful. As you can see, there's no real circumstance where we'd want to drag this field in or analyze it by itself, but where it does become useful is serving as an input for something like percent of all orders. So let's go ahead and add another measure, new measure, and let's call it actually, just like I said, percent of all orders. And what we're going to do here is basically just calculate the ratio of our original total orders measure divided by that brand new all orders measure. So that denominator, which is defined by the all function in the calculate, will never change. It's always the grand total. But the numerator, total orders, can change in reaction to different filter contexts, as you can see right here. So when we go ahead and lock that in, drag it into our matrix visual, we can go ahead and enter the modeling tab to format it as a percentage. And look at this, it totals to 100%, which is correct. And now we can see really interesting insight, like what percentage of the total orders do accessories account for? In this case, about 2/3. What about bikes? Just over half. Clothing, about 28%. Now a little added bonus to this, even though all orders is a component of this percent of all orders calculation, it's the denominator, it does not need to live here in the matrix for us to calculate our percent of total. So let's remove that, and there you go. It still functions exactly like you'd expect, and it can still be filtered and segmented in any way you can imagine. So that's a great, very common example of how to combine calculate and all to create these percent of total fields. Now, one more quick demo here. I'd like to add one more measure, this time to our product lookup table. So I'm going to right click, add a measure within product lookup. And for this one, I'd like to calculate the average retail price or the average product price across the entire table, which will essentially give me a single number that captures the average price across the entire product set. So let's name this overall average price, okay? And you remember we've already calculated an average retail price just using that basic average function on its own. So now what we can do is calculate that measure, average retail price. And since we don't want our overall average price to change in reaction to filter context, we always want the same overall average number to be returned. That means we need the all statement here again. And this time, the table that we're going to reference is not the sales table, it's not the returns table, it's the AW product lookup table right here. Close out two parentheses, and to recap, we're evaluating our original average retail price, which is the average of the product price column values, and we're evaluating it based on the entire AW product lookup table every single time. Press enter to lock it in. And now to see how that's working, we can go back to our matrix here. We've got our original average retail price, which we'll pull in. And then we've got our overall average retail price, which we can pull in second. And there you go. You can see that our overall average, which used the all function, gives us that same total average, that same overall average every single time. So while we're here, let's go ahead and make that currency, $English. And there you go. So now we can see interesting things like the average price for accessories is well below the average. Bikes is clearly pulling the average up. Clothing average is about $51. Components $432. And when you blend all of that together, the overall average is about $714. So we're going to be using this overall average price measure as a way to demo another function that's commonly nested with calculate, which is called the filter function. So stay tuned, that one's coming up next. All right, so we've talked about a few DAX filter functions already, namely calculate and all. Now I want to talk about a third called filter. Now filter by definition returns a table that represents a subset of another table as defined by some filter expression. So very simple syntax. First argument is the table that you'd like to filter. Might be a lookup, might be a data table, doesn't matter, any table. And the second piece, or the second argument, is the filter expression, a Boolean true-false filter expression to be evaluated for every single row of the referenced table. Now, a couple of very important things to call out here. Number one, filter can accommodate more complex filter expressions than a standard calculate. One great example is that you can actually integrate measures into your filter expressions within a filter function. Like this last example here, product price is greater than a measure named overall average price. And the other important thing to note is that filter is what's called an iterator function, meaning that it iterates row by row by row by row through an entire table, testing that filter expression, that true-false statement. And for every row where that expression returns true, that row is preserved. Any row where that filter expression is false, that row gets chopped out. So as a result, it's going row by row and chopping out any rows that don't meet the filter expression. And then by the time it's gone through the whole table, you end up with this subset, a smaller table containing fewer rows and only the rows that meet the filter expression. So this is different from how a calculate works. Calculate is not an iterator, meaning it doesn't actually eliminate rows from the table. It just identifies filter context and modifies it. Filter, as an iterator, is actually producing a new table as a subset of the original table based on whatever filter expression you're using. So, important point, filter is used to add new filter context, and it can handle more complex filter expressions than calculate, like we just said by referencing measures, for example. And since filter spits out an entire table, you won't use it by itself. It's almost always used as an input to other functions like calculate or sumx, just like we saw with the all function as well. So, little tip here, since filter is an iterator function, it can be slow and it can be pretty processor intensive. Not a big deal at all if you're working with manageable file sizes, but as a best practice, don't use filter if a standard calculate function will get the job done. So let's open up our AdventureWorks file and practice creating a brand new measure using this filter function. All right, once you're back in your AdventureWorks report, remember that we added this overall average price column by combining calculate and all. And now using that column, I want to create some sort of measure that will calculate our total orders, but only for products that are greater than the average price. So I want to see sales for higher than average priced items. And I want to name that measure something like high ticket orders. So let's go and right click our sales table and add a new measure. And we're going to name this measure high ticket orders. And again, we're going to start by calculating our existing total orders measure. And now for the filter statement, let's step back and think about this for a minute. So to recap, what we're trying to do is we're trying to return a measure that's going to capture the volume of orders, but only for high-priced products, or products with a retail price greater than the overall average, which we know is $714.44. So the first thing you might be inclined to try is to say, okay, in our filter argument of our calculate, let's find that product price field, product lookup product price, tab that in, and say, okay, so if the product price is greater than the overall average price measure that we created, and then close the parenthesis, right? So we're calculating total orders in cases where the product price in the product lookup table is greater than the overall average. Press enter, we get an error. And the error message is not very helpful. It says a function calculate has been used in a true-false expression that is used as a table filter expression. This is not allowed. So classic Microsoft writing a very wordy, very confusing error message when they should have just said, hey, you can't use a measure in your filter argument of a calculate. That's really what's going on here. That's what it has a problem with. So if we edit this and delete the reference to our measure, our overall average price measure, what we could do if we were lazy is just type the average, right? 714.44, because this now becomes a simple filter expression, column criteria. And if I press enter, that will go through just fine. It added a measure for high ticket orders. And let's select the matrix. And why don't we grab it and pull it right after total orders. So as you can see, high ticket orders populated on the bikes row. That's the only product category that's generating sales for products priced over $714, which makes sense. So we see overall about 11,312 orders were categorized as high ticket out of 25,164 overall. But the fact that we had to hard code that number is unsettling to me, and it's not scalable because it won't change as our product list evolves or if we need to refresh data in the future. So it's kind of sloppy analytics, and I don't like it. So let's go back to that measure, and what we're going to do here is use our new friend filter to accommodate this more complex filtering rule. So let's go ahead and clear out the filter argument of our calculate. And just like we added all, we're going to add a filter here. And this is where we're going to define that product price greater than overall average price filter. And here we can reference that measure since filter can handle some of these more complex expressions. So the table that we want to filter is our product lookup table, AW product lookup, because that's the table that contains the product prices that we're testing. And now the filter expression is that the product lookup product price is greater than that measure that we use to calculate overall average price. So kind of a lot going on here. Looking at the filter statement on its own, it's saying, all right, look at the entire AW product lookup table, that list of all our product keys and all those attributes about those products. Go row by row, check the product price, and compare it against our overall average price measure, which we know is $714.44 based on the data we currently have. If the price is greater than $714, we're going to keep the row from product lookup. If it's less than or equal to that average price, we're going to chop that row right out of the table. And then we repeat the process row by row by row until it's gone through the entire product lookup table and hacked it down to a smaller table containing only the products that meet this expression that we just wrote. And then that table as a whole gets passed to the calculate function so that the total orders measure can evaluate against it. So a lot going on there, but you see how this can start to enable some really advanced, really complex stuff. So it looks like we just need to add one more closing parenthesis, and then we should be good to go. So what we're going to watch is this high ticket orders number. And if we've done our jobs, when we hit enter, this shouldn't change at all. So drum roll, please. Enter. There we go. So it refreshed, gave us the correct number that we got when we hard coded the number in there into our basic calculate. But when we replaced that hard coded number with the full filter function, we continue to get the correct number. So that's great news. Now, obviously, that's just one example of how filter and calculate can be combined, but hopefully a good example of how these functions can work together to do some really sophisticated things. So that's your crash course on filter. Next up, we've got iterator functions and SUMX. Next up, I want to take a quick look at iterator functions, otherwise known as X functions, in DAX. And in a nutshell, what these iterators do is they loop through a given calculation or expression for each row of a table and then apply some sort of aggregation to the results. Now, here's an example of what a SUMX function looks like. And in this particular case, the aggregation mode is a sum, but the same syntax applies to other X functions like countX, averageX, rankX, etc. So the first argument of the function is the table in which you want the expression to be evaluated. This could be an explicit table reference like sales, or it could be a filter or all function that produces a table. And then the final argument of the function, the expression, is basically what's the calculation that you're trying to evaluate row by row by row. So it might be a measure like total orders, or it might be a mathematical operation like the values in one column times the values in another. And this took a little while to sink in, at least for me. But what kind of helped was to equate it to a sum product in Excel. And a great example that's kind of tangible and hands-on is calculating something like price times quantity, right? So imagine a price column, a quantity column, and you run a sum product, which basically calculates price times quantity in row 1, price times quantity in row 2, over and over and over and over until it gets to the last row in the table. And then it takes the results of each of those multiplication expressions and sums them up. So it might be helpful to think about these iterator functions adding a temporary column at the end of the table where it stores the results of each of these expressions for every single row as it works through the table. And then once it reaches the end, the final row in the table, it aggregates the values in that temporary column based on whatever function it is. If it's a SUMX, it takes the sum of those results If it's a count X, it counts the results. If it's a rank X, it determines ranks based on those results, and so on. So that's how these iterators are really working. And to show you an example, what I'd like to do is head back to our AdventureWorks report and try to recreate that revenue column that we had generated with calculated columns and see if we can convert that into a measure using this SumX function. All right, so open up your Power BI report and head to the Data tab. You want to head to your sales table specifically, and you should see this retail price and revenue column. And these columns were created during the calculated column demos. For retail price, we used related, and for revenue, we simply multiplied the values in the retail price column by the order quantity column. And then as a result, we were able to create a measure for total revenue that equals the sum of that new revenue column. So there's nothing wrong with that. It's not incorrect. We're getting the proper values and it's working just fine. Our table and our data set is small enough that really there's no noticeable impact whatsoever to file size or to speed or anything like that. But if we were perfectionists and we were trying to build the leanest, most efficient possible model that we could, we would try to replicate both of these columns as a measure so that we're not actually stamping redundant data here in the table. So let's see if we can make that happen. I'm going to go back to the report view because we're going to play with our matrix a little bit. And to set up our view, let's keep this view showing category names, but let's just show the quantity sold and the total revenue. So I'm going to get rid of a bunch of these for now and pull in quantity sold, which is a measure, and that total revenue measure as well by product category. Now let's go ahead and add a new measure in our sales table. And let's name that measure total revenue underscore measure, because I want to keep the original so we can compare against it. And let's think about how the original version of total revenue was calculated. We were taking the values from the order quantity column, multiplying by the values of the product price, which we had pulled into the sales table using related. So maybe the instinct is to start with something like that. Maybe we reference the quantity field, and you'll notice that I can't. It doesn't let me. I can only get to measures here. Same thing with product price. If I try to type price, it's only giving me measure options. And that's DAX reminding us that we can't just reference blanket columns like this. We need to aggregate, because DAX doesn't know what to do with a full column of values and no further instruction. So what if we try to indicate or add the aggregation right here in the formula? So instead of just the quantity column, maybe the sum of the quantity. So sum of AW sales order quantity. It lets us do that. So that's a good start. And let's multiply that maybe by the sum of the product price. You know, if we have to identify some sort of aggregation, maybe that would make sense. So press enter and lock that in. And it seemed to calculate fine. So let's grab this second version, total revenue, pull it into our matrix, and things look totally out of control here. This is telling us that products in the clothing category were sold 12,436 times, total quantity sold, and that generated a revenue of over $22 million, which, just doing the math, means that the average price for a piece of clothing is almost $1,775. So something seems a little bit off there. And as you look at the formula, it's pretty clear that the issue is with our product price field, because we are summing product prices together, which doesn't make any sense at all. We could try to change this to something like an average and probably get a little bit closer. Press enter. So we're at least in the realm of something reasonable, but these numbers are not correct. They're relatively close, but this is not a valid revenue function. So we've got to just chop this down and start over. So if only there were some function that could evaluate an expression for each row in a table and iterate through the whole table and apply an aggregation to the result, that would be exactly what we need here. I think you see where I'm going with this. SumX is going to be a great fit for something like this. So let's start typing it and then walk through. So the first argument of the SumX function is the table, which table contains the rows that we'll be cycling through evaluating these expressions. Well, it's the sales table, AW sales. And the expression, what calculation are we going to be running for each of those rows? It's the calculation for revenue, price times quantity. So we can type quantity, and there you go. Now we can access the actual column itself, order quantity, times the AW sales retail price. Now, one thing you'll note is that I only type price, and there's another price column in the product lookup table. Note that that's not even an option here, and that's because we're performing these row level calculations within the AW sales table. So DAX is telling me I've got to grab columns from within this table. So that's the one I want, AW sales retail price, and close the parenthesis. Now some of you may be wondering, how am I using blanket column references here? AW sales order quantity, AW sales retail price, when we couldn't do that before. The reason is because this is an expression argument of a SumX. And the way a SumX works is that this expression only runs on one row at a time. So I'll never need to aggregate because I'm only looking at a single value from each of those columns each time. Now when we go ahead and press enter, there we go. Everything adjusted. Our new total revenue measure matches the original total revenue measure, and we've done it using a SumX function. So in the spirit of making our model more efficient and reducing redundant data, that means we can now go back to our data, we can right click and delete that revenue column, go back to report. We're going to get an error because that old total revenue measure was built off of the column we just deleted. So we can pull that out of the visual, find it right here in our field list. You can see it's got a little caution exclamation point. You can right click, delete it, and there you go. Our total revenue measure using SumX is still here, still correct, still fully functional, and we've eliminated an entire column of extra data. And now if you want to get really crazy, we can eliminate one more column as well. And I'm going to give you a hint at how we can do that. Looking back at our data sheet, this retail price, remember we pulled this in with related? We can follow this same logic, but embed it or nest it inside of that SumX that we just wrote, instead of pulling the column in here and then referencing it from within the sales table. So let's go back. I'll show you what that looks like. Total revenue measure, which we can now just call total revenue because the other one's gone. And so SumX, AW sales, order quantity. Now I told you that we had to pull columns from within that sales table, but I kind of lied. We can access columns from other tables, but the only way to do it is to use the related function. So just like we pulled a related field into the table itself, we can access values from a related field inside of a SumX. And that related field is the product price. So again, same exact logic as when we used related in the calculated column, except this time we're just embedding it within this SumX function. And we press enter, values still hold. Let's go ahead and format those as currency. Perfect. And now the last little step here is to go back to our sales table, and you know it, we can delete this related column as well because we don't even need it anymore. All of the information we need is now built into this single SumX iterator function. So bottom line, we just chopped out 2 entire columns worth of data without actually losing anything, because we essentially just transitioned the calculations out of columns and into measures. So that's SumX The other X functions work in a very similar way. The only difference is the actual aggregation step that happens at the end. But hopefully this inspires you to go and play with some of these iterator functions on your own. Next up, we're going to take a look at an area where DAX really shines, which is time intelligence functions. All right, so I've saved some of the best stuff for last. The final topic that we're going to hit for our DAX demos is time intelligence. Now, time intelligence functions allow you to easily calculate common time comparisons. Now, these are all built on the DAX calculate function, and they're all extremely flexible and easy to use. So the first one that we're going to talk about is performance to date. So it's going to start with that calculate function. We're going to be calculating some measure, whatever you choose. Could be orders, could be revenue, returns, profit, whatever it might be. And then we're going to use the dates YTD function in here and point to a date field in a calendar table. Now, dates YTD calculates a year-to-date total, but you can swap in other variations like dates QTD for quarter-to-date or dates MTD for month-to-date. The second time intelligence formula that we'll look at is the previous period. So again, starts with calculate, measure. In this case, we're going to use a date add function, point to a calendar date field, and then add 2 additional arguments at the end of the function. An interval type could be day, month, quarter, or year, and the number of intervals that you'd like to compare. So the example we're looking at here is basically calculating the measure for the previous month. So in this case, if you're calculating a revenue measure and you wanted to change this from previous month's revenue to yesterday's revenue, you would simply change that month interval to day and you're done. And the third one that we're going to look at is a running total. And this one just has one additional function built in, starts with calculate. We're going to use the dates in period function, point to a date field, and then it just has one additional argument for that max function, followed by the same 2 final arguments, the interval type and the number of intervals. So the version shown here is a 10-day running total. You could change it to -6 and month to create a 6-month running total. And little pro tip, you can easily convert running totals into moving averages by taking that entire running total function and then dividing by that same number of intervals that you're using. So all of these are extremely flexible. They make it very easy to build out many different variations of time intelligence fields with very little effort. Now, my recommendation is not to worry so much about memorizing all of these. It can be really hard to keep track of whether you're going to use dates in period or date add and so on and so forth. To be honest, I have this sheet printed out. I refer back to this slide all the time. So it can be helpful to almost think of these as recipes that you consult when you need to build out these time intelligence formulas. So let's head over to the AdventureWorks file and build out some of these for ourselves. All right, so once you're in your AdventureWorks report, we're on the report pane, and let's edit our matrix. I want to set up a view that's going to be helpful to see these time intelligence functions. So I don't want to view the data by category anymore. Let's get rid of that. And we don't need quantity. We'll keep total revenue, and let's navigate to our calendar lookup and grab start of month and drop it into rows. Now what you'll notice is that it's created this hierarchy automatically, and it's trying to be helpful. It's kind of collapsed it into years by default. If you don't want that, click the little down arrow and just say, don't give me the hierarchy, just give me the original field, start of month. And that will show me monthly level data through my whole sample. So there we go, monthly revenue. It's a good starting point to start working with these time intelligence functions. So let's go ahead and just kick things off. In our sales data table, I'm going to right click, add a new measure, and let's start this one with year-to-date revenue. So we're going to name it something like YTD revenue. It's going to start with calculate, they all do. And the measure that we're evaluating is our total revenue measure. And now for the year-to-date time intelligence function, we use the dates YTD function. and we'll just point it to our calendar lookup date field. And remember, it gives me these options if I want to aggregate. In this case, I don't. So all I need to do is close out 2 parentheses and press enter. And now watch this. My matrix, I'm going to grab YTD revenue here at the bottom of my field list, the end of my sales table since it's alphabetical. I'm going to drag it right beneath total revenue in the matrix. And now you can see that it seems to be working properly. First month of the year, total and year to date are the same. Second month, year to date is adding the first 2 together. And then it builds and builds and builds until the final month of the year and then resets the next year. Now, a little teaser for one of the topics we're going to talk about in the next section, the whole data viz section, is a little formatting tool. If we click into this format pane, conditional formatting, I want to format the year-to-date revenue field with data bars. So check this out. This really visualizes how this year-to-date function is working. It builds and builds and builds and then resets. Builds, 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 resets. So if we changed our formula to month-to-date revenue and broke this down by day or week, you'd see that same trend just at a more granular level. So pretty cool stuff there. Let's go ahead and keep cruising ahead, add another measure, and this time I want previous month. So prev month revenue. Starts with calculate. And again, total revenue is the measure we care about. And for this one, we use date add. Open parenthesis, point to our calendar, date field, and then I'm just going to comma right over to get to my last 2 arguments of this function, the number of intervals and the interval type. So starting with the number of intervals, I'm looking to evaluate that measure for 1 month in the past. So since it's only 1 period and it's in the past, my number of intervals is -1. And my interval can be day, month, quarter, or year. So I'm just going to select month, tab it in, close out 2 parentheses, and that should just about do it. So you can see how easy it would be if I changed my mind and said, okay, instead of previous month, our AdventureWorks clients really want to see year-over-year trending. So we need this to actually be previous year. All we would have to do is literally change this last argument from month to year, and we're done. It's that simple. So in this case, I'm happy with previous month revenue. Press enter to lock that one in. And let's go back to our fields pane here. And let's pull year to date out and grab that previous month revenue field that we just created and drop it in. So as you can see, because it's the previous month, it's just basically offset 1 month from the total revenue column, which is exactly what we'd expect. Now, this alone can be pretty helpful, but for our purposes, it's even more helpful because AdventureWorks has given us a pretty aggressive goal. And I don't know if you've heard yet, but they want us to maintain 10% revenue growth every single month moving forward. In other words, that's our revenue target, previous month plus 10%. Now, calculating a dynamic measure like previous month revenue is the perfect starting point for something like that, because now all we need to do is right-click to add a new measure and create something like revenue target equals that previous month revenue that I just created times 1.1. 110% of last month's revenue is my current target. We can enter that in. We can pull it into our matrix to take a look. And 110% of 585,000 is 643,844. So that adds up. And there we go. Now we have revenue target fields based on previous month revenue. Now, last demo here, let's right click, add a new measure. This time we're going to practice the rolling total. And let's do a 10-day rolling revenue. And that's going to use another one of our time intelligence functions, starting with calculate and total revenue, just like all the others. Now for this one, you remember, it starts with that dates in period function. Open it up, point to our date field, calendar date, and then this one has that extra argument for the start date, which is going to take a max function, and it's just the max of our calendar date. There we go. Close that parenthesis out for the max function, and then we comma over to those same two arguments that we had in our previous month revenue formula, the number of intervals and the type of interval. So because we're looking for 10-day rolling, you guessed it, the number of intervals is 10. And because we're looking at previous periods, that's a negative, so -10, and the interval type is day. So -10 for the number, and the interval itself, day. Two parentheses to close it out. I know I'm moving pretty quickly, so feel free to kind of pause the screen, slow down the audio. These time intelligence functions really just take practice before you start to feel natural. But there you have it. That's 10-day rolling revenue. Press enter to lock that measure in. And now because I'm looking at months, it's a little bit too high level here. So I'm going to pull out my previous month and revenue target. And instead of start of month, let's go up to our calendar and actually pull in the date itself. And again, it's going to automatically bucket things and roll them up. I only want the date. So there you go, total revenue by day. Now if we grab our 10-day rolling, drop it in under total revenue, you'll see that the first date is the same as total revenue. The second date adds the first two, third adds the first three, until you get to the first 10-day window. And then basically that 10-day rolling history just shifts right along, and you can track how you're performing over that 10-day window tracked over time. So a really helpful kind of trending analysis that we can use to keep a pulse on how AdventureWorks revenue is doing. So that wraps up time intelligence, and that actually wraps up all of our DAX demos for the course. Remember, this was just a sampling of some of the most common DAX functions. Things can get much deeper and much more complicated from here, but hopefully this has helped to lay the groundwork and create a great foundation for you to start from. With that, we're going to quickly talk about DAX best practices and speed and performance considerations, and then it's off to visualizing data with reports. All right, let's take this DAX section to the finish line with some best practices. First, don't use calculated columns when measures will do the trick. So only use calculated columns when you're looking to create new data and actually stamp static fixed values to each row in a table. On the other hand, use measures when aggregation is necessary or to create dynamic values to use in a report or a visual. Next, get in the habit of writing measures for even the simplest calculations, like the sum of orders or the sum of sales. Once you create a measure, you can use it anywhere in the report, as well as an input to other more complex calculations, which we've seen many times at this point. So a rule of thumb, try to avoid using implicit measures by simply dragging those raw fields into a visual. Next up, as you're learning DAX, try to break down measures into simple component parts. DAX is a unique language, and it's a very difficult one to get a grasp of. So focus on practicing and understanding the simplest components at first, and then work on assembling them into more advanced formulas. Finally, I'd recommend referencing your columns with the table name and your measures by themselves. So using those fully qualified column references not only helps make your formulas more readable and intuitive, but it helps to differentiate them from your measure references. Now, last but not least, I want to cover some quick speed and performance considerations as well. Now, these will come into play especially if you're dealing with very large or complex data sets. So number one, aim to eliminate redundant columns and keep your data tables narrow. Your data tables really should ideally only contain quantitative values and foreign keys. If you have extra descriptive columns in those data tables, those can usually live in a related lookup table. Next, imported columns are generally better than calculated columns. So if you have a means to do so, creating calculated columns at the source like in SQL or Access if you're dealing with a database source, is more efficient than creating those calculations either in the query editor or in your data model. And then last but not least, try to minimize iterator functions whenever possible. These functions like filter, sumx, averagex, etc. that cycle through each row in a table are expensive, meaning that they take time and they consume processing power, especially if they're cycling through very, very large tables. So if you're experiencing performance lags with your model, that might be a good first place to check. So that officially wraps up the DAX section. Next up, we've got some homework exercises, and from there we'll shift gears, start getting creative, and work on visualizing our data with Power BI reports. All right, time for the DAX homework walkthrough. Now I'm going to go through this very, very quickly. I'll try to include some timestamps in the instructions themselves so that you can jump to specific spots if you get stuck. If you still have trouble following along after I work through these, feel free to reach out and I'll try to help you. So we've got two main buckets of questions. First, we're going to create a bunch of calculated columns, and then we're going to shift to report view and create a bunch of measures. So starting with our calculated columns, we're going to start in the customer lookup table. There we are. And we're going to add a new column called customer priority. So new column, customer priority. And the way we're defining this is that it's going to equal priority for anyone who's under 50 and has an income of greater than 100,000, otherwise standard. So know we need to use an if and an and statement here. So I'm going to start with the if. Current age is less than 50. And now I didn't use the if and version. I'm going to use the double ampersand operator so that I can just separate my logical tests kind of in readable order. So if current age is less than 50 and the annual income is greater than 100,000, comment to my result if true, priority, value if false, standard, close it out, press enter, and we'll see that it's added here. If we scroll down, I believe there should be some priority customers. There they are. So that looks good. That's number one. Next up, we're going to move to our product lookup table. Here we go. And add a new column called price point. Add a new column called price point. And basically we're looking at the product price column. If it's greater than 500, price point's high. Between 100 and 500, price point's mid-range. And then anything under that is low. So rather than using and statements in here for the in-between values, since Power BI, just like Excel, is going to be reading from left to right, I'm just going to start with my highest value and then add a second if, and we should be good. So I'll show you what I mean. So if the product price is greater than 500, then the result, if true, is it's a high price point. And now a little shortcut here. I'm going to grab that whole statement, copy it, paste it as my second if statement. So if the product isn't high, then what am I testing for? Well, then I'm testing if it's greater than 100. And in that case, it's going to be mid-range. And the value of false at the very end, I don't have to add a third statement here, because if a product isn't greater than 500, and if it isn't also greater than 100, then it's got to be under 100 bucks. So that's my catch-all low statement. So if the price is over 500, high. If it's less than or equal to 500, but greater than 100, mid-range, otherwise low. So you can enter that in, scroll to the right, low, mid-range, high. These align with the prices, so that looks good as well. Next up, we're moving to our calendar table. We're going to add a new column called short day. And that short day is essentially going to extract the three first letters from the day name and capitalize them. So I'll do it in two steps just to show you. I'm going to start with just the left. So the left of the day name column, I want the 3 characters. That returns fry, sat, sun. Looks good. The only other step is to capitalize by wrapping this whole function in an upper statement. There you go, just like we created the short month column during the lectures. And then last calculated column that we're going to work with is back in our product lookup table. Here we go. We're going to add a new column, and it's going to be called SKU category. And the first part of the question is very simple. It's just the left 2 characters from the product SKU field. So left product SKU, 2 characters, press enter. This is very similar to what we practiced in the query editor, and that seemed to work just fine. Now the bonus is to modify this to return any number of characters up to that first dash. So basically make that 2 something more dynamic. If there were 5 characters or 10 or even 1,000 characters before the first dash, they would be returned here in the SKU category field. And to do that, little hint, you may need to search long and hard. We're going to use a search function here. So the number of characters returned is going to be a function of searching for the dash within that SKU field, right? And we don't need the optional arguments at the end. So I'm going to close out 2 parentheses, and let's try that. So when we scroll over, you'll see we're very close, but it added a dash at the end. That's because the search found the dash in the 3rd position of the string. Therefore, it fed a 3 into the character length argument of the left function, where we just want a 2. So a little tip, between the 2 parentheses, I'm going to just literally subtract 1 from the result of my search function, and that will return everything up to just before it finds the character, the dash, and we're good to go. So those are your calculated columns, all pretty straightforward. You can consult the solution file if you have any questions about those. Next up, we're going to jump to report view, and here we're going to create 10 different measures. Now I've included spot checks so that you can actually play with the matrix visuals and confirm that you're getting the correct results. I'm not going to create all of the matrix views to produce those spot check values. It would take too long. So I'm going to show you how to write the measures so that you can make sure you're defining them properly, and then make sure that you do confirm those spot check values so that you're good to go moving forward. So first up, we need a new measure named product models. So this is going to live in our product table. Let's collapse some of these. Right click new measure in the product table, and it's called product models. And product models needs to calculate the number of unique model product names. So every time you hear the word unique or distinct, you know you want the distinct count here. So we want the distinct count of model name from the product table. There you go. You should see 119 unique models in this file. Next up, create a measure called all returns that calculates the grand total number of returns regardless of the filter context. So let's drop this one in our returns table since it's obviously return related. We're going to name it all returns, very similar to the all orders measure that we created as well. So because we need to calculate our returns measure, that tells me I need to lead with calculate. Where is it? Total, there it is, total returns measure. And because we don't want it to respond to filter context, that means we need an all function here. And what we want to do is calculate that based on the entire total returns table. So we're calculating the total returns measure based on the entire AW returns table every single time. Press enter to lock that one in. You should see a total of 1,809 returns. And that should map to the grand total no matter how you filter out those values. Next up, we're going to use what we just created to create a new measure to calculate percent of all returns. So again, we're living in this return table. I'm going to name it percent of all returns, and that's simply going to equal our original total returns measure divided by our new all returns measure. That's going to give us a ratio, a percentage, that we can then use to analyze return rates or return proportions filtered out in different ways. So there you go, that's percent of all returns. Next up, bike returns specifically. Again, new measure in our returns table. I'm going to name it bike returns. And for this one, we're going to use the calculate function because we're calculating a total returns measure like usual. Now the filter context that we're going to add here is where the product category name specifically, equals bikes, in quotes. Press enter. Now when you run your spot check, you should see 427 total bike returns. And next up, we need a measure for total cost. And so total cost, this is actually going to go in my sales table. New measure, total cost. And actually, I'll tell you what, before I do this, rather than starting from scratch, I'm just going to X out of this one I just created. Total cost is going to be an iterator calculation that multiplies order quantities by product cost. And it's going to work exactly how we created the revenue measure by multiplying order quantities by product prices. So rather than reinvent the wheel, let's look at our total revenue measure, which is a SumX that used that related function. I'm going to literally grab that whole thing, copy it, and now add a new measure so that I can start with the total revenue and simply change this to total cost. And I still want to perform a SumX because I want row level calculations. I still want order quantity. This time, instead of pulling the product price from the product table, all I need to do is change that to product cost, and we're good to go. So we'll lock that one in as well. And when you pull that into a matrix, you should see a total cost of $14,456,986. Now from here, we can very easily create a measure for total profit that's as simple as the total revenue minus our total cost. Revenue minus cost equals profit. When you lock that in, you should see a total profit of $10,457,580.86. And now next up, we're going to start working with some time intelligence. First up is previous month orders. So orders are going to live in our sales table. I'm going to name it prev month orders. And basically for previous month, we're going to start with calculate, like all of our time intelligence. The measure we're going to calculate in this case is total orders. And for previous, we're going to use the date add function. Point to our date field in our calendar lookup. And since we want the previous month, we're going to do -1 month, and the interval is a month interval. So close out two parentheses, we're calculating total orders, and the date add allows us to calculate for the previous period, and our periods are months. So press enter, and we've got previous month orders, good to go. Now, based on that previous month orders, just like we did previous month revenue and a revenue target, we're going to create another measure called order target that's calculated the same way, which is simply that previous month orders measure times 1.1, since our target here is a 10% lift month over month. So we need 10% over the previous month to define our order target. And we're going to be using this in some of the visuals in the next section of the course. Next up, previous month returns. So same process here, we're just going to add previous month time intelligence function in the returns table. Prev month returns. You know the drill. I could have just copied the other one too, but let's do it from scratch. This time we're calculating the total returns measure using the date add, pointing to our calendar date lookup as usual. And then we're going to say number of intervals, -1. Interval is month, two parentheses, calculating total returns using that date add time intelligence function for the previous month. That one looks good. And now our final measure that we need to create is a 90-day rolling profit. And I'm going to put profit here in my sales table, new measure, 90-day rolling profit, which creates basically a running total with a time frame of 90 days. And for this one, as always, we'll start with calculate, and then this time total profit is the measure that we're evaluating, and we're going to use the dates in period option here, point to our calendar lookup date field. And then the next component, this is the only one that has this fourth argument here, the start date. And for that one, we're going to use the max of our calendar lookup date, just like we practiced in the demos. And then the number of intervals, in this case, 90 intervals. And our interval period is a day, so minus 90 days. Close out 2 parentheses, press enter, and you are good to go. So I know that was a fast and furious run through of all those measures. Make sure that you play with the matrix visuals, pull these in and out, confirm the spot check values in the homework file, because we're going to be using a lot of these measures in the data viz section coming up next. So with that, you've officially wrapped the DAX section. So get excited, because now we're going to start building some incredible reports and dashboards. All right, time to take this AdventureWorks project to the finish line. We've done all of the data engineering that we can do. We built a nice, clean, and flexible data model. Now it's time to actually bring this data to life and explore some of Power BI's visualization tools. Now we're going to look at matrix visuals, slicers, maps, KPI cards, forecasting tools. We're going to cover it all. We're almost there. Let's do this. All right, so by this point, we've put a ton of work into this. We've spent a lot of time connecting to our data sources, tying them together with a proper normalized data model, and then building out a ton of powerful calculated fields and measures to add new metrics like rolling profit, return rates, order targets. A lot of really great stuff that we've done, but the thing is, it all means nothing until we can actually communicate it and visualize it and allow users to interact with it. So that brings us to the final phase of the business intelligence workflow, which is actually visualizing the data with reports and dashboards. So let's kick off this section with a quick walkthrough of the Power BI report view. Now, we spent some time in here already working with those matrix visuals, but we were really only using those to check our measure values, nothing else. And I think you've probably realized there's a huge amount of functionality and a huge library of tools that we haven't even touched yet. So that's what I want to spend our time focusing on in this section, is working through each of these panes and toolbars and options to see exactly what we can do in this report view. So let's walk through some of them. First up at the top in our View tab, you've got some basic view options. We're going to talk about phone versus desktop layout. You can show grid lines. You can allow your objects and charts to snap to a grid for alignment. And you can also activate other panes like the bookmarks and selection pane. Down at the bottom of the screen, you'll see report pages. Now these look just like Excel tabs and they function the same way. Think of each page as its own blank reporting canvas. So a single report can be made up of multiple individual pages. In this example we're looking at here, and the example that we're going to build together, we're going to have an executive summary page, a product detail page, and a customer detail page. On the right side, you've got 2 primary panes. These are like mission control for reporting, visualizations and fields. So starting with visualizations, this shows you all of the chart templates that you have to work with. Charts, slicers, matrices like we've been working with, different types of maps, etc. And just keep in mind that for the purposes of this course, we're working with the standard kind of default set, none of the preview options, but it's very, very easy by clicking those 3 dots in the lower right to import either new preview visuals or to import custom visuals. Now on the right, you've got your field list. We've seen this before. It's accessible in the data view as well. This is simply where you can access all of the fields and all of the measures and columns across all of your tables. Now right beneath the visualizations box, you'll see a pane that includes fields, format, and analytics. So there are actually 3 panes embedded within this. Now by default, you're going to start in the fields pane, which is what we're seeing here, because that's where you drag in your metrics. It's how you actually tell Power BI what you want that visual to be showing. So in the matrix view, we had rows and columns and values. In this example, we've got a KPI visual that needs an indicator, a trend axis, and a target goal. So what you'll notice is that these panes are completely dynamic. you'll see different options depending on what type of visualization you're using and what fields and objects you have selected. So the fields view within this pane is where you drag those columns or dimensions and values. The next tab, the little paintbrush, contains all of your formatting options, which we'll dig into. And the third, the little magnifying glass, that's called the analytics view, and that includes options to do some interesting things like trend lines and forecasts. Now the last thing to note here is the filters pane, which includes 4 different types of filters: visual level, page level, report level, and drill through. We're going to talk about those and practice them in a later lecture, but for now, just remember that those impact the specific scope of data that gets filtered. So let's quickly jump into our report view and take a look for ourselves. All right, here we are in our AdventureWorks report, right where we left it at the end of the DAX section. What we can actually do here is go ahead and delete this matrix visual. So now I've got a fully clean canvas, clean slate to work with. And now you'll notice those view tabs we talked about. You can show the grid lines. You can enable the snap to grid if you want to make sure you're working with clean alignment. You can activate your bookmarks pane or your selection pane, which just pops up next to visuals. And then let's uncheck grid lines. Down at the bottom, see we've defaulted to page 1. You can easily add a new page or delete it, just like Excel tabs. And then here's our command center, visualizations and fields. So these can be collapsed if you want to save space, but these will always live here on the right side of your view. And as always, we've got access to all of our fields here. And then as soon as we drag in a visual, we'll have access to the fields options as well as the formatting options in this pane. So with that, let's go ahead and get started by adding our first objects to our report. All right, so let's kick things off pretty simple with inserting objects in basic charts. Now, there are at least 2 ways to do this in Power BI. One way is to either click on the visual icon itself from the visualizations pane, or head to the Home tab. You'll see this Insert grouping of tools, and from there you can add new visuals, as well as text boxes, images, shapes, and buttons. Now, the other way to add a visual is to grab a field directly from your field list and drop it onto the canvas. And that will automatically generate a new visual, and typically it's a column or bar chart by default. So super simple. I think you'll find throughout this section of the course that a lot of these tools are very easy, very intuitive, and user-friendly. So let's go ahead and add our first object. All right, so it's officially time to start building our AdventureWorks dashboard. Hope you're excited. We're going to start very simple, about as simple as it gets, and simply drag in or import the AdventureWorks logo. So to do that, in our Home tab, we're going to look at this Insert group of tools and simply click Image here. Now, I have a folder on my desktop called AdventureWorks. It's where I stash the data as well. I also have an AdventureWorks logo PNG file, which is available in the course resources. Go ahead and double click, and it just drops it right here on my canvas. So you can click and drag to move it around and reposition it. You can click and hover over the edges or the corners to resize, however you'd like. And we're going to be moving and tweaking this stuff quite a bit as we polish the design and layout. But for now, I want it somewhere right up here in the upper left corner of the dashboard. Now, taking a peek at some of these view tools, you can show the grid lines. And again, this is just a point of reference if you want to align your objects to horizontal or vertical lines. For now, I don't want that. We can snap our object to the grid. And that means when you move this around, it'll move kind of in a chunky way. And it's chunking or snapping to an underlying grid. Again, another tool to help with alignment. So up to you if you want to enable or disable that one. And then lock objects is helpful. See, I can't even drag it and move it. And you'll see this can actually come into play once you have a number of different visuals on the same page. It can get very tough to kind of navigate through things without accidentally selecting and dragging your visuals. So that's the lock objects view. We're going to talk about the phone layout versus the desktop layout later on. And then page view, you can choose whatever option you want. Right now we're at fit to page, which will work just fine. Now, last item here, we've defaulted to page 1. just double click to rename that page. And we're going to name this one Exec Summary and press enter. And there you go. Step 1 of our AdventureWorks dashboard is complete. All right, the time has come to officially add some true, proper visualizations to this dashboard. Now remember, there are a few ways to do it. Number 1, from the home menu, click New Visual. As you can see, it's defaulted in this case to a stacked column. That's not what I want, so I'll press Delete. Instead of going with the home menu route, I generally choose my visualizations straight from the visualizations pane. So in this case, I'd like a stacked bar chart specifically. And when you click and select a chart template, a few things happen. First, you'll see that it drops a template or placeholder for that chart right there on your canvas. And second, it populates these fields as well as formats that are specific to the chart type that you're using. So again, this pane is dynamic. Right now it's telling me that a stacked bar chart can take in an axis, a legend, values, color saturation, and tooltips. But if we change this chart type to something else, like a stacked area, you'll see these values change, or funnel, or scatter. So these are all dynamic, and they're all tied to the specific chart type. So let's jump back to our stacked bar and start actually populating this. Remember, we're always going to start here in fields because this tells Power BI what data we want to visualize and exactly how we want to visualize it. So what I'd like to visualize here is total orders, that measure we created in our sales table. So let's go ahead and grab that measure. And the first option is to click, hold, and drag it into value and drop it there. And as you can see, it's populated the chart with a single series of values, total orders, with the grand total, just one bar. Now remember that if you want to format a field, you can do that here. Select total orders, modeling. In this case, let's add a comma to it. And now as you hover over, you'll see that the format has changed. So this is nice, but not very helpful. It just shows a single bar. So the idea here is that it will be helpful to break this data down and analyze the total orders in some interesting ways. And I know that AdventureWorks is very interested in their subcategory level performance. So let's go ahead and break down this chart by product subcategory name. And now remember how we clicked and dragged the values field? You can also try clicking the box, and Power BI will say, okay, what's the most appropriate place where I can populate that field that you just checked? In this case, it puts it on my axis of the bar chart, which is actually exactly what I want. It breaks down my total orders, and now I've got a field or a dimension for subcategory on each row. And it's automatically defaulted to sorting descending. It tells me that tires and tubes is the highest order driving subcategory, followed by road bikes, helmets, mountain bikes, etc. But just to get a sense of what these other options could do, what if we took subcategory name and instead of dragging it to axis, we dropped it on the legend? Well, that completely changes the visual, and it basically shows the grand total segmented out with a different legend value for each of the subcategories. So not the proper chart type here. I mean, it's kind of nice to look at, but it's not very helpful. So we're going to take that legend, drag it back to axis, because that's what we want. Now we know what values do. Values is almost always where you're going to pull your measures in. And now what about color saturation? If you're curious about what that does, honestly, the best way to learn this stuff is to just try it out and see how it looks. So let's grab our total revenue measure here, drag it into color saturation, and look at that. The chart itself is still showing the same data, but now as you hover over, it's giving you an additional piece of information, which is the actual revenue in addition to the orders. And not only that, but it's visualized in a subtle but very effective way the relative revenue of each of these subcategories. So they're still ordered by the order volume, but now you see these darker blue lines represent the subcategories driving the most revenue. In this case, road bikes drove 11.3 million in revenue, mountain bikes 8.6, touring bikes 3.8, and then these lighter shades are smaller amounts. So that's color saturation, which is a really nice way to add an additional level of data without making the chart overwhelmingly busy. And now we also have this option called tooltips here. And to show you what that does, let's grab total profit and drag it into tooltips. And you'll notice that nothing changes except the title now reflects total orders, total revenue, and total profit, which is the tooltip field that we just added. Now all it does is add a third piece of information to this box that pops up when you hover over. That's what Power BI calls a tooltip. So now by simply hovering over and interacting with this chart, I'm getting information about order volume, about revenue, and about profit broken down at the subcategory level. So very, very little effort, and we've already created a lot of very interesting insight with one simple visual. And trust me, it's only going to get better from here. All right, so in the last video, we talked about inserting and modifying basic visuals. We added our nice little bar chart here, talked about some features like color saturation and tooltips. But the thing is, Power BI has changed quite a bit since the course was originally recorded. We still have all the same functionality. It's just that some of these tools live in different places now. And I added an overlay to the last video to help people find these new features, specifically color saturation. But I still get a lot of questions about it, and I've realized that it's really hard to find those options. So what I want to do is just put together this very quick video, and we're going to rebuild that same chart using the current version of Power BI. So I'm in the, you'll see the light mode here. I'm in the 2020 January release. I'm going to insert a bar chart here, grab subcategory name, drop it on axis. I'm going to look for my orders, drop that on values. And there we go. We've got kind of our basic version of the bar chart. And now here's how we get to the color saturation option. Remember, originally it existed right here in the main fields pane. Now we have to navigate to format, which is the second pane here, drill into the data colors well, and you won't see any obvious color saturation or conditional formatting options right here. What you have to do is hover the cursor over the default color line until you see this ellipsis, the 3 dots. Click that, and there are the conditional formatting options. Don't ask me, I don't know why they buried this feature like that, especially given how popular and powerful conditional formatting is, but that's where you'll find it. Now that you know, you should be able to get there quite easily. So this menu should look pretty familiar. Let's go ahead and just drop a very light pale blue on our lowest value. We'll keep our highest value with this darker teal. And check this out. We can update which field we're actually formatting based on. So in this case, to match our demo, we wanted to do a color saturation format on total revenue. There we go. Press OK. And boom, we've replicated our original chart. Now, the only other catch was that we had the tooltips option in the fields list, which you'll still see here. When we dropped our revenue field into color saturation in the last demo, it automatically added revenue into our tooltips. Now in the new version of Power BI, we need to manually make that change. So let's go ahead and grab the revenue field, drop it into tooltips, and there we go. We see it listed in the 3rd line of our tooltips. So there you go. Hope that was helpful. Color saturation in the current versions of Power BI. Next up, we're going to talk about Power BI report formatting options. Now, this is all about customizing the look and feel of your visuals. The fact is, there are a ton of different formatting options, and they vary pretty drastically between chart types. So rather than show you every single option for every chart type, which wouldn't be a very effective use of time, I'm going to demonstrate what some of these sets of formatting options look like for different types of charts. And then we're going to go into Power BI and practice customizing the format for our stacked bar chart. So here we have 3 very different types of visuals. We've got a combo chart on the left, which is a line and column. We've got a matrix visual in the center and a donut chart on the right. Now, looking at formatting options for the line and column combo chart, you've got a number of different categories there: general, legend formatting, X and Y axis, data colors and labels, shapes, plot area, title background, lock aspect, and border. And within each of those, you have additional options. So just within the x-axis formatting options, for instance, you can change the type, the scale type, you can fix a starting or ending value, update the color, text size, font, and display mode. So these menus are packed with options, and those options, like everything else, dynamically update based on what you're working with. Now for the matrix view, you'll see a slightly different set of options here. Now you've got matrix style options, grid options, column and row headers, subtotals, grand totals, conditional formats. So that conditional formatting field is one of the more interesting ones here. That allows you to do things like add colored backgrounds, or change the font color, or add data bars dynamically to draw attention to high or low values as a visual indicator, similar to how we used the color saturation option in our bar chart. And then looking at donut chart options, again, it's got its own totally different set of options here. And drilling into some of these, you've got detail labels, where you can change the style and text and font settings, and then a title, which you can align and customize as you see fit. So again, thousands and thousands and thousands of different combinations of formatting rules that you could apply. But the good news is that A, Power BI's default styles and formats are actually pretty thoughtful and polished, more so than with other tools that I've used in the past. And B, it's all extremely user-friendly. So by simply poking around and testing out different combinations and variations, you'll pretty quickly get a grasp on what these options mean and how they all work. So with that, let's head back into Power BI, and we're going to explore some of the formatting options for the bar chart that we've added. Okay, so we're back on our canvas. You'll note that when I don't have the chart selected, I don't see my options here for either fields or formatting. So make sure that you select the chart that you're interested in, and now you'll see those fields populate. This time we're interested in the second tab of this pane called Format. And as you can see, we've got all of these categories of options, each of which includes sub-options for us to customize the look and feel of this chart. So I'm going to quickly pass through each of these, maybe touch upon a couple of the key concepts, but I'd recommend that you take some time to explore these menus on your own as well. So general, basically this is about height, width, positioning. Typically you won't really touch the general options. Y-axis has a bunch of options here. So this is everything related to the Y-axis of our chart. I'm going to drag it closer just so that it's side by side. So you can turn the entire axis on and off first and foremost. And when you turn it off, obviously those options are now inactive. But let's keep the Y-axis because I want to see those titles, those labels for each subcategory. You can change it from the left side to the right. You change the color, the text size, even the font family. And then if we expand this out a bit so we can read, minimum category width, literally just give it a shot and see what happens. Just changes the actual width, in this case, almost like the height of each bar. Maximum size changes kind of the length of each bar. And then inner padding is if you don't want that blank space between bars, you can eliminate that entirely. Let's make this a little bit bigger. And then the last option here on the Y-axis is the title. So an axis title assigned to your Y. Keep that off. So let's say we've made some changes and now we've changed our mind and we actually don't like the updates we made. Every one of these menus has a yellow revert to default option on the bottom. And when you click, it takes me right back to where I started. So really helpful feature there. So those are Y-axis options. Very similar tools for the X-axis. So now I'm dealing with this horizontal axis down at the bottom. Some certain chart types will have different scales. In this case, it's just linear. That's the only option. Start and end will default to auto, but these basically say, do you want to customize the minimum and maximum values along that axis? So you could say, sure, instead of 10,000, let's have it go all the way to 30,000. And it essentially shrinks these bars down because my max is now 3 times larger. You can simply delete that to go back to auto. And again, we've got color, text, font, Display the units in different ways, thousands, millions. Decimal places, turn the x-axis title on and off, turn the grid lines on and off, change the grid line style. In this case, maybe we go with dashed and change them a little bit darker, like so. And those are our x-axis options. Now, data colors, you can see because we have a color saturation applied here, it gives us the option to customize this gradient that we're looking at here. Diverging basically just adds a third center point. You can see how it makes the middle values kind of this light, almost white color. We could customize this if we choose and say, let's make the minimum red, center maybe yellow, and the maximum this kind of greenish blue, almost like a rainbow. And then say, okay, never mind, we don't want that. Let's revert to default. And you're back to where you started. Data labels, this might be helpful here. So you can activate the labels and you'll see them populate here in your chart. Let's change the color to make them a little bit lighter. Let's go one more dark than that. There we go. And then those same number tools, display units, decimal places. You can position them inside of the bars, outside, automatic, change how they react to overflow when the chart's resized, and then change the text size, font, and background will basically just put a little bar behind it. So I think this is good. They're light, they're very subtle, but they're there if you need them. Let's go one size up to 9. And those are the data label options there. Plot area, not much to do here. You can add an image behind the chart. Since there's nothing behind it, transparency is not going to do anything. Chart title, this is one that I do want to update here because it defaults, auto-populates based on the fields you've dragged in. So right now the title is kind of awkward. It's total orders, total revenue, and total profit by subcategory name. So let's simplify that a little bit because we're really just focusing on total orders by subcategory. There we go. And there you go. It's updated the title. And what I'd like to do, you can add a background and a font color. So I'm going to add kind of a darker gray and a light font color. Kind of make that title pop a little bit. I'm going to align the title in the center and let's make it bigger to a size 12. And again, you can change font family. You can follow along exactly how I'm doing this, or you can format using your own style. Totally up to you. So those are the title changes that I'd like to make. Background, you can turn on or off. Just sets basically a background color like so, and a level of transparency. In this case, I don't want the background. Lock aspect ratio. This just says when you resize the chart, do you want to keep the exact proportions? So this fixes the proportions. When that's off, now you can kind of resize however you want. And then our last option here is the border, on or off. That one's a simple one. So let's keep the border off unless you choose to keep it. Totally up to you. So that was a lot of options, a lot of formatting tools, but we've made a couple tweaks here. We've added data labels. We tweaked our X grid lines, made them dashed, and then updated our title here as well. So again, you'll come across some other formatting options when you start dealing with other types of visuals, but for the most part, they're as simple as those ones that we just walked through. So there you have it, chart formatting options. All right, next up, we're going to talk about the incredibly powerful filtering options of Power BI reporting. Now, within the filters view of the report pane, you'll see 4 primary filter types. First, you have visual level filters. Now, these are the most narrow of scope. They apply only to the specific visual in which they are defined. Next up, you have page level filters, and any filters applied at the page level will impact any visuals on that specific page or tab of the report. So they're broader than visual level filters, but more narrow than the third type, which is a report level filter. Report level filters are the broadest of all. They apply to all visuals across all pages of the report. So this is where you'd use a blanket filter that you want to just apply universally. Now keep in mind that DAX filter measures, like all or filter, can still change and overwrite the context created by a report level filter. So there's a lot of interplay here between filter context being created in different types of ways, and we'll talk more about that throughout the section. The fourth type of filter is a drill through. This one's a little bit different, and we're going to dedicate an entire video just to drill through filters. But basically, they apply to pages, so it's similar level as a page level filter, but they dynamically change based on user click paths. So they're really useful tools and certainly worth a video of their own. Now, across all filters, you have a number of different settings. You've got your basic options, which are like checkboxes. You can select one, all, or multiple items. You've got top end filtering, which lets you say, filter down this visual or this page or this report to the top number of items based on some quantitative value. In this example here, we're filtering down to just the top 2 items based on total orders, which is a measure. And then you have advanced options, which look a little bit different, whether you're dealing with a value field or a text field. But this is basically the same idea as those value or label filters that you would find in Excel or in a pivot table or in other tools. So if you're dealing with values, you've got logicals like less than, greater than or equal to, etc. And for text, you have contains, does not contain, starts with, is not, is blank, etc. So let's jump back to our report and see exactly how these things work. All right, so check this out. What I want to do is add another bar chart to help demonstrate how these filters work. But instead of creating a new one from scratch and then having to recreate my formatting, I can select my existing one, press Ctrl-C to copy, and then Ctrl-V to paste another version of it right here on the canvas. And now for this one, instead of showing subcategory, I want to display this chart by category, so a little higher level. Now I can just go ahead and find the product category lookup, and instead of removing subcategory, I'm just going to take category name and drag it in above subcategory. And what it does is it shows me the highest level data, which is category, but now allows me to drill down with this button in the top left, the double down arrow, to take me down to the next level. And this works just like the matrix view worked as we were QAing and spot checking our measures. But now we're able to do this same thing with a visual representation. So I do want to make a couple tweaks to this category level view. For one, I'm going to remove the color saturation here so that it's one solid color. Then I'm going to go into the formatting, and I do need to change the title since it still says orders by subcategory. So I'm going to just change that to orders by category. And there we go. Now, as far as filtering in a report is concerned, the simplest way to filter has nothing to do with the filter pane. I don't have to drag any fields or do anything except click into my charts. And you see what's going on here? As I click into my category chart, my subcategory chart updates as well. And that's not just because I copied and pasted a second version of this chart. Even if I created a brand new one from scratch, that interaction would still take place by default. So what's happening here in technical terms is that my selection, like when I select the bikes category, for instance, is creating filter context that's impacting everything on this report page. In this case, including my subcategory chart. So with a simple click of the mouse, I'm already able to drill in and explore and see trends in this data that otherwise might be very difficult to see. And to make it even more visible, I'm going to go ahead and pull the color saturation off of my subcategory chart as well. And now you can see very clearly which subcategories fall into certain categories. So bikes, clothing, and accessories. Now, to show you how the actual filter pane works, I'm going to copy this category level chart that we created, and let's go ahead and add a page and paste it right here on this page. Now, returning to our exec summary, I'm going to select the category chart and scroll down to my filters pane right here. And you can see by default, it's pulled in all of the fields and dimensions that are currently part of my chart. And you can go ahead and drill in and see your filtering options right there for each. And by default, these are placed in the visual level filters window of that filters pane. So for instance, I could say, I only want this chart or this visual to show bikes, or only bikes and clothing. And you see how those changes are only being impacted in this chart? They're only reflected here. My subcategories still show all of my subcategories across all categories. So this filter is essentially constricted to the universe of just this visual. So those are my basic filtering options. Let's quickly take a look at some of the others. I could say, show me the top N items, which are categories in this case. Let's say top 2, since we only have 3 to work with. And the by value is basically how are you defining top 2? How are you defining those ranks? So we could say, let's show us the top 2 by profit. And we click apply. We get accessories and bikes. Clothing disappears because clothing did not make the top 2 as far as profit driving categories are concerned. So we change our mind. You can click this little eraser icon to clear that filter. And then you've got your advanced options here, which really aren't that advanced. They're just those text or label specific fields like contains, does not contain, start with. These are pretty straightforward. So I added a filter for categories starting with B and applied it. There you go. I only see bikes. Now if I say does not contain bikes and apply it, now I see accessories and clothing. So these are all very user-friendly, very straightforward. The most important thing to remember is the scope in which your filter is applied. So everything we just did was visual level. It only impacted this chart. Now let's practice a page level filter. So what I'll need to do is grab a product category name again. I'm going to drop it into page level. And now watch what happens when I select bikes. See how both charts on the page were impacted? Same thing if I add clothing and then add components. Well, components weren't sold, so if we add accessories, there you go. Now we're back to 100%. So we're using the same filtering tools, except now instead of just impacting one chart, it's impacting our second chart and potentially any other charts that might exist on this page. Now the important thing to note, let's go ahead and select bikes alone again, is that if we jump to page 2, this visual is on a different page, so it's not impacted by a page level filter that was implemented on the exec summary tab. Only visuals on this tab, on this page, will be impacted by a page level filter. So let's go ahead and clear that one. And again, we're going to cover drill throughs in its own separate deep dive. But what I'm going to do is grab another copy of category name and pull it into the report level filters. And now very similar idea, select bikes, filter down, and click to page 1. This one's filtered down as well. So as you can see, report level filters are the universal filters that impact everything in the entire file. So let's go ahead and clear these. I'll erase that. Don't need a page level filter here. So now a little bit of formatting, rearranging here. I'm just going to make these a little bit skinnier. And like I said, we're going to keep kind of tweaking and adjusting as we go. You can follow along exactly if you'd like, or you can kind of follow along loosely or not follow along at all. It's totally up to you. So I'm going to start kind of with something like this. And again, we could snap to grid if we wanted it to be exact and perfect. But this looks good for now. We're going to tweak some things a little bit more as we go. So those are the filter settings and the core types of filters in the Power BI report view. So as you can see, they're really, really powerful, and they're going to allow us to do some really interesting and pretty advanced things. So now that we've covered the field options, the formatting options, and the filtering options, the next phase of this section is going to be demo mode. So from here, we're just going to play with all different types of visuals. We're going to add matrix views, slicers, timelines, KPIs, text cards, maps, tree maps, gauges, and so on and so forth. We're going to add a whole bunch of visuals to build out this dashboard. And then from there, we'll start exploring some of the more advanced or nuanced concepts like adding drill through filters, customizing visual interactions, adding bookmarks, parameters, and some other really interesting tools. So there you have it. Those are your Power BI report filter options. So at this point in the course, it's time to shift gears into demo mode. So no more slides for a little while, no more broad concepts. It's time to roll up our sleeves, stick right here in our reporting pane in Power BI, and focus on individual chart types and visualizations that we can use to build out this report view. So looking at what we have here, we've got orders by category, got order info by subcategory as well. We know that our AdventureWorks client really cares about product level performance too, not only in terms of orders, but in terms of how frequently certain products are being returned. So I need to capture some of that data here in our executive summary. And what I'd suggest that we do is use a matrix, which you're already familiar with. We use this quite a bit in the DAX section of the course. And this is a great way to show a lot of information without it being overwhelming. So we'll use some of the drill through capability here and some conditional formatting to make the numbers really pop. Now the data that I want to show lives in the sales table. So let's go ahead and grab total orders. We're going to pull that into values. And let's also pull return rate from our returns table as well. So we've got two columns of values, and the level at which we want to view these values, or the row labels that we want to use to segment them, will come from the product lookup table. And we actually want the product name. So I'll drag that into rows, expand this down a bit. So now we're looking at total orders and return rates at the product level. And one thing that's cool about these matrix views is that you can just click on the header and it will sort. So we can default to sort the products that drove the most orders. So in this case, we see that water bottle, 30-ounce water bottle drove the most orders, followed by the patch kit and then tire tubes. Now this is good. It's a lot of information here, but one thing that I think we can do to really make this come to life a bit more is add some conditional formatting. So we can go ahead and navigate to the format pane. And obviously you've got matrix specific formatting here. You can change different kind of matrix styles if you want. And again, you can always revert to the default. And generally speaking, the default is actually going to serve our purposes pretty well in most of these cases. So I'm not going to mess with tons of different formatting options as we build this out. But what I will do here is go all the way down to conditional formatting. And it lets you format each series individually. So starting with total orders, for this one, I want to add data bars. And you can see what each of these looks like. So those are data bars. That's the font color. And this is the background. So font color and background work same kind of way. It's just you're either updating just the font itself or the whole background of the cell. So for this total orders column, because it's a volume column, I kind of like using data bars. And that will really draw attention to the difference between some of our top drivers and some of our lower driver products in terms of orders. So I can stay right here in the formatting pane and format return rate. And instead of data bars for the return rate, because they're going to be kind of all over the place, what I'd rather do here is kind of a subtle background conditional format. So this is not subtle, this is very loud and aggressive. What I can do is drill into my advanced controls here and determine exactly what this gradient for my conditional format should look like. And in this case, instead of this crazy green to red scale, for something like return rate, which is a negative metric, what I'm going to do is reverse this, first of all, because high values of return rate, that's a bad thing, not a good thing. And I'm going to adjust the colors themselves to make them a little bit more muted. So the maximum, meaning for bad return rates, I want this kind of pale red. And for the minimum, I want a white. So this basically means that products with an okay return rate or relatively low return rate will show up as white. There won't be huge negative attention drawn to them. And only the ones that really start to have some of the higher levels of return rates will start to pop with this red shading. So let's press OK there. And as you can see, it's pretty subtle, but in this case, it does get the job done. So you can see certain cases where individual products are popping a little bit more, like this Rhodes 650, whereas the other ones with kind of average or decent below average return rates, those kind of just fade in with this white background. So feel free to make your own adjustments, but that's kind of my personal style. Keep it a little bit more muted while still drawing attention to the key trends. Now, last thing that I want to do with this matrix view is go back to fields, and instead of only showing the data by product, just like I showed you before, let's go ahead and grab the subcategory, which is beneath my product lookup. Bring the subcategory name in, as well as the category name. And then you know the drill. No pun intended. You can drill all the way back down. So now I'm seeing that same product level view, but I've just given the user the option to aggregate if they choose to do so. And one last note here, that little forked arrow, the third option, that will expand down all the way one by one until you're seeing not only the lowest level, the products, but you're also seeing them grouped into subcategories and then into categories. This is very much like the outline table layout in a pivot table in Excel. So just go ahead and drill back up and then back down to get back to where we started. So I love these matrix views. I think they're incredibly useful and insightful. They pack a ton of information, and these conditional formatting tools are great ways to really bring some of that data to life and expose some interesting patterns. So there you go. That's your report matrix view. All right, next up, let's talk about slicers. And you'll see the slicer icon. For me, it's in the lower corner. It looks like a little table with a funnel on top of it. And basically, a slicer is a fancy word for a visual filter. So it behaves just like any other filter, and it applies filter context just like any other type of visualization. And it's a very simple object. It only takes one input, which is some field. So if we were to take something from territories, for instance, and drag country in, it just creates a list of checkboxes. And again, these pass filter context, just like any other filter or visual. You can clear them like this. And you can also format this as a dropdown, which behaves exactly the same way, just a little bit of a stylistic difference. So nothing special about regular slicers. They act just like slicers in a pivot table in Excel as well, but where they get really interesting is when you pull in a date field. So let's go into our calendar, grab date, and swap that in place of country. And you might be thinking, okay, well, what's so great about that? It's the same exact thing. You're just listing hundreds and hundreds of dates. Well, the thing is, we've got additional options now. Check this out. So between is actually my personal favorite. Between allows a user to set a start date and an end date by dragging these handles on a timeline and customizing the exact date range that you're looking at. You can also type fields and use this calendar pop-up, which is really, really slick, in each of these input boxes. So that's the before option. The between option. Before basically just gives you the end date to play with. After only gives you the start date. And then you can do the normal list or drop down. The last one that's really interesting is relative. And so this allows you to choose things like show me the data from the last 30 days, right? Or the next, or this week, or this year, whatever it could be, any combination of these fields. Now you might be wondering, why did everything blank out when I chose 30 days? Well, look at the date range. This is current data. It's based on actual real-time information, not the data in my data model's calendar. So that particular option is really great when you have current real-time data. You could use this relative option. For now, I think between is going to be our best bet, so that we'll have full customization over the window of data that we look at. Now, stylistically, only a couple changes that I think we should make to this formatting. Go into Format tab. I don't want the header, it's just redundant. It's pretty clear that we're looking at dates here. And for the date input formatting, let's just give it kind of a light gray background to make those numbers jump off the page a little bit more. And there we go. So let's kind of position this up here We can resize it. I like putting my main controls kind of at the top to make it clear, that these are impacting everything you're seeing on this page. Now, already this date slicer is going to be useful because see what happens when we start looking at 2015 dates alone. All we have are bike category sales, and because we only have bikes being sold, there's only a handful of subcategories, in this case road bikes and mountain bikes, and obviously all of our products are bike related products. So something changed in AdventureWorks' sales strategy or their corporate structure where they didn't start selling other items until it looks like later in 2016. So turns out that they're not really interested in analyzing the data from 2015. It was kind of a different world. They were just a little bike shop back then. So good opportunity to use a report level filter here. And what I'll do is, I'm not selecting any specific visual. I'm going to go and grab that year column from my calendar, drop it into report level filters. And then what we can do is set a basic filter type and select 2016 and 2017. And you see that it basically just summarized what I'm doing here. Year is 2016 or 2017. And now everything in here now reflects that report level filter. Even the timeline itself, I can no longer extend my start date before January 1st, 2016. So now I can be sure that the date ranges that we're looking at here, with the exception of some early dates in 2016, should reflect all of the categories that AdventureWorks is selling. Now, a little tease into one of the more advanced concepts here called syncing slicers. You may have noticed on the View tab, there's this option here in the Show group that says Sync Slicers. That opens up a menu that allows me to determine basically the scope of impact that this slicer has, because generally these visuals are going to impact other visuals on the same page. In other words, their filter context will apply to visuals on that same page. But slicers, if you want kind of a more universal control, in a similar way that you would set a report level filter, you can allow a slicer to sync with other pages and therefore control the data and the visuals without having to duplicate and have two different versions of the same slicer operating on two different wavelengths. So right now it's showing me that I have two pages in my report, exec summary and page 1. If I show the filter and sync it on both the exec summary and the page 1 sheet, what this is going to do is create a copy of this timeline, and it's going to put one right here on page 1. And not only that, but when I make a change to one of them, like to 7.1, the other changes as well. So these are now synced together, and both the slicer and the reports or the visuals on those pages are adjusting accordingly. So that's a great way to make your kind of controls apply not only to the current page and not only to the entire report, but potentially to only specific pages or combinations of pages. So in this case, I don't actually want to sync that. We can close the sync slicers view. And in fact, we don't even need this page 1 anymore. It's kind of just scrap anyway. So let's delete that page. And there we go. We've got our date slicer here, our matrix, our bar charts. Things are coming along pretty nicely. Next up, we're going to dig into cards and KPIs. All right, I'm really excited about this next demo. I'm going to talk to you about cards. And it doesn't sound that exciting, but trust me, it's pretty cool. So we've got 3 types of cards that you'll find in here. Single row or regular card, looks like a 1, 2, 3 icon. A multi-row card, and my personal favorite, the KPI card. So these are all great ways to draw a lot of attention to very big or very important numbers, or KPIs, key performance indicators. And let's start with our basic card. And it's a very simple object, requires 1 field input. Okay, so let's go into sales. And if our focus right now is on revenue, let's go ahead and bring revenue into the fields box. And there you go. You have literally just created a card. That's it. 1 step and you're done. There aren't even really many formatting options. for cards as well. You can give it a little background, change the font, but for all intents and purposes, that's it as far as cards are concerned. Now, instead of deleting this and adding a new visual, with the card selected, I can change the visual type to a multi-row card. And it changes the format, the look and feel a little bit, and more importantly, it now allows me to drag in additional fields, like total orders, for instance, and kind of show them side by side. If you resize, they'll stack differently. So again, it's a nice way to just literally draw attention to individual numbers in your report. So cards and multi-row cards are fine, and we'll use them in a couple different cases. But in this lecture, I really want to focus on KPIs. So we're going to insert this KPI. It's got the up green arrow and the down red arrow. And this is not only going to allow us to show a big important number, but it's also going to integrate elements of trending and of positive or negative performance all within the same view in a really nice, clean, visual way. So let me show you what I mean by that. We're going to focus on revenue as a key number here. So I'm going to take total revenue. I'm going to drag it into this field that says indicator, okay? And it doesn't do anything just yet because the KPI card needs some more inputs. In fact, it says right here, it needs a value and a trend axis. So what does that mean by trend axis? Well, it means that you care about total revenue, but instead of just showing the overall total revenue number, in which case you'd use a regular card, what time period are we interested in? At what level do we want to show the trending performance? And what current period do we want to be reflected in this card? So we're going to need a date-related field. Let's drill into our calendar. And this will just determine the level of granularity that we want to show revenue trending within the card. Now, I think month is probably a good level. It's not too granular. It's not too broad. So I'm going to take start of month and drop it into the trend axis. And check that out. Without even doing anything else, it's already given me a really insightful view here, showing that revenue trend in the background over time, month by month, as well as the current month revenue total, big and bold right in the center of the card. So remember, that trend axis not only determined that trending area in the background, it also determined what time period this number reflects. And since we're trending at the monthly level, this revenue shows current month. And to validate that, we can actually insert a matrix just for a little QA. I actually find myself doing this kind of thing quite a bit. And we can pull in total revenue to the values and that same start of month into our rows. And remember how it kind of automatically creates that hierarchy. Just want start of month. And there you go. So you can see that the latest month drove $1.8 million of revenue, which is reflected here. So far, so good. But you'll notice that the KPI card takes one more field. It's optional, but it takes it. It's called the target goals field. And what this will do is add one more layer of insight here and indicate whether this 1.83 million monthly revenue figure is good or bad. And how we define good or bad is a function of whatever we use for the target goal. Now, there are two options that I can think of off the top of my head that would be valid choices for a target goal. Number one is our revenue target that we actually defined. And if you recall, looking at the DAX, it's our previous month times 1.1, basically a 10% lift over previous month. Now, we're going to be using these targets for both orders and revenues on the product specific page a little bit later on. So I'm going to hold off on that one for now. And in this case, for this KPI card, what I'm going to use as my target goal is just the previous month's revenue. So when we drag it in and drop it into target, we get that nice little check mark. It all formats to a nice green. And it also shows me the value of that target goal, which is previous month revenue, 1.77 million. Which again, we can confirm and validate here in our little matrix view. So that's a KPI card. Fantastic way to draw a lot of attention to the most important numbers for your business. And since AdventureWorks is very much interested in their revenue, in their order volume, and in their returns, I think it would make sense for us to create cards to capture those three KPIs. So no need to reinvent the wheel. Let's copy this one, paste another version down here, and instead of revenue, we're going to basically go through the same process for total orders. So swap in orders instead of revenue. Instead of the target goal being previous month revenue, we want previous month orders. And there you go. We can also pull orders into our matrix to help QA that field as well. Total orders. Okay, so current month total orders 2146, which is correct. And it's just barely down, less than 1% compared to last month, 2165. So essentially flat, but a little bit down month over month here. So now one more, we're going to copy the order one, paste it one more time. And this time I want to show a KPI card for returns. So you know the drill at this point. We're going to go into our returns table this time, grab our total returns, swap them in for total orders, get rid of the order target, and pull in previous month returns. Now wait, we got fewer returns and it's formatting red as if that's a bad thing. And the fact is fewer returns is good. We want to see a drop in returns month over month. So no fear, there's actually a very easy way to change that. And that's to go right into our formatting options, color coding, direction. See how it says high is good? Just change it right to low is good. And now if it's a drop month over month, that's a good trend. So there you go. Now we've got KPI cards for revenue, for orders, for returns. We can go ahead and get rid of our matrix here. And last thing, probably should have done this first, but let's go ahead and just change the titles here. Instead of this wordy total revenue and previous month revenue, let's just call this monthly revenue. Let's name this one monthly orders. And finally, monthly returns. And the final step is just to arrange things in a way that looks nice. I think in this case, I'm going to try to create some room here. And I really want to focus on revenue as the number one most important KPI. So I want this one to be kind of larger. And then maybe we put orders up here in the top right and returns in here. I'm obviously squishing things in because we've got more visuals that we'll be adding shortly. And again, you can kind of adjust this as you see fit. But for now, I think something like this will do just fine. So there you go. We've created this pretty simple yet pretty impactful way to show the most important business metrics for AdventureWorks: revenue, returns, and orders. So there you go. Great demo of how to use KPI cards with goals to draw attention to the most important metrics for the business. All of the demos that we just walked through with cards, multi-row cards, and KPI cards were based on quantitative or numerical values: revenue, orders, returns. But cards can actually serve another important purpose, and that's to visualize text-based fields. So to show you how that works, let's go ahead and grab the standard card. And now instead of pulling a numerical column or measure into our fields option here, I'm going to grab a text-based field from my product table. In this case, I want the product name. I'm going to drag it in. So you'll see that it automatically populates a value, all-purpose bike stand, and it says this is the first product name. So what exactly does that mean, and why did it choose all-purpose bike stand to visualize here? Because we haven't really given it any context or any conditions to work from. So in the fields list, you'll see this little drop down, and it gives me options here: first, last, distinct count, or count. Since that's really all I can do with text fields, I can't sum them or average them or do any other sort of aggregation to them. So it's defaulting to first, which you may have realized by now, that's first alphabetically. So if we change it to last, you'll see women's tights, small. Now, neither last nor first is very helpful in this case because What's the point of a card in a dashboard that just simply returns the first product name alphabetically, right? So this is where our filters are going to come into play, and specifically that top N filter that we hinted at earlier in the section. So if we take a look at our filters pane here, you'll see by default it's dragged a copy of our first product name field here in the visual level filters, but we don't have all of the options that we need here. All we have is a contains filter here, which isn't going to really do the trick. So what we can do is actually grab another instance of product name and drag it underneath, and that will give us access to the additional filtering options, the advanced filtering and the top N filtering. So in this case, what we're looking for is top N, and that way we can define which item is returned based on some numerical field. So one thing that I think might be helpful for us to show in this report for AdventureWorks is the top product in terms of order quantity, and perhaps also the top product in terms of revenue or profit. So that's pretty simple when you're able to use these top N filters. We can say show the top one item by a certain value, and let's start with our sales table. Let's make this one the top product by order quantity. So we'll grab total orders, drag it in, and apply. So then we get water bottle, 30-ounce water bottle, and in our matrix here, we already have the view set up to show products ranked by total orders, and that is indeed the top item on the list. And this, just like any other visual, will change dynamically as you adjust different filters in the report. So now we're filtered on bikes. The top selling or top ordered bike is the Mountain 200 Black size 46. So pretty helpful to have that text insight held here in the card visual. Now, a couple formatting tweaks I'd like to make. We don't need the category label because it says first product name. We could customize that, but rather than use category labels, let's actually turn on the title. And we can give this a title like top product, and then in parentheses, orders. There you go, it pops it in right there. Let's make that pop a little bit more, kind of using a similar theme that we used with our bar charts on the left. And I'll center it here, maybe bump it up to size 9 or 10, and that's good for the title. Maybe we give it a little bit of a background so that it doesn't completely blend into the page. Maybe kind of this light yellow shade here. And then last thing, if we wanted to change the actual data label itself, maybe the font, maybe make it a little bit bold. Something like that looks nice. So top product based on orders is that 30-ounce water bottle. And now let's copy that, paste another one. And all we're going to do here is instead of filtering top one product by orders, this time why don't we show the top product by profit? Just swap it in and apply. Head into our formatting and just tweak the title so that instead of saying orders, we say profit. There we go. Top product based on orders, top product based on profit. And we can align these. Speaking of alignment, one thing I forgot to mention that can be really helpful for formatting and tweaking and polish. These charts and graphs and tables, these work just like any other object in many other tools where you can control click to select multiple ones. And from your formatting tab here, you have options that you'd see in tools like PowerPoint where you can align things. In this case, I just aligned all of those shapes along this left edge. You can bring things forward, push them back. Really helpful tools just to get that polish just right. And it's as simple as that. Good example of how to use cards to visualize text-based fields. All right, I want to take a minute to talk about Power BI's map tools. Now, I've used mapping software in a lot of different places, a lot of different tools, and I can honestly say that Power BI has done it better than anyone else. It's powerful, it's flexible, and most importantly, it's incredibly user-friendly. You don't need to find data at the latitude and longitude level. You don't need to look up coordinates. If you have any sort of geospatial indicator, a town name, a zip code, a country, a continent, chances are Power BI will be able to very smoothly integrate it into its map visuals. So let's take a look at how that works. If you look at your visualizations pane, you'll actually see 3 different mapping options. This plain white globe is the standard map option. You also have a filled map option, as well as the ArcGIS maps for Power BI. Now they all work in a very similar way. They all take very similar fields, but they each have kind of their own flavor. And I'll show you a couple comparisons. But we're going to start with the basic map, and it's going to drop it right in here, right in the slot that we have left. And you can see by the fields list, it's going to ask for some sort of a location indicator. And lucky for us, we've got a territory lookup with continent and country, which we had already categorized in the datasheet as countries and continents. So they've got that little globe icon. That means we know Power BI is going to be able to handle these fields. Let's grab country and drop it into location. And immediately we get some sort of mapping happening. And what's going on, there's no data being visualized yet. There's no legend, no values, just kind of points that are pinpointing the different countries. Germany, France, UK, US, Canada. So it's a good start, but we're not quite there yet. We need to give it some sort of values to actually compare and visualize for us. So if we want to show country level performance by something like orders, which is one of our KPIs, we could grab total orders, and there are a couple places to put it, either size or color saturation. So I'll show you color saturation first because it's very, very subtle. You see that the size of the bubbles stayed exactly the same. They just got a little bit lighter, and they're actually so small that they're almost impossible to see. So I don't think that's going to be a very good option for us. Let's drag it over to size instead, and that's a little better. So you see larger bubbles now for the US at 7,851 orders. Australia's a little bit lower, 5,212, and then the European countries are in the 2000s. So to compare the other map types here, I'll show you what these look like. I can just switch the type to a filled map. It's very similar, but now it just kind of fills in the outline of the countries as opposed to putting bubbles or dots over them. So if you prefer this style, you can go ahead and stick with it. That's totally fine. Notice that the size option disappears and our total orders field has been shifted into the color saturation option, since that's the only place where values make sense here, aside from tooltips. So pretty interesting. You also have the ArcGIS option, which is a little bit more sophisticated. It's also a little bit slower and a little bit clunkier. You can see it's kind of dynamic as far as highlighting country outlines and shapes are concerned. But again, kind of slow, a little bit clunky to load. So I'm going to stick back to our original map option. And now, because viewing this at a global level isn't really that insightful, I'd like to have easy controls to drill in at least to specific continents. And that will help kind of narrow the focus or the view of this map to give us something a little bit more user-friendly. So before we do anything else, let's make a couple formatting tweaks. We actually don't need this title here, so we'll turn the title off, drag it down a bit. And one last adjustment, we're showing the bubble size by total orders, but we can also pack a lot more information for each country using the tooltips. So let's go ahead and pull total revenue as well as total profit into those tooltips. And remember, you don't see those up front, they just get embedded. So now hovering over these areas shows you not only the orders, but also the revenue and profit. So a lot of information kind of tucked away in this map. Now, in order to give the users a means of drilling into more specific areas, what we can do is add a slicer. And instead of a date slicer, like we practiced the first time, this time I want to use the continent field and just drop it in. But instead of a vertical list of checkboxes or a drop down, there's another style that's actually going to work really, really well for this layout. And that's the horizontal style with buttons. And I can access that through the formatting tools, and it's actually in the general category. And where it says orientation vertical, we're going to change that to horizontal, and we're going to resize this to fit really nicely right into this little space above the map. And one other thing that we can change while we're in the formatting here is it's only got single selection options for Pacific, North America, and Europe. But if we drill into selection controls, we can add a select all option, which adds one more button here. And we can delete that header or deactivate that header that says continent. And I think that should just about do it. We'll resize a little bit, kind of fit it nicely in here. So now when you select an individual continent, the map will go ahead and zoom in to that particular area, which makes it a bit more readable and a bit easier to interact with these different types of tooltips. So remember, one of the key criteria that our AdventureWorks clients needed to see was performance by sales territory. And by creating this map and these user-friendly slicers, we're able to provide an entire view focused on each core sales territory. So let's go ahead and select all. And there you have it. That just about fills out our executive summary. We've packed a lot of information in here, but kept things relatively clean and organized and tight. We used the matrix views, bar charts, KPI cards, text cards, maps, and a date slicer. And we are only just getting started. Next up, we're going to take a quick look at the tree map visuals and then start building out an entirely new product-focused page. All right, next up, I want to do a quick demo of what I feel is one of the most underrated chart types, the tree map. And you'll find the tree map right here in the visuals pane. Looks like a little box split up into smaller boxes, which is exactly what the visual is going to look like. And obviously, we're a little tight on space. I don't want to squeeze it in here, try to resize anything we already have. So I think it would be a good idea to modify our total orders by category bar chart here, because the way we're showing data in this view actually lends itself very, very well to a tree map visual. And I'll show you what I mean right now. With one click, we can convert that from a bar into a tree map. And basically a tree map is designed to show composition. So in this case, we're seeing how the total order volume breaks down into different categories and segments, in this case, product categories. So without even looking at the data labels themselves, you can get a very clear, very quick picture of relative volume and proportion here. So you can see that accessories drove the largest order share, followed by bikes, followed by clothing, by simply comparing the size of the rectangles that they make up. And in fact, one thing that I really like about tree map visuals is that they can be extremely effective without showing a single number at all. So to show you that, let's actually go into labels, and I'm going to turn off the data labels entirely. So now we're not seeing a single number, yet we're still communicating a very clear story about how those order volumes break down by product category. And of course, we still have our tooltips, which kind of embeds deeper information if the user chooses to access it. Otherwise, it's a very simple, very clean, yet very effective visual. And now remember, because we also have subcategory built in here as well into the fields list, that means we have access to our drill down capabilities. So check it out. Here's a tree map by subcategory. And the way to read this, again, is just by looking at the relative sizes of the rectangles for each subcategory. So you've got tires and tubes starting in the upper left, helmets, road bikes, bottles and cages, mountain bikes, and then you start getting into smaller and smaller and smaller fractions of that total order volume until you're down here at bike stands, which is the lowest volume, which you see is reflected right here in the bar chart as well. So obviously our title might need to change if we're allowing viewers to see this tree map by either category or subcategory, but let's drill back up. We'll default to showing it by category. And there you have it. I think that gives us kind of a nice balance. We've got some visuals that are very dense, very information heavy. We've got others that are designed to really just draw attention to key business metrics. We've got purely visual designs as well, plus user controls so that our clients can completely customize the view that they're looking at. So I'm really happy with this executive summary view. I think it serves its purpose. Next up, we're going to continue to dig into a few different visual types, start exploring some more advanced tools, and build out a new tab to really dig deep into product-specific performance. All right, so our exec summary is a wrap. It looks great. Time to add a new page to our report. So just click that plus sign, double click to give it a new name. We're going to call it Product Detail. Now, if you hadn't guessed by the title, this page is going to be all about products. And we know that AdventureWorks wants the ability to drill down to individual product performance. And not only that, but be able to track things like order volume against targets, see how revenue has paced over time, understand forecasted future profits, and they even want to see the impact that various pricing adjustments would have on their company's profit. So it all sounds very complicated, but what we're going to do is break down those questions piece by piece and build a view that can answer all of them and more. So first things first, can't create a report page without a logo. So let's copy that AdventureWorks logo, drop it in here. And now what you may have noticed about our exec summary is that it provides a ton of information, but what it does not provide is a clear sense of trending. So we can see at this current point in time, how are we doing? How's our proportion of order volume? What are my top products by orders and profit? And so on and so forth. You can, of course, change the date slider to get a sense of trending, but it's very manual and it's kind of embedded into the view. So what we're going to do in our product detail right off the bat is create some trending insight using line and area charts, which are designed for that. So let's grab a line chart first. It's right here in the top left and kind of stretch it out. Now, what we're going to show here is profit trending. So it's in my sales table. We're going to go down to our total profit measure here, drag it into values. And when we do that, we don't really get anything helpful. We get a single point with the total profit. So to make this line chart meaningful, we need to provide or define an x-axis. And we're going to do that by picking a date field to determine the granularity that we want to track profit over time. So let's head to our calendar lookup up here at the top. And we've been doing a lot of monthly views. Let's get a little bit more specific, a little bit more detailed, and grab start of week. And we're going to drop that into the axis window. And we don't want these weeks rolled up. We actually just want the start of week. And there you go. So we're seeing a very clear pattern and trend of weekly profit over time, all the way to our current week, which is the end of June. So that's a great start. Formatting looks nice. Don't need to change anything with my y-axis or x-axis labels. What I will do is tweak the title in my formatting pane. So let's drill into title and just name it weekly profit. And there you go. We just built a line chart. Super simple. Now to show you an area, I want to copy this line chart, Control V to paste it. I'm going to drag it right here underneath. And in this case, we're going to visualize returns. So head into our field list here. We're going to need to drill into our returns table. Grab that total returns measure, drop that one in, and we'll pull profit out. Now, first things first, we'll need to change our title. Instead of weekly profit, now we're looking at weekly return volume. There we go. And to stick with our theme of representing negative metrics like returns in red, let's go ahead and adjust the data colors while we're in here as well. So we make it kind of a mid-red like that. And now let's change this from a line to an area. And basically the only difference between a simple line chart and a simple area chart when you're viewing one series of data is that the area chart is filled. So think of it like a line with fill underneath it. So didn't really add much value here by changing it from a line to an area. Generally speaking, where area charts really shine is when you're comparing multiple series. So to give you a little demo, we'll head back to fields and you'll want to drag something into the legend. And this is basically what categories do you want to use to break down your data, your return data. And for something like this, you want to use a category that doesn't have many unique values because things can get overwhelming pretty quickly with area charts. So a good candidate here would be our product category, which only has 3 active category names. So when we drag category name into the legend, you'll see that it's created all 3 series kind of overlapping each other. So you've got the red series, which is clothing. You've got the green series, which is accessories, and the gray kind of behind here, which is bikes. So some people really like the default overlapping area chart. I actually prefer a variation of the area called the stacked area chart, which takes those same series and it literally stacks them on top of each other. So there's no overlap whatsoever. Now you can clearly see both composition as well as trending. In other words, by tracking the top line of this list, you can see the total return volume over time. And then by analyzing individual slices, you can get a sense of how many of the orders for that given week came from accessories versus bikes versus clothing. So that's a quick kind of crash course in areas and stacked areas. In this case, because we're going to be looking at individual products here, there's no need for a legend field. There's no need to break down the returns any deeper. So I'm going to get rid of the category name here. And we can use either stacked or standard. As you can see, one series, meaning it doesn't really make any difference. And I'm going to leave it just as it is here. So this is just a start. We're going to continue to evolve this view, add more visuals, explore some more features. But for now, this looks good. So there you go, line charts and area charts. So in the last lecture, we built out this line chart and this area chart on our product detail page. But I feel like our line chart is kind of sad. It's showing profit by week, which is helpful, but I think we can pack some more information in here. And one way to do that is to use the tooltips like we've practiced already. So let's go ahead and grab some important measures like revenue and orders into our tooltips. That way all 3 of those metrics are now visible at the weekly level without having to chart 3 separate series on the same graph, which would certainly be feasible, but not the best visual since those metrics are on very, very different scales. Instead, what I want to do is explore a pane that we haven't touched yet, which is this third option for analytics. Now, this pane will only be accessible for certain visuals, and for many, these options will be quite limited, but the line chart is one type of visualization that has very rich, very robust analytics options. So we're going to play with a couple of these here, starting with the trend line. Now, all we have to do is add a trend line, and it essentially fits a line to our series over time to give you an overall kind of smoothed out trend of where things are headed. So if I'm AdventureWorks, this is a great trend because I'm seeing profit on a nice upward slope over the last year and a half or so. Now, like everything else, the look and feel is completely customizable. In this case, that black line is pretty overpowering. So I'm going to pull that down to about 75%. Transparency, that's a little bit more subtle, which I like. You can change the style to solid or dotted or dashed. I think I actually prefer the dashed here. And then these default options will do just fine. These come into play if you're dealing with multiple series. So that's our trend line, easy enough. We have very similar options for a constant line, a min, a max, an average, median, or percentile. All of these essentially add lines, horizontal lines to our chart, and they kind of speak for themselves. Constant allows you to define a value, like 100,000 for instance, and I typed a million. There you go, 100,000, and plot that horizontal line on your chart. That's nice if you have like a fixed goal or something like that. You can also plot the minimum line, which finds the smallest or lowest value in the window of time and applies a horizontal line based on that minimum. Same story holds for max up at the top. Kind of gives you a good sense of the range of values that you're looking at over this period. And then average, median, percentile, they all work exactly the same way. I don't want really any of those. We could add them, but I feel like it's just going to make things a little bit too busy in this case, especially because I want to play with one more tool, which is the forecast down here at the bottom. And this is how we're going to address that question for AdventureWorks about how is my profit expected or anticipated to look for the next X weeks or periods or months. So Power BI makes it very user-friendly to create forecast views like that. And all we're going to do is add a forecast. By default, it's created a forecast of 10 points, and points are basically date fields, and a point is the default unit of date that you're looking at. So in this case, it's 10 weeks out. And if you want to get totally wacky, you could do something like, show me a forecast for 10 years. And it's very ridiculous because you very quickly lose confidence in what your profit's going to look like 10 years out. So I would not recommend that. And I don't think our clients would appreciate that much either. So let's stick with weeks, and let's actually narrow it down a bit to a 6-week forecast. Now you do have an option to ignore previous points. Like if we know this was an outlier or an anomaly, we could ignore that 1 point. I kind of feel like that's sweeping things under the rug. So let's keep that at 0, and we'll keep the true forecast here. Now, confidence interval, this is an interesting one. And this basically defines at what level of confidence do we think the true values are going to fall into this shaded range. So at 95%, that's pretty darn confident, which is why you see a pretty broad or pretty wide range here. If we drop this down to 75 and apply, you'll see that it shrinks down quite a bit. And that's because we're trying to hit a tighter target. So naturally, we're less confident that the numbers will actually fall into this narrower range. So best practice is generally to use 90 or 95. Let's go with 90 for our purposes. There we go. And you can also apply a seasonality factor. Like if you know that mid-June or July profits tend to dip over the summer, then you can kind of manually tweak that forecast window yourself. So there you go. That's our forecast. I think I'm happy with that. Feel free to adjust the settings, kind of customize or personalize it as you see fit. But for our purposes, I think that does a nice job. It adds some good insight about the overall trend of profit and what we might expect to see for future profits over the course of the next 6 weeks. All right, I've got one more specific visual demo for you, and I've saved a fun one for last. We're going to talk about gauge charts. So you can find the gauges right here underneath the pie. And we can drop one onto our canvas. We need to make a little bit of room for it. So let's go ahead and just shrink down our returns view and our trended profit view to make some room for these gauges up at the top of the page. That looks good. Now, essentially what I want to do is use the gauge to provide a quick visual indicator of pacing towards our targets. And remember, we defined order targets and revenue targets as 10% lifts over the previous month. And we did that using time intelligence functions in DAX. So for our first gauge, let's call this our total orders gauge. We'll hop into our sales table, grab total orders, and drop it into the first field, which is the values field. And you'll see a few things happen here. It's populated the total value, 23,000. Again, no other filter context yet, aside from our report level filter of 2016 or 2017. And what it's done is default to a minimum of 0, maximum of about twice the current total, so that it defaults to a half-filled gauge. Now there are a couple tweaks I'd like to make here. Number one, I want this gauge to always show monthly performance for the current month, because our targets, our goals are defined at the monthly level, and I want to provide a recent view of performance, not just the grand total. So to do that, we're going to work with our visual level filters here, and we're going to need a field from our calendar lookup. In this case, monthly. So I'll take the start of the month field and drag it right in here. Now I've got a couple options here. Because the data that we're working with at this point is fixed, we could simply select June 1st, the month of June, and update our gauge to the latest month that way. Problem is, we need to get smarter about this. We need a flexible solution that will scale if we end up adding more data over time. If AdventureWorks, for instance, starts sending us sales or returns data each week or each month and expects new reports, then this basic filter just isn't going to cut it, because we're going to pull in July data and it will still filter to June because we've fixed the filter in that way. So what we need is a better solution like top N. And what we're going to do here is show the top one item, and that item is going to be the start of the month. And because it's a date field, Power BI gives us these earliest or latest options. So we want the top one latest month. And when we apply, we see the same value, which is exactly what we want. June is the correct value because it's the current month, except now our solution is more scalable and more flexible by using that top N filter instead. So that works for our filter. We're good to go there. Next up, we need to provide context, because right now this gauge is meaningless. We could simply have a card showing this number and it would accomplish the exact same thing. So the beauty of gauge charts, kind of like KPI cards, is that they accept interesting values like dynamic minimums or maximums and target values. So let's go ahead and grab our target, order target DAX measure, and you'll see that calculation right here, previous month orders times 1.1. And let's drag that into the target value field here. And now what that does is it creates this indicator with the target, which in this case is 2,382, telling us that we are slightly behind target overall for the current month. Now there's another option that works pretty well here too, which is to take that target, that order target, and move it to the maximum value. That way the gauge fills up until it hits the goal or the target value. So if you have a partially filled gauge, it means you haven't reached your target yet. So I think this is actually a bit more intuitive, but again, this is completely up to you. If you prefer to see that order target in this format, that's fine. I think both look nice. I'm going to keep mine on maximum value, and let's just resize this a little bit. That looks good. And update the title. And let's make this a bit more descriptive to something like current month orders versus target. There we go. And if we want to be consistent with our exec summary, we could do something like this. There we go, and center it. Beautiful. So there's our total monthly orders gauge. We can go ahead and take that, copy it, paste it 2 more times, because we're going to do 1 more for revenue and then a 3rd for returns. So let's work on our second one here, and we're just going to swap in and out the values. So our filter can still stay exactly as is. We can actually collapse our calendar. And in this case, we don't want orders and order target. We want revenue and the revenue target. So we've swapped them out. In this case, current month, we've got 1.83 million in revenue against a target of 1.95. So coming in just under. And we can change the title as well to current month instead of orders, current month revenue versus target. And then our last gauge here, we're going to show returns. Head to our fields, drill into our returns table. And we'll grab total returns instead of total orders. And now remember, we don't have a return target. So in this case, let's just use the previous month return as our maximum value. And because this is a negative metric, I want to call that out and make that explicitly clear using some color consistency. So let's change the data color. There we go. And adjust the title here as well to current month returns, and not versus target. This is versus previous month. And there we go. Next up, I want to cover a very important topic when it comes to Power BI reporting, and that's report interactions. Now, consider a dashboard like this. In the Format tab, you'll see a button on the left called Edit Interactions. When you select a specific visual in your report and click Edit Interactions, you'll see a number of different controls associated with each other visual on that page. And in each case, you'll see a filter icon and a no filter icon. And what these report interactions do is they allow you to determine how filters applied to one visual impact the other visuals. In other words, it determines how you want your visuals to talk to each other. And remember that in most cases, by default, all of the visuals on the page will be configured to react to each other. So as filter context changes with every selection on each visual, the other visuals filter down accordingly. But sometimes you don't want that to be the case. Take this example here. The product matrix shown on the left, the country slicer at the top, and the map itself are all configured to react to filter changes to the timeline, which is the selected object or visual. And you can see that by the activated filter icons in each of those three visuals. Now, on the other hand, our three cards here, the month-to-date profit, quarter-to-date profit, and year-to-date profit, are all configured to not filter in response to changes in the timeline. And this is a common example for cases where you'd like your card to always show a specific time period or the current month. Or maybe you're showing data from two unrelated tables that can't provide valid filters for each other. In any of these cases, the Edit Report Interactions tool is incredibly useful. I want to show you one more example as well. Consider this case. In certain types of visuals, a third option appears, and that option allows you to highlight subsegments of the data rather than simply filtering or not filtering. So in the first case here on the left, when the interaction mode is set to filter, then when we select bikes from the tree map, it produces a filtered list of subcategories in the chart below. So all we see are road bikes, mountain bikes, and touring bikes. In the second example, when the interaction mode is set to highlight, which looks like a pie with a slice pulled out, selecting the bikes category in the tree map doesn't filter down the list of subcategories, it simply highlights the relevant subsegment of data. So both options are perfectly valid, it's just a matter of how you want to display this relationship between your visuals. So let's head back to our report and try configuring some of these interactions ourselves. So back in our AdventureWorks report, let's head back to the Executive Summary tab. And let's say, for example, we want these KPI cards in the top right to always reflect the current month. In other words, we don't want these cards to react to changes in filter context from the date slicer here. That means that what we need to do is edit the report interactions to change the way that these visuals talk to each other. So we'll select the slicer as kind of our parent visual. We can go into the Format tab, and you'll see this Edit Interactions button on the left. And when you click to activate, all of those icons will appear for every visual on the page. All the cards, the maps, the matrix, the tree map, the bar chart. And you can see that by default, they are all configured to filter in response to changes to our date slicer. So all we need to do to tell the cards to ignore filter context from our slicer is disable or switch these filters to none. And once we do that, we can deactivate the interactions. And now check it out. As we move our dates, the other visuals in our report change, but our cards remain constant. Now keep in mind that other filter changes produced by other visuals in the report will continue to change those cards. We've only changed the interaction between the slicer and the cards, not the relationship between other visuals and those cards. So in this case, I'd like to be able to filter down our revenue, our orders, and our returns by different categories produced by filter context from other visuals. So this is okay, but keep in mind that if we were to select the tree map, for instance, and edit the interactions, you get an entirely new set of interaction modes. Now, one to call out here is by default, the subcategory bar chart is set to highlight instead of filter, which is why when we deactivate, as we filter these categories in the tree map, you see that we still continue to see the full set of subcategories. We're just highlighting those which fall into the selected category above. Now, if we were to change that interaction mode to filter, now we're not seeing the full set of subcategories each time. We're seeing a filtered down list based on the selection in another visual. So in this case, I think the highlight mode is actually more effective here because I like to see the full list of subcategories and get a sense of the rank of where the highlighted values from a given category fall. So let's go ahead and deactivate the interactions. And really, it's just interesting to play around and see how things react to each other. So in this case, we have a highlight relationship from the subcategory table up to the tree map as well. You'll note that it's highlighting subsegments of these boxes rather than changing the entire tree map itself. So as you can see, it can get pretty complex. There are a ton of different potential relationships and interactions that you could customize here, especially in our case where we have a large number of visuals on the page. But keep that in your back pocket. It's a great tool to customize how your different visuals react to different filter context. All right, so by this point, we've talked about all of the filters that Power BI Report View has to offer, except for one, the drill through filter. So it's finally time to dig in and see how this tool works. Now you'll find drill through filters between your page level and your report level filters. And what these do is they allow users to jump to different pages like bookmarks do, which we'll talk about next, while simultaneously filtering based on the specific item that they've selected. So it's a little bit confusing. It's one of those things that's quite a bit easier to show than to explain. But if you look at this example here, we've built a report page, product detail. This should look very familiar, featuring product level performance. Everything on this page is designed to show product level detail. And we've added a drill through filter for product name. What that means is that users can now right click on any report visual on any other page in the report that contains product names and select the drill through option to jump straight to this product detail page. And not only that, but the page will filter simultaneously based on which product the user right clicked. So it's almost like a bookmark filter hybrid, and what it does is create some really interesting interplay between the pages of your report and allows you to kind of create specific paths that users can drill into. So let's head back to our report and set one of these things up. Now, once you're back in your report view, head to the product detail tab. And the first thing I want to do is just add a simple text card to indicate what product we'll be looking at here. So I'm going to grab the card option, and from my product lookup, I'm going to take product name, drag it into the fields, and let's give it a quick format just to be consistent. Data label, I believe on the exec summary we used Seago bold. I'll pull it down to about size 20. We do not need the category label in this case. And let's give it a little background with that light yellow shade, just like we did on the exec summary. So you'll note that it's defaulted to first product name, which in this case is actually okay, because this will be changing based on that drill through filter. So normally this wouldn't be very helpful, but think of this just as a placeholder for the time being. So I'll just kind of reposition things a little bit, and there you have it. So this is kind of my label to indicate what this whole page is going to be showing. Now the next step is to grab another instance of product name and drop it right here in the drill through filters window. And I don't even have to make a selection. I don't have to change a thing. What this is going to do just by existing here is it allows me to go to any visual that contains product name level information, like this matrix for instance, and right click, and now I have access to this drill through option, and that product detail page is already populated. I didn't have to set up anything. I didn't have to configure any settings. And now watch what happens. I've right clicked the Sport 100 helmet in red. And when I drill through to the product detail, there we go. Sport 100 helmet in red. I'm seeing the current month orders, revenues, and returns for this product specifically. I'm seeing trended profit through the whole sample plus the forecast. I'm seeing how returns have trended over time. Looks like a spike the week of 5/15 that we should probably investigate. So really user-friendly and really easy to configure. Now the other thing it's done for me, which is pretty cool, is that it's added this back button automatically. and it says control click to go back. And when you do that, it takes you right back to the exec summary where you started. And you can do this literally for any row containing a product name level field. So here's the logo cap. This one hit its target. Looks like it exceeded the order target by 11 orders this month. It beat the revenue target. So what we've done here is essentially create this choose your own adventure kind of narrative that users can experience to interact with the data in any way that they choose. So when we talk about self-service BI, it's kind of a buzzword these days, but this is really what it means. It means you're giving users and analysts and developers and data scientists tools to very easily do this sort of data discovery and reveal these patterns and trends much more efficiently and much more effectively than with traditional tools. So there you have it. Those are drill through filters. Definitely a tool that you want to keep on your radar. So now that we've talked about drill through filters, the concept of bookmarking should come pretty naturally. Now consider a case like this, where we've got a dashboard and we've been filtering and exploring it in different ways. In this case, we noticed that Q4 sales were particularly strong in the Portland market. What we can do is activate our bookmarks pane from the View tab and create a new bookmark to lock in this view, lock in the filter settings, and name it Q4 Portland Sales. What that will allow us to do is link any other object in our file, in our report, back to this specific view. So no matter what the current filter settings are on that page, they would recalibrate to match how those filters were defined when the bookmark was created. So a really useful and relevant case study for using bookmarks is something like this. You could create a new page in your report specifically dedicated to something like key insights and recommendations. And this is where you could capture those findings that you've uncovered as you've been exploring your data. So in this case, our second insight says Portland sales were strong in Q4, led by High Top, Ebony, and Red Wing brands. And then what we've done is insert those buttons, those little eye info icons, and we've linked them to specific report bookmarks using the object action properties. So this creates incredible opportunities, not just to present data, not just to show charts and graphs, but to build a story and actually create a meaningful narrative from that raw data. Because at the end of the day, that's what analytics is all about. It's not about writing code, it's not about crunching numbers, it's not about memorizing formula syntax. It's about deriving meaning and context from the data, and more importantly, using it to make real change. So I absolutely love the bookmarks feature. Let's head back to our Power BI report and try this out in our AdventureWorks dashboard. All right, so there are a number of places where we could potentially use bookmarks here, but as a demo, let's create a button or a bookmark that links from our executive summary straight to our product detail page. And we're not going to do anything fancy in this case. We're not going to pre-filter to any specific view because we already have that drill through functionality in place. But let's head to our product detail tab. We're going to go into view, show the bookmarks pane, and all we need to do is add a bookmark from here. And let's go ahead and double click to name it. Product detail, just to match the name of the tab. And for now, it's as simple as that. We can close that bookmarks pane. We can go back to our executive summary. And let's create a little bit of space right down here beneath our matrix. And we're going to add a button and a little text box that basically says, okay, if you're interested in this product level info, then click this link and I'll drive you straight to even more product detail on that second tab. So what we're going to do here is head to the home tab. We're going to insert a text box first, and got a lot of stuff, so it's kind of tough to manage our shapes at this point. There we go. And let's just type something like view product detail. And I'm going to make it bold, italic, maybe a size 18. Okay, details don't really matter here. And we're just going to drag it kind of right under here beneath that matrix view. And because we can't link a text box to a bookmark, there's no actions pane here that we can use. We'll just need to insert something else, whether it's a shape or an image or a button. So buttons give us some interesting options. We've got arrows, back buttons, info buttons, help buttons, and so on. So let's go with this little info box here and just click and drag it right next to our text that says view product detail there. And now we get this action drop down in the visualizations pane that popped up when we selected the object. And within the actions drill down, we can activate it and say this is a bookmark, and the bookmark that we want to drive to is our product detail bookmark. And that's it. We have set up and enabled our bookmark. All we need to do to test it is control click, and there we go. Takes us right to our bookmark page. And remember that back button that was created when we added that drill through filter automatically? Well, if you select it and look at the pane, you can see that automatically an action has been activated, and in this case it's a back button. So we don't need to create a new one here. We can reuse this one. It'll take us right back to our executive summary. So again, yet another example of a really, really powerful yet intuitive tool in Power BI. And you'll see this time and time again. Once you develop those fundamental skills and understand how this tool is working, which if you've stuck with the course up to this point, I hope you have, then you've got some incredible power at your fingertips here. Speaking of which, next up I'm going to give you a little taste of parameters, which are going to take things to a whole new level. Stay tuned. Alright, I want to take a minute and walk through a slightly more advanced demo. We're going to use what's called a what if parameter to do some scenario testing. And if you look at your modeling tab, you'll see this new parameter button that launches a dialog box that looks like this. Now, essentially, these parameters are preset DAX measures that produce values within a given range based on user inputs: the data type, the minimum, the maximum, the increment, and the default value. And these can be really good tools to use for things like forecasting or scenario testing. So the example you see here and the example that we're going to practice is creating something like a price adjustment percentage captured within a parameter so that we can compare total revenue based on actual information and actual prices against an adjusted revenue based on the parameter adjusted price. And I'm going to show you exactly how that works. Now, one interesting thing to note is that when you create a parameter using the dialog box, Power BI actually generates and creates a new table for you with DAX calculations already in place for the parameter and the parameter value. So those generate series and selected value functions that you see at the bottom of the screen, those are automatically created behind the scenes, although we could build them from scratch if we chose to do so. So let's head back to our report and try creating a scenario test of our own using these parameters. All right, we're going to head to the product detail tab, and you're going to want to follow along closely with this because there will be a number of steps, and we're going to have to get back into our DAX world and write a few new measures to make this all work. So first things first, on the modeling tab, here's my new parameter option. Let's go ahead and launch the dialog box. Now the settings that I'm going to use, I'm going to give it a name, something like price adjustment with a percentage. And that's just part of the title. It's just text because the values that we're going to use, as you'll see, will eventually translate into percentages. The data type is a decimal number, and let's set the minimum to -1, maximum to 1, the increment at 0.1, and the default to 0. And we can keep this add slicer to page activated. So to recap, we've essentially created a scale of values defaulting to 0 with a minimum of -1, maximum of 1 in 0.1 or 10% increments. So let's go ahead and press OK to create that parameter. So a few things have happened here. It's dropped this slicer onto my page, and I'm going to resize my trending profit to create some room here. So I've got this slicer, and as I drag it, you'll see that it contains the values, the minimum of -1, the default center point of 0, and the maximum of 1. And not only that, but at the bottom of my field list, it's created a new table with 2 new fields. One is the price adjustment percentage, which is calculated as a generate series function. You can see that the 3 arguments that the function takes are the minimum, the maximum, and the increment. And the second field, an actual measure, essentially uses the selected value function to capture or harvest whatever value is currently represented by this slicer. And that means that as we move this slicer left and right, we are producing a value using a measure that we can now reference in other measure formulas. Because if we don't do that, then this is kind of just sitting here as an island and it's not really impacting anything around it. So the first new measure that we need to create is an adjusted price. And if we go into our product lookup table, you'll recall that we've already created a measure for average retail price. What I'm going to do now is create a new measure in this product table. I'm going to name this measure adjusted price, and I'll define adjusted price as the average retail price times 1 plus whatever the currently selected value in my parameter slicer is. So I can search for price adjustment, and you see how it gives me that measure that was automatically created? That price adjustment percent value measure, remember that's capturing the current value of that slicer. So by multiplying my average retail price by 1 plus that slicer value, I'm essentially defining an adjusted price that modifies my average retail price in steps of 10%. From 0, which is essentially dropping the retail price to nothing, or up to 200%, which is essentially doubling the actual retail price. So that's step 1. I'm going to press enter to create that measure. And now just to see if this is working, let's add a multi-row card and click off of our slicer, add a multi-row card. And the 2 fields that I want to pull in are my average retail price and my adjusted price. So right now, because my price adjustment in the slicer is set to 0, these 2 fields should reflect the same thing. And I'm noticing we need to format here. So I'm going to select adjusted price. And why don't we format this as currency? There we go. So now if we move this slicer, you see the adjusted price changing all the way up to a maximum, which should be double the original or actual average retail price, which it is. Other side of the spectrum, we can drop all the way to the point where the adjusted price is 0. So this is working exactly as we'd expect. Let's set it to 0. Let's kind of resize, create a little bit of room here. There we go. And I'm going to drag my multi-row card right underneath the slider there. So that's step 1 and 2. The next step is to actually take that adjusted price and feed that into some of our other calculations in our sales table, like our revenue measure and our profit measure. Because at the end of the day, those are the actual values that I'm scenario testing here. We're really trying to see what impact this type of pricing adjustment will have to actual bottom line revenue and profit. So let's go to our sales table and let's drill into our total revenue measure and remind ourselves how this original revenue measure was calculated. We used a SumX to multiply the order quantity by the product price in the related product lookup table. So rather than reinvent the wheel and create a new adjusted revenue measure from scratch, let's copy this entire measure, press enter, create a new measure within the sales table. I'm going to press Ctrl V and paste that. And now instead of total revenue, this version of it is going to be named adjusted revenue. Okay, and I'm still multiplying order quantity from the sales table. The only difference now is that instead of multiplying quantity by actual product price, I'm going to multiply order quantity by that measure that we just created for adjusted price. So we've removed the related function. We're not pointing to a related price field in the product table. We're multiplying order quantities by this new adjusted price measure instead. So when we press enter, the measure is created. There it is, adjusted revenue. And now the final step from a DAX standpoint is to create one more. And if you recall, we had defined profit as revenue minus cost. Therefore, adjusted profit is simply going to equal our adjusted revenue minus the total cost. So same exact formula, except instead of plugging in total revenue, we're plugging in adjusted revenue. And we'll lock that one in as well. And now we've got adjusted profit and adjusted revenue. So let's take this thing to the finish line and visualize what this looks like. To do that, I'm going to copy this line chart that we've created, paste a second instance, which we can pull in right here. Just going to kind of rearrange things a bit. There we go. And now I don't need my analytics tools here. I can get rid of my trend line. I can get rid of my forecast. I'm going to go back to fields. And instead of simply showing total profit, I'm going to show total profit right alongside adjusted profit. Okay, so now both are being visualized here. And at the moment, both values are exactly equal because my price adjustment is set to 0. Now, if I bump up that adjustment to 0.2 or 20%, look what happens. Now we see that adjusted profit is $549. Total profit or actual profit is $345.74. So what that tells us is that with a 20% lift in the product price for the AWC logo cap, we could potentially increase weekly profit by about $200. And then if we adjust in the other direction, and if we reduce product prices, you'll see that these kind of reverse order, right? All the way down to a 50% reduction in price means that you're actually losing money on that hat. So you can see where the break-even points are. You can see how these different scenarios play out. And remember, this is still at the product level. So everything we're looking at here is related to this logo cap. Remember, we can go back. We can drill into a different product, like the water bottle. And we can see a completely different trend and test completely new scenarios with each product individually. So let's go ahead and just kind of tweak formatting, get things to a good point here. We'll default to a price adjustment parameter value of 0. Stretch this out a little bit. So there you go. Good example of how to use these parameter tools to create different types of interactive scenarios inside of your Power BI reports. Next up, I want to take just a minute to talk about managing and viewing as roles. Now within the modeling tab, you'll see a security tool group with two options. When you click the manage roles option, it allows you to actually define filtered views so that your report can be tailored to specific audiences. So in this case, we're choosing to filter down the territory lookup table based on the condition or the expression that the continent field must equal Europe. And you can create a number of different roles based on different DAX filter expressions. So in this case here, we've created views for each territory manager, Europe, North America, and Pacific, based on those simple DAX filter statements. Continent equals Europe, continent equals North America, etc. Now what's important to make clear is that you're not just pointing a user to a pre-filtered view. So when you select the Europe role that we've created, for instance, you're not seeing the executive summary tab pre-filtered down to Europe. You're seeing a version of the report that literally doesn't contain data for any other continent. And that's why this is different from simply creating a bookmark or a pre-filtered view that you can link to. This is actually running the selected table through a DAX filter expression and chopping out rows that don't meet the condition. So what we're dealing with here is essentially row level security, meaning we're defining specifically what rows of our data set certain users or user groups are able to access. So this is very simple to set up. Let's head to Power BI and I'll show you how this works. All right, so back in our exec summary tab, what we're going to do here is head to the modeling tab, click on security, manage roles. This is where we create or define a new role. And just like the example we talked about, let's create individual roles for each territory so that we can provide AdventureWorks sales managers from different regions with reports that only contain the data that's relevant to them. So let's start with a role named Europe. And basically we define which table we need to filter down. In this case, the only table that we need to filter is the AW territories lookup. And then we write a simple DAX filter expression that returns a true-false value. So in this case, continent equals Europe. It's as simple as that. Now this little icon tells us that this is the table that's filtered. And in the window here, we see the expression that defines the filter. So press save. There we go. And now when we click view as roles, we have Europe as an option here. So watch what happens and pay very close attention specifically to our map and to our map slicer. When we click Europe, press OK. See what happened? We are now filtered on Europe, but our continent slicer only contains a single value aside from select all, which is Europe. So that really emphasizes the difference between simply creating a filtered view and actually defining row level security that prevents rows of data from actually reaching the report. So from here, we can simply say stop viewing. Back to normal, we can manage roles, create another for Pacific, click the territories lookup, and write the same kind of expression for Pacific instead of Europe. Press save. View as roles. Now we've got a Pacific option as well. And there you go, same thing. So a Pacific sales manager in this example has no idea that data from Europe or North America is tied into this model or even exists. So it's a great tool when you have sensitive information or need to create very specific access rights for certain user groups or teams in your organization. So let's go ahead and stop viewing Pacific. Now, one thing worth calling out here is that by implementing row level security rules, this does have impacts in other places. And one area is when it comes to actually publishing reports. Now again, publishing and collaborating will be covered in depth in an entirely separate focused course, but I will provide a quick preview on what it looks like to load this to service. Now, if I have row level security roles defined, that prevents me from publishing this to the web. So in this case, I don't really need those roles. So I'm going to go back and delete the two that we created, just so that later on I can demo what that publish to web functionality really looks like. So we'll save, and now we're back to usual. We've got no additional roles, and that should do it. So good intro to row level security and using Power BI's manage roles options. All right, to take this section of the course home, we're going to wrap up with some pretty quick rapid fire preview demos. And these are topics that we're not going to dive very deep into, but I want to bring to your attention just so that you're aware of the functionality. So first up, importing custom visuals. You'll see these three little dots, this ellipsis in the lower right corner. This allows you to import custom visuals either from files or from the Power BI Marketplace directly into your report. So you can search different topics or categories, look at suggested visuals, and then once you pick one that you like, press add, click OK, and boom, it's accessible right there. You don't even need to restart Power BI. You can start working with it immediately. And to clarify, this is a completely free, totally open source marketplace of custom visuals that already has a ton of really interesting options, but it's continuing to grow by the day. So definitely worth taking a look at. And I'll just take 30 seconds now to show you what this looks like in the actual Power BI environment. So like I showed, here's my visualizations pane. Click these three little dots. It says import a custom visual. I'm going to choose from Marketplace. And right here, it opens up the Power BI Visuals Marketplace. You can search different categories. You can look at top editor picks, filter visuals, some really creative ones in here, like network visualization. You can do image timelines, custom KPI charts, different types of maps. I don't know what Sandance is, but it sounds really cool. And then really all you have to do is click add. I'm going with Sandance. Press OK. And check it out. I've got a Sandance now. So again, we could spend hours digging into all of the custom visual options available. Best bet is for you to just scroll through, check out that marketplace on your own, and start exploring some new visuals. So quick crash course in desktop versus phone layout. Desktop layout is the exact interface that we've been working with this whole time. That's the default, the standard. When you switch to phone layout, you'll see a view like this. And what phone layout does is it allows you to design on a canvas size that's optimized for mobile viewing. So important thing to note, you don't actually do any building of content within the phone layout view. You build in the desktop layout and then switch into phone view and kind of assemble your pieces and resize within that new constricted canvas. Now this really won't come into play until you start getting into Power BI Service and publishing, but because it is an option in Power BI Desktop, I wanted to quickly cover it here. So let's quickly whip up a mobile optimized version of our exec summary. So by default, we're in our desktop mode. If we go to the View menu and click the phone layout, what it does is it gives us this shrunken down canvas and assembles all of our pieces or components over here on the right. And that includes everything, even these little icons that we dropped in, slicers, maps, charts, visuals, logos, all of the pieces are here. So as we start actually dragging items onto the canvas, you'll start to see that we really don't have much flexibility for sizing. So we're not going to be able to get all of these elements into a mobile phone view unless we stack them, one on top of each other. But let's try to get the most important things in here. Maybe it's the current monthly revenue. Maybe it's the current monthly orders here. Try to squeeze in returns as well, kind of our big KPIs. We could probably show our subcategory view down here and stretch it out a bit. And then why don't we pull our tree map? There we go, make this a bit bigger. It's kind of hard to work with. There we go. And maybe it's the top ordered product there as well. So, obviously you don't have to follow along with what I'm doing exactly, but maybe something like that makes sense. And now when you switch back, we haven't edited anything on the desktop view at all. We've just created a new variation of it here in the mobile view. And now if you do end up publishing this report, then it will become accessible on the Power BI mobile app, and this is how users will be able to see and interact with that report. So there you go. That's phone versus desktop layout. All right, the last feature that I want to quickly preview for you is the Publish button. Now keep in mind that this button is essentially the gateway to an entirely new world called Power BI Service. It's got a ton of features and functionality, sharing tools, collaboration tools, apps, workspaces, data gateways. The list goes on. The fact is, it's just way too much to try to cover as part of this course, but I do want to take just 30 seconds to show you what the process kind of looks like to get started. So keep in mind, I am signed in. You see my name in the upper right. And when I publish, it's going to allow me to publish to my workspace, which is the default. This is kind of a blank canvas account right now. Press select, and it's off and running. starting to load this up to Power BI service. So there you go, success. Usually takes around 20 to 30 seconds, not long at all. And then from there you can click the link, and that's going to take me right into app.powerbi.com or Power BI service, and populate and render the report. So here's my report, still fully functional, fully interactive, all of the tools, everything we created, including the drill throughs. It's all maintained here exactly as it was in desktop. Even our parameter testing, our buttons link really smoothly. And this is where you'll find all of these tools that allow you to start sharing this content, collaborating with coworkers, creating apps and workspaces. This is also where you can publish either to the web or to SharePoint. You can export to PowerPoint, download as a PBIX. Now, one thing I will say is that this report could be published to the web because it contains no private or proprietary data. That said, if you do choose to publish and share this publicly, all I ask is that you please just give a quick shout out to the course. So again, we're going to drill into all of the functionality in this whole Power BI service world in the upcoming course, but that just about wraps up our desktop features. So to wrap up this section, I thought it would be helpful to share some of my top data visualization best practices. Number 1, strive for clarity and simplicity above all else. Power BI has a lot of tools, a lot of features, a lot of bells and whistles, but remember that sometimes less is more. Your goal should be to maximize impact and minimize noise. It's all about balancing design and function. Number 2, remember that your job isn't just to build charts and graphs. Your job is to create a narrative. So remember, without context, data is meaningless. Make sure that you're using tools like filters and bookmarks and creating effective visualizations that translate raw data into powerful insights and implications. And finally, always ask yourself 3 key questions. Number 1, what type of data are you visualizing? Is it integer, categorical, time series, geospatial? Based on that, what exactly are you trying to communicate? Are you trying to show a relationship, a composition across categories, a trend over time? And then finally, who is the end user consuming this information? Because the report that you build for an analyst or a fellow colleague may look very different from a report that you would send to an executive. So there you have it. Those are my top broad data viz best practices: clarity and simplicity, creating narratives, and asking yourself those 3 key questions. All right, time for a quick solution walkthrough for our last homework assignment. And basically what we've done here is create a brand new report page for customer details. And I'm not going to walk through the actual building of every single step. I don't think that would be necessary. But what I'll do is show you my completed version, and we'll walk through each component piece by piece. And keep in mind that your formatting, your style could look different from this, and that's totally okay, as long as you've got the correct visuals in there and the correct filters and functionality. So number 1, we add this matrix here to show total orders and revenue by customer full name. And when you try to pull in return data, what you should see is something like this, where you get the identical return values in every single row. And remember, the reason why that's the case is because we do not have a table relationship in our data model between the customer lookup and our return table. What that means is that we can't filter any customer related values to analyze those total returns values. So returns are off limits for this page. We're going to be focusing entirely on our sales data, the profit, the revenue, the orders, those types of fields. So spot check, when you sort the total revenue column, you can click to sort ascending versus descending. You should see Mr. Maurice Shan at the top of the list, who generated $12,407.95 in revenue. And the last step here for question 1 is to update the conditional formatting for those 2 columns, which you can do right here. So for total orders, we've activated data bars. And for total revenue, we've activated the background color scales. And in my case, I've gone from a white to greenish blue shade. Again, your style is completely up to you. Next up, we added some donut charts, and we formatted the titles to match with our product and executive summary pages. The first is breaking down order volume by gender, the second by income level, and the third by occupation. And what we've done here is update the report interactions from the matrix as well as each donut to make sure that these donuts are set to filter and not highlight. So you're going to want to make sure you select each donut individually and make the adjustments. If you only edit one of the donuts, you may still default to highlighting in certain cases. So that looks good. And now if we select Mr. Maurice Shan specifically, we should see these all filter completely down to show gender equals male, income level equals average, and occupation equals professional, because those are specific attributes to this customer. And you can select any blank area of any chart to unfilter. I like clicking in the middle of one of my donuts, just kind of an easy target to hit. And then last note here is just to use those formatting tools to align and distribute. You can hold Control, select all three, align the top, and distribute them horizontally. There you go. And that's question 2. Question 3 asks us to add a line and clustered column visual, which is this icon here, line and clustered column chart. And we're showing total orders on our column values and total revenue on our line values, and using start of month, not the hierarchy version, just the start of month, on the shared x-axis. So when we spot check here and drill down to just the latest month, June 2017, you should see Mr. Marco Lopez drove the most orders that month with 3. Now we're going to update interaction mode again, select the matrix first, interaction, and make sure that that combo chart is set to filter and not highlight. If we select Mr. Marco Lopez, you should see that he placed orders in 4 different months: June 2016, August 2016, March 2017, and June 2017. So that all checks out. That takes us to question number 4. Add a tree map to show total orders by current age. This one's pretty straightforward. We're going to group by that current age field from our customer lookup table. Values are total orders. Now, one thing to keep in mind, right now, I see 928 orders for age 50, 855 for age 49. Remember that the DAX measure that defined current age was based on the today function, which is volatile, meaning that the today function returns different values based on the actual current point in time. So even though our data set is fixed, these customers are actually going to continue to age before our eyes. So don't be concerned if you see slightly different numbers here in this tree map. Next thing we did was add a card for the customer full name. We made some formatting changes to turn off the category labels. We updated the title. We added a light yellow background. And then more importantly, we added this visual level filter for full name, where it's a top N with the top 1 item by total revenue. That returns our highest revenue driving customer, which we know is Mr. Maurice Shan here at the top of our list. From there, we copied and pasted to keep the formatting, added 2 new cards, kept the filter in place, but simply dropped in new fields for total orders and total revenue, and updated the headers and titles accordingly. And a couple spot checks here. When we filter on female customers only, you should see Mrs. Janet Munoz with 6 orders and just over $12,000 in revenue. And then among high income customers specifically, our top customer is Mrs. Lisa Kai, who placed 7 orders and drove $11,330. Now, last step here, we added a text box here for executive summary, and then dropped in a button with an arrow next to it. Now from there, we went to the exec summary tab, went to the view menu, activated the bookmarks pane, and we added a bookmark named executive summary tied to this view. That was all it took. Then we went back to customer detail, clicked on this arrow button, turned on the action property, selected the bookmark type, and linked it straight to that executive summary bookmark that we just created. And final little spot check to test, control click that arrow, and it should take you right back to your exec summary. So there you go. Last step here is really just to make any last kind of tweaks or formatting adjustments. I added these lines here as visual separators to kind of break up the dashboard into clear and distinct sections. But again, the specific styling and formatting is totally up to you. So congratulations, you just wrapped up the final homework assignment in the course. Go ahead and save this workbook with pride as a completed version, and make sure to give yourself a little pat on the back, because that was a ton of work and we've built something that's really, really interesting and powerful. So there you have it. That officially wraps up our reporting section of the course. All right, so as you probably know, over the past year or so, Microsoft has been making some pretty incredible strides integrating artificial intelligence into tools like Power BI. Now, some of these tools, like Azure Machine Learning Models, or sentiment analysis, or text analytics, are currently only available to enterprise or premium capacity users, but the good news is that there are some great AI tools that are accessible to free or pro users as well. So what I want to do here is cover some of the AI-driven visuals that were recently introduced to Power BI Desktop. Now, important note, what you're looking at here is the December 2019 release. Make sure you've got a current version of Power BI so that you see these new visuals. If you're not sure, head to the upper left corner, jump into Help, About, and you should see the version number. So I'm on 276, which is the December 2019 release. Now, the first AI visual I want to talk about is the Q&A visual, which looks like a little call-out box or text box here. You'll see a little light bulb in the lower right corner. There are 3 visuals here that I'm showing with that light bulb. That indicates that it's an AI visual. So we're going to use our VentureWorks report here that we built throughout the course. Let's go ahead and clear this filter on our fields. Just want to work with a data model that we're already comfortable and familiar with. So first things first, we're going to add a new tab or page. Let's call it Q&A, nothing fancy. And here we go. We've got our blank canvas. There are 2 ways we can insert a Q&A visual. You can click the button just like any other chart, or if you go to the home menu, you'll see an Ask a Question option, which does the exact same thing. So let's go ahead and delete that duplicate. We can drag this out because this is the only thing we're going to be showing here. And the first thing you'll probably notice is that we have a question bar here and some suggestions to get started. So Microsoft is looking at our data model and offering some suggestions, things I might want to look at. So total cost by SKU category, total revenue by SKU category, top genders by year to date. You can show some more to kind of get a full list. Now, listen, I'm going to be honest with you guys. I very rarely will use these suggestions. They kind of feel like a shot in the dark. Sometimes you'll get some interesting suggestions, but in this case, we're not that interested in the SKU category. Some of these are just a little weird, like day of week over time. That really doesn't make much sense. But if you click on one, you can see kind of how this visual works, right? It populates the query, turns that query into a visual, and because this is an AI visual, you're not going to get the same chart type every time. Power BI is going to look at your query, it's going to interpret what you're asking and what you're looking for, and it's going to render the most appropriate visual to answer that question. So here we're looking at SKU category with total profit as our values. So let's go ahead and clear that out and ask a question of our own. Now what's important here is that we want to be able to ask a question the same way that we would speak to a friend, right? This visual wouldn't be very powerful or useful if we had to type the same way that we create a DAX measure, for instance, write things like AW underscore sales bracket. That's not natural language. That's not a natural query. So what we can do here is type the same way that we would speak, right? So maybe we want something like revenue by category. Press enter. We got a result. Granted, it's maybe not the one that we want, but Power BI recognized keywords in the query, which it underlined in blue, and it took a stab at rendering what it thinks we're looking for. So SKU category, and I can see with the tooltip that it is showing adjusted revenue. Not quite what we want here. The good news is we can click on that keyword and we can use a different suggestion. So in this case, we want total revenue, and instead of SKU category, we want the product category name. There we go. And now we get something a little bit more reasonable, right? We get bikes, accessories, clothing, and based on the tooltip, we're looking at that total revenue measure. So that looks great. Now, Power BI is pretty smart when it comes to this visual. So let's say that I was typing very quickly and I did something like this. Revenue by category name. Well, it gave me the correct results, same view that we just showed. And now what it's done is underlined that first term, revenue, in red, and it's saying, hey, we think you're probably trying to type revenue here. So we're going to show you the results for revenue by category name. Just like Google does, the autocorrect tool, Power BI is driven by, obviously, AI behind the scenes. And as part of that AI, it understands synonyms and corrections just like the one we're looking at here. So again, I can click in and I can say, yep, you know what? I want total revenue by category name. And boom, we're off and running. Now, this is really just scratching the surface of what this visual is capable of. This is a simple query, one measure, one column or dimension name. We can get a little bit more sophisticated than this. And we could do something like total revenue for red bikes. Okay? And because this query is designed to aggregate values to a single result, Power BI has displayed the answer or the result in the form of a card with one value, 4.87 million. If you're not sure, if you don't trust that that's right, we can go ahead and test that. We can add a card ourselves. Let's expand our filters. And in this card, we want to show that total revenue measure. And we want to filter it down for the bike category. There we go. And for the color, the product color, red. 4.87 million, boom, there we go. The Q&A visual did its job. It returned the proper result, which is actually pretty impressive when you consider the complexity of this query. We're looking for a measure, aggregated values, based on an attribute, red, which is a value in a dimension from one table, the product table, and also category equals bikes, which is a dimension from a second table, the product category table. So the fact that Power BI was able to interpret that instantly and render the proper result is actually pretty incredible. Now, we can take this a step further. Beauty of AI and machine learning is that you can train these models and train these tools to get smarter over time. So let me show you what that looks like. I'm going to click this gear icon here. This is going to open up this menu. Granted, this is a brand new visual. Things are changing and evolving, so you might not see this exact view. But basically, I've got three options here. I can review questions that have been asked in this visual. I can teach the Q&A visual to get smarter and understand new synonyms, and I can manage any custom terms or synonyms that I've defined. If you click this link here, you'll go to the official Microsoft documentation if you want to dig a little bit deeper. But let me show you how this works. Now, if I click review questions, I'm going to see a list of questions that have been asked in this visual. Now, you won't see any questions here if you've only interacted with the visual in Power BI Desktop. In order for this to work, you have to publish this to a workspace in the Power BI service environment, which we do cover in a separate course, Publishing the Power BI Service. So as a test, what I've done is upload or publish this report to a workspace in the service environment. I asked a bunch of questions inside of this visual, and they populated right here. So the important thing to note on this tab or this view is that any query that has a red underline or a keyword that Power BI didn't understand has this pencil icon where it says fix needed. And when I click that icon, it takes me to the Teach Q&A tab. It populates that query. And when I hit submit, what it's going to do is show me a preview of what the Q&A visual would return here on the right side. So in this case, a card with the value 24.91 million. And it also lets me define the term in red, the term that Power BI wasn't able to interpret. So in this case, I'm looking for product type, which isn't actually a column name or a field in my model, but I know that this user, because it was me, is actually looking for the category, right? Bikes, clothing, accessories. So what I can do is tell Power BI, hey, whenever you see someone type product type, what they really mean is category name. Okay, so I've just defined a new synonym, and watch this preview update. Boom, there you go. So now instead of the card, it's showing that bar chart with the breakdown by category name. So when I save that synonym, I've now made this visual smarter, and I can manage any terms that I've created right here in that last tab. So pretty cool stuff. If I close out of that dialog box now, and I head into our model tab, you'll see this kind of populate one other place, which is in the properties tab. So if we look at the category name inside of our category lookup table, there's this box called synonyms. Check it out. Category name, no space, category, and product type, which is the one that we just defined in the Q&A visual. So pretty cool stuff, pretty user-friendly. One last query that I want to show you. Let's say we do something like orders by order quantity. In this case, Power BI interpreted this as a line chart, but really we're not showing anything in a time series. We don't really want a line chart here. I think a bar or column chart would be a little bit more appropriate. So what we can do is convert this to a visual using this button here. Just turns it right into a line chart, and all we need to do is click and we can modify it, change the chart type, we can format this, we can filter it any way that we like, just like any other visual. So there you have it, pretty powerful stuff. That's the AI-driven Q&A visual. Hey everyone, so for this demo, I want to dive into another one of Power BI's AI-driven visuals called the Key Influencer visual. Now instead of applying this to our current AdventureWorks project, what I want to do is show you how we can use this visual to explore a new demo data set that's a little bit more appropriate for this kind of analysis. So what I've done here is create a new Power BI file. It's called Power BI AI Visuals, and you'll find a completed version of it as well. Both are available for download. You can follow along or just watch. Totally up to you. But the data set that we're working with here, there's one query in this file, and it's called Kickstarter Projects. Now, for anyone not familiar with Kickstarter, it's basically a platform where entrepreneurs can post projects or business ideas and try to get them funded from other users. So let's take a quick look at what we're dealing with here. I'm going to pop into the Data tab, and we have one record or one row for each project. We've got a unique project ID, project name. It's categorized into subcategories and categories. The goal amount is basically the target level of funding in order for the project to be successful. We know when that project launched, and ultimately we know what the outcome was. Was it successful? Did it fail? Is it currently live or in progress? That's what we have in this column here. And then we also know the number of backers, the number of people who pledged or supported the project. We know what country it came from. We know the total amount pledged in US dollars. And then we've got a year field here as well. So I've filtered this down to just 2017 projects. We've got about 40,000 records here in this table. But if you're interested, jump into Power Query. You'll see the full unfiltered data set, which is about 350,000 records. So you can play with the full one. You can cut it up different ways. Totally your call. So let's head back to our report view. And we're going to go ahead and insert the Key Influencers visual. Looks like this little, kind of like a lollipop chart looking thing with the AI light bulb in the corner. So let's drop it in. If you don't see that visual, make sure you've updated your Power BI desktop version. I'm on December 2019, so make sure you're current. And let's just stretch this out to take up almost our entire canvas. Now, here's the thing. Before we just start dragging and dropping all willy-nilly here, let's take a minute and understand what the purpose or goal of this visual really is, because this is not your average visual. Most chart types and templates like bar charts and pies and areas and histograms, whatever, they're designed to visualize concrete data. They just change the format, they bring it to life in a visual form. What the Key Influencers visual does is much more sophisticated. It actually helps us understand and expose the individual factors that drive some sort of an outcome. And that outcome could be categorical, like a project being successful or unsuccessful, like we have in this case, or maybe it's a customer review being positive or negative, or that outcome could be numerical or continuous, like determining what factors impact the price of a house or make the price of a house increase or decrease. That's what this visual is all about. And for anyone who wants to kind of dig deeper under the hood into the actual statistics and data science behind this. It's outside the scope of this course, but basically what we're working with here are regression models, either logistic regression for categorical variables or linear regression for numerical variables. Basically, the idea is to understand the dependence and the interrelationships and correlation between variables here in our table, and specifically how changes to some independent variables impact the predicted value of our outcome or our dependent variable. So, all right, that was a lot of words. I apologize, getting a little heavy there. Now let's start playing with this and see what this is all about. So we've selected our visual here, and we've got 3 different fields or wells that we can play with in the Visualizations tab: Analyze, Explain By, and Expand By. So Analyze is the outcome that we care about. So let's go ahead and start with that project outcome field, which is categorical. And as you can see, it says, all right, what influences project outcome to be failed, live, or successful? I want to see what impacts successful projects. So I'm going to select successful there. And now my next step is to drag fields into this explain by well based on basically any field that I think might influence this outcome. Okay, so if I think that country might be a factor here, I could just drag country, drop it in, and the visual updates. So we see a lot of information here. On the left side, we'll have a list of any key influencers, any factors that Power BI has deemed to be statistically significant and influential in impacting that outcome. In this case, we just have one. And then on the right side, we have visual representation of our entire data set for a given field. So we've got 5 countries in our data set: UK, US, Canada, France, and Australia. And Power BI has told us that there's one significant influencer here, which is that when the country is the United Kingdom, the likelihood of this project outcome being successful increases by 1.11 times, all else equal. Okay, and the way that that value or that factor is derived is by comparing the success rate or the project success outcome in the UK compared to the average country. So all other countries averaged out. So in the UK, for the 5,856 projects, 42% of those were successful. When we compare that against all other countries averaged out, we see that only 36.24% are successful otherwise. So quite an increase there, and that's why when country equals UK, that's identified as a key influencer. Now, note that we only have one influencer here in the list on the left, but we're seeing 5 countries here on the right. And that's because whether or not a value or a factor is noted as an influencer has to do with a number of things. For one, it has to do with the difference of success rate compared to the average. So for instance, US and Canada are very, very similar to the average. And it also has to do with volume. So you can see the count of Kickstarter projects. From France, only 979. From Australia, 1,500, compared to the US, which is almost 33,000. UK, which is almost 6,000. So those factors all go into this regression model behind the scenes in order to determine this list of key influencers. So at this point, we're only looking at one factor, country, but we obviously know that there are other things that determine if a project ends up being successful or not. So all we need to do is think about, okay, what other factors might possibly be influential here? And maybe category is a factor as well. So we can drag category in right next to our country. And now all of a sudden we see a totally new list of influencers here. In fact, that country equals US or UK influencer is now pushed way down to number 7 in the list. And we have these category influencers which are outweighing it significantly. So now we're actually seeing that when you factor in or consider country and category, the number 1 influencer is when the category equals comics, followed by dance projects, theater projects, music projects, and so on and so forth. And you can continue with this process. Right now we're looking at 2 categorical fields, but we could pull continuous or numerical fields in here as well, like the number of backers or the total amount pledged in US dollars. And now what you're seeing, kind of as you'd expect, are that these new fields we just pulled in are the new biggest or most influential factors. and it makes sense. The number one factor is that if you have a project that raised more than $4,968, you're almost 4 times more likely to have a successful project, all else equal. And that makes sense. Same story here with backers more than 100. Here's the thing. You raise more money, you get more backers, you're more likely for your project to hit its target. So that all is intuitive. That makes sense. And when we click on one of those factors that's based on a continuous field, what Power BI does here is it kind of bins those values, just like you would with a histogram, into different chunks. So more than 4968, between 2635 and 4968. You can kind of see how each of those bins of values compares to the average. If we had a clear linear relationship here, Power BI might plot this as a scatter plot with a line of best fit. But the one thing that's kind of missing to this point is that we're sorting by default based on the impact, these influence factors here. But what we don't know at first glance is, okay, this is an influential factor, but how much of the data set does it actually represent? Is it a large portion? Is it a very small piece? And what you can do is hover over these bubbles here, and it will tell you. So this influencer contains 25.38% of the data. This one contains 19%. This one down here contains under 1%. And what you can do to make this a little bit more clear is actually go into the format pane here, drill into the analysis options, and you can enable counts. And what that does, it's kind of subtle, but it adds that little ring around each of these bubbles, which represents the percentage. Right now it's based on an absolute percentage, so 25% actually looks like a quarter of the circle. You could change that to relative, which makes the largest factor 100% and then indexes all the other ones accordingly. Sometimes that can make it a little bit easier to see and interpret. And the last thing that actually does is it gives us an option here to sort either by impact, which we're doing by default, or we can sort by the count. And now we see that actually this factor here, which isn't a very big influencer, is a big piece of our data. It represents almost 26% of our data set. Now, last thing to cover really quickly here before we move on to the next demo, which is going to cover continuous variables, is this top segments tab. And what the top segments tab does is it actually runs a cluster analysis behind the scenes. And what Power BI is doing here is it's combining factors into segments or populations that seem to have a very high level of influence. So you can click on any of these to see more information about them. So segment 1 is defined as a segment where the number of backers is greater than 100 and the category is not games. Okay, so within that segment, almost 90% of those projects were successful. And that's compared to an average of only 37%. So a very, very influential, very successful segment that we've defined here. You can also see that it contains about 6,400 records, which is about 14.6% of our data. You can learn more and explore down here, but that's basically the idea. You can click through, see which types of segments Power BI is defining, and this can help you understand things like, who your target audience really is. Maybe you realize that middle-aged women in the Northwest are, your best customers, and you're really not resonating with men in the South. Those are the types of insights that this sort of segment analysis can really enable. So there you go. That's the key influencer visual, looking at a categorical outcome like we are here. In the next demo, we'll keep this example going, and instead of looking at a categorical outcome, we'll pull in a continuous variable there and check out some of the differences. Stay tuned. All right, so it's time for part 2 of our conversation about the Power BI Key Influencers visual. Remember that in part 1, we analyzed the impact to a categorical outcome. So what influences a Kickstarter project to be successful? Now we're going to run a very similar analysis, except we're going to use a continuous or numerical value for our outcome instead. So in our Power BI AI visuals file, I'm going to add a new page here. I'm going to call it Key Influencers Continuous. Now I'll just drop in a new instance of that Key Influencers visual, and we've got a nice blank slate to work with. So just like before, we're going to start by dragging a field into Analyze, but instead of using a categorical field like Project Outcome, This time I'm going to use a numerical or continuous field like amount pledged. So things look pretty similar here. The only difference is that now we're saying what influences amount pledged to either increase or decrease. Those are the standard options that we get with a continuous variable. Now, if you go into the Format tab and click into Analysis, you'll see that Power BI detected this as a continuous analysis type. You can override that if you want. I could say, no, this is categorical, and what we'll do is try to bucket every unique value in that field into its own category, which is utter nonsense. So in this case, it got it right. This is continuous, and we're left with that increase, decrease option. So the question that we're posing here is, what influences the amount pledged to increase, to go up? So let's start thinking about potentially influential factors here. We know that the number of backers is highly correlated, so we can pull that into the explain by well here. And check it out, we get this nice scatter plot with dots representing each project in the table. And we see this nice clear linear relationship between the number of backers on the x-axis and the amount pledged on the y, which makes sense. You have more backers raise more money, and we get that nice upward sloping line. This is a linear regression model, and the slope of this line is what allows us to determine these factors and these influencers. So what we're saying is that when the number of backers goes up by 946, the average amount pledged increases by about $109,000. Now, here's where things get a little bit interesting, which is that by default, when you pull a continuous variable into the Analyze field, you're going to see Don't Summarize. And what that means is that Power BI is going to run this analysis at the table level of granularity. And what I mean by that is that the level of granularity in our source table is at the project level. Each row, each record represents one project. That's why we see each dot in the scatter plot represent one single project. But what if this is just too granular for me to even make sense of or generate insights that I can use to optimize my business? What if I actually want to see the relationship between backers and amount pledged at a higher level, like by category or country or subcategory? Well, I can use the expand by option to do that. What we can do is aggregate these values for both amount pledged and the number of backers. I could choose average here instead, or I could take a measure. In this case, we've defined average amount pledged as the average amount pledged. Makes sense. We could use a measure here instead, same exact thing, and we can choose an aggregation for our explain by fields as well. So let's choose average for both, and now what we're going to do is determine the level of granularity that we want by pulling a field into this expand by well. So if we want to see the relationship between the average backers and average amount pledged by category, we just grab category, pull it in here, and look at this. We get that same scatter plot, but now each dot no longer represents a project, each dot represents a category. So the way to interpret this tooltip here is that on average, projects in the games category have 343 backers and have raised about $25,500. Same goes here with design projects, with technology projects, and so on. So now on average, for an average project, when you get 89 more backers, you can expect to raise $1.85 thousand more dollars. That's just a way to run a very similar analysis, but explore things at a different level of granularity. And when we pull a field into expand by, what we're doing is determining that granularity without treating it as an influencer, which is what we'd be doing if we pulled that in here instead. So there you have it. That's how you can use Power BI's key influencer visual to explore or predict a continuous outcome. All right, so as we talk more about AI and machine learning and statistical modeling, it's important to remember that these tools can be incredibly powerful when they're used appropriately, but incredibly dangerous when they aren't. Now, the thing about tools like this key influencer visual here is that they're great because they help make machine learning accessible to everyday users, but a little scary because those same users often lack the foundational knowledge to understand what's happening behind the curtain and how to properly interpret the results or make intelligent decisions based on them. So speaking of interpreting results, I think this is a good time to take a step back, take a pause, and review one of the most important rules in statistics and analytics. Correlation does not imply causation. Now, I'm sure many of you have heard this before, especially if you work in data or analytics, but let's take 2 minutes and break this down. Correlation is when two variables, x and y, move together, kind of like this. They move in the same direction. Causation, on the other hand, is when variable x causes variable y. In other words, there's a clear cause and effect relationship here. Now, what if I were to show you a scatter plot like this? We're plotting violent crime rate on the y-axis and some mystery variable on the x. And based on this 25, 30 observations here, we've got a very tight correlation, pretty clear linear relationship between the two variables. So clearly they move in the same direction, clearly they're correlated, but you might be tempted to think, that this x-axis variable is the driver behind violent crimes. It's causing violent crimes, and that if only we could cut back on whatever this variable is, we might be able to make our streets safer. The problem with that is that we're looking at ice cream cones sold. And you may be scratching your head, you may be a little confused, and that's totally understandable because the human brain is biased to look for cause and effect relationships where in fact they don't exist. So if you're still wondering kind of what's going on here and how this could possibly be true, here's a hint. Our y-axis, violent crime rate, could just as easily be drowning deaths, or forest fires, or even your dreaded crab attack. So think about what those things have in common, and you'll probably start to realize that this has nothing to do with ice cream at all, and everything to do with temperature. As temperatures rise, you have more people out later, gathering in public spaces. As a result, crime rates increase. You also have more people going to the beach and swimming in the ocean, so drowning deaths increase, and so on and so forth. So because ice cream sales are such a close proxy to temperature, we've created a false narrative that paints a completely misleading story. So key takeaways here: ice cream does not turn you into a violent criminal, it does not make you drown, it does not start forest fires, and it certainly does not encourage crabs to attack you. Now, obviously, these are silly examples here, but the core principle, the concept, holds true, and it's a really important one to keep in mind. I'll leave you with one kind of more real-world business case here. Should be a scenario like this. Maybe you run a startup, you've been live for about 4 months, and you're plotting your weekly marketing spend, which you've been ramping up, against your total revenue. Now, if you were to imply causation based on this chart, these results here, you might think that ramping up your marketing spend is a surefire way to drive more revenue. And that may be the case, it may be true, but it also may not. So the idea is you've got to think about the other factors that might be at play here. Maybe over this 3 or 4 month period, you've also been ramping up a new sales team, or maybe your organic traffic has been growing due to referrals or PR or something like that. So bottom line here, be thoughtful about how you interpret these results, and please use caution before you make big decisions based on these findings. All right, it's time to talk about my all-time favorite AI visual in Power BI, the decomposition tree. Now, this one's still a preview feature, so you're going to want to make sure you have the latest version of Power BI Desktop installed, and once you open it up, you're going to need to head to your Options and Settings, open up the Options window, and then what you can do is drill into your preview features, just give that checkbox a check where it says Decomposition Tree Visual, and press OK. So you'll probably be prompted to restart Power BI. Go ahead and do that, and you'll see this nice little icon here. Kind of looks like a flow chart or a process diagram with that AI light bulb. That's our decomposition tree. So if you'd like to follow along with me, go ahead and open up the AI visuals file, and we're going to create a new page here called Decomposition Tree. So let's go ahead and give it a click, drop it onto our canvas, resize things a bit. Looks good. Now, you know me, before we start tinkering, I always think it's important to talk about the why. So why are we using this visual? What's the objective? And what I love about the decomposition tree is that it's great for ad hoc data exploration. It's a great way to understand how your data is distributed, and it's an excellent tool for root cause analysis. And what I love about it is that it's smart, it's intelligent, it's AI driven, but it's also really intuitive and really user friendly. So let's go ahead and give it a click, and you'll see kind of two fields that should look familiar from our key influencers visual. We've got an analyze well and an explain by well. So what's important to note is that anything we pull in the analyze field here needs to be a quantitative metric. So we can pull a categorical field in here like project outcome, but it's going to get aggregated either as a count or a distinct count. So really what this visual is designed for is for continuous or quantitative fields. Things like the amount pledged in US dollars, for instance. You can see that by default, this was aggregated to a sum, which in this case makes sense. So not really impressive quite yet, right? We've got a little bar here showing the total amount pledged, 544 million. Now, where it gets interesting is when we start populating the explain by fields. And think of these explain by fields as the ways that we'd like to break down these dollar amounts, this amount pledged. So I kind of like to think about this like a hierarchy, right? Where I want to break things down at a high level, maybe like category first, and then a little bit deeper like subcategory, and then we'll go all the way down to the project name. And you can actually drop these in any order. It's just kind of the way that I think about it in my head. And you'll notice nothing really changed here except this tiny little plus icon appeared, which was so subtle that you might have missed. But what that does is allows us to build our decomposition tree. And we've got two options here with light bulbs. These are the AI-driven options where we can find out what makes our metric the highest or the lowest, or we can manually select one of the fields that we dragged in ourselves. So I'm going to start there because it's really clear, really intuitive, and also a really powerful option. So I'm going to take my amount pledged, I'm going to break it down by category. Boom, there you go. Instantly, I can see that games, design, and technology products make up the bulk of my amount raised or amount pledged. There's a big drop off before film and video, publishing, and then I can actually scroll down a bit to see dance here at the bottom. So from here, I can keep building my tree. I can select any one of these nodes and break it down at another level, so subcategory, for instance. Here we go, within games, tabletop games, clearly the biggest driver here. And let's drill one level deeper to project name. And there you have it. We've built a decomposition tree in about 30 seconds, and it looks great. And check this out, it's totally interactive. You can select any of these nodes, totally dynamic. You can see exactly how your data is distributed, where you'll find the bulk of the volume. It's just a great, very user-friendly tool. And honestly, if they left it at that, it would still be a pretty valuable addition to the visualizations pane. But where it gets really cool is with the AI features. So let's close those out, and let's go back to our plus sign. Now what if we choose the AI-driven high value? Okay, we see the same result that we did manually, pulled in the category field, and it's showing games at the top. Same order here, kind of descending in volume. Now, what we didn't really realize happened is that Power BI looked at all of the available fields in order to find the one field with the biggest chunk of volume. That happened to be category with games here, which drove $144 million. But if, for instance, we had country as well, now all of a sudden US is the top driver. And it's really just based on the ratio of that 454 million out of the total, and that's what determines the rankings here, as well as which field was selected to be displayed. And that's nice, but it's not really artificial intelligence. It's not that smart or that impressive. But where it gets more interesting is if we go into our formatting pane, drill into analysis, you can see that by default, the analysis type is absolute. In other words, it's based on volume. That's why we see always the kind of descending by volume. We see the biggest categories pop up first. If we change this to relative, watch what happens. Everything changed. Now that AI-driven high value is showing project name, which is the lowest, most granular field that we have. And it's showing this top project, the 7th continent, as the biggest relative factor. that contributes to the amount pledged. So the simplest way to explain kind of the rationale here is that basically Power BI is saying, okay, given all of the project names, what would I expect a project to drive in terms of pledge amount? In other words, it's the average across all projects in the entire table. And the reason why this project here, the seventh continent, is appearing at the top and why project name is appearing at all is because the difference between what this project drove and the average among all projects, that difference was bigger than any other difference in the data set. It's bigger than what the US drove as opposed to the average among all countries, and it's bigger than what games drove compared to the average among all categories. And that's why AI has determined that project name should appear here, and why the seventh continent is technically the biggest relative driver towards the amount pledged. So really interesting findings here that would be very tough to kind of realize without doing some pretty heavy analysis on your own. So with that, let's go ahead and clear that out. I'm going to kind of recreate that initial tree that we built because I think it's a pretty helpful one. Category, subcategory, and project name. Note that if you hover over the headers here, you can lock specific categories. So if you always want to start at the category level, but you'd like users to be able to rearrange these or pull them out, you can go ahead and lock one category or one column here of your tree, but leave the others flexible. Now, last thing I'll call out here that makes these visuals so great is that you can treat them just like any other visuals. You can format them. In fact, Microsoft just released a lot of new formatting options for this decomposition tree visual specifically. So you can change the look of your data bars if you want. You can change the connector lines, all sorts of formatting options here. And perhaps the best thing of all is that you can filter and cross-filter these visuals based on things like slicers or other visuals in your report. So check this out. It's as simple as dropping in a map, for instance, or let's use a filled map here. Pull country in, and now check it out. Our decomposition tree is now dynamic. It's tied to our map. We can look at the UK, we can look at France, we can look at Canada or the US, and everything updates dynamically. Again, really powerful tool when it comes to ad hoc data exploration, data distribution, and root cause analysis. So there you have it, the new AI-driven decomposition tree visual.